In this video, I'm going to show you how you can use a scientific calculator to determine the equation of the least squares regression line. That is, y is equals to a plus bx. Let me brief you in on our problem statement. A mathematics teacher wants to make an unbiased prediction of a grade 11 learner's final marks. She uses the SBA mark and knows the final mark. The results are as follows. So this is the x values and this is the y. We're using the SBA mark to predict the final mark. In question 1.1, we're supposed to draw a scatter plot for the data, but we're just going to go ahead and start with 1.2. In 1.2, we're supposed to calculate the correlation coefficient for the data, that is R. Let me show you how we can do that with a calculator. You want to press mode or setup, and then you want to go to start. Here in this calculator, it's option number 3. So I'm going to press 3. After pressing 3, I'm going to go to the equation for the least squares regression line. That is a plus bx. You can see here that it is option number 2. On a different calculator, it might be a different option, maybe option number 3, but the steps are identical. Now I just have to punch in my x values. As you can see, the first x values I have 42, followed by 35, 69, 62, 83, and 75. But then my x values are still carrying on. I have 48, 72, 57, 25, 65 and 68. You have to verify your entries at least 2 times, because if you entered a number incorrectly, then your answers are going to be incorrect. So now let's put in the y values. We have 51, 43, 76. You don't just put the y values randomly, you put it close to its x value, right? And 72. Let's go to the other column. We have 59, 85, 63, 35, 59, and 75. Yeah, there we go. We have our data inserted on our calculator. We're going to press equals to a couple of times, and we're going to press AC. After pressing AC, you press Shift and 1. You can see above 1 that it says stat or distribution there. So we're going to press Shift and then press 1. We are interested in the least regression line. So we're going to press the option that says REG, just short for regression. So here it is option 5. In your calculator it might be different, but it doesn't matter. So I'm going to press 5. After pressing 5, you're going to see that I have A, B, R, X, and Y. So I'm going to press number 3 because I want to find the correlation coefficient. I get 0.94. So the value of R is 0.94. And then now I can move to 1.3. The question is saying, is the SBA mark a reliable predictor of the final mark? Provide a reason for your answer. Obviously, it is a reliable predictor of the final mark because we can see that we have a very high correlation of 0.94. Let's move to the next question, 1.4. Determine the equation of the least squares regression line. Like I've said, we have y being equals to a plus bx. So we just need to find the value of a and the value of b using our calculator. So let's go ahead and do that. Again, we're going to press AC, Shift, and 1. We're going to go to number 5, regression. And now we're looking for A. So we're going to press 1. And A is equals to, let me just write that down. A is equals to 14.49. That is the value of A. Now we just need the value of B, and we have our equation for the regression line. AC, Shift, 1, and 5 regression. I press 2 and we have our value of b. B is equals to 0.86 if we round it off to 2 decimal places. So the equation y is equals to 14.49 plus 0.86x. That is the answer to 1.4. Let's look at 1.5. Predict Toby's final mark if his SBA mark was 66%. So we just need to substitute 66 into our equation. We're going to have y being equals to 14.49 plus 0.86 multiplied by 66. Let me just go ahead and do that using my calculator. I'm getting 71.25. So that will most likely be Toby's final mark if his SBA mark is 66%. This set of data has a mean of 7. There's one interesting thing about this data. We have a variable y. Let's look at the first question, 2.1.1. We are given the mean and the question is saying that we must find the value of y. So we can easily say that x bar is equals to the sum of all the data points divided by the number of the data points. So that will give us 3 plus 4 plus 4 plus 4 again plus 6 plus 10 plus 12 plus 12 plus y divided by the number of data points. How many data points do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are dividing by 9. But we know the mean. The mean is 7. So we have 7 being equals to. Now we need to add all those constants, 3 plus 4 plus 4 up until the last term. If we do that, we're going to get 55 plus y divided by 9. We can go ahead and cross multiply. 7 multiplied by 7, that is 49, plus 7, 56, plus 7, 63. So we have 63 being equals to 55 plus y. It will be easy to see now that y is equals to 8. Let's go ahead and do 2.1.2. We're looking for the median of this set of data points. So let me just uncover our data points. In order for us to find the median, we need to arrange our data from the smallest to the highest. So if we do that, we're going to have 3 and then 4, 4, 4. After that, we have 6. We know that y is 8. So y is here between 6 and 10. And then we have 12, 12. The median is the data point in the middle of our data set when we have arranged it from the lowest to the highest. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Our median should be the 5th term, so that is 6. We can conclude here and say that the median is equals to 6. On the left of 6, we have 4 numbers, and on the right of 6, we have 4 numbers. So 6 is our median. We actually do have a formula for finding the position of the median. We can say that the median is equals to n plus 1 divided by 2. In our case, n is 9. We have 9 terms. So that is 9 plus 1 divided by 2, which is equals to 5. So our median, if we have 9 data points, will be on the 5th position. That is how you can find the position of the median if you have a completely different data set. 2.2.1, 2 additional numbers, 7 minus n, and 7 plus n are added to the data set. Calculate the mean of these 11 numbers. So a lot of people will probably think that this question is difficult, but it is not. These variables are going to cancel each other. We have minus n and plus n. So the fact that there is now another variable shouldn't be worrying. We can say that the mean is equals to. We know fully well that before introducing these 2 additional numbers, the sum was 63. So now we can just simply say that 63 plus 7 minus n plus 7 plus n divided by. Now we no longer have 9 terms, but we have 11. As you can see, minus n and plus n are going to cancel out. So the mean is just equals to 63 plus 7, 70 plus another 7, 77 divided by 11. That is just equals to 7. So our mean is 7. 2.2.2. Determine the standard deviation if the data points that are within one standard deviation of the mean lie in the interval x is between or equals to 11 and 3. This means that x bar plus standard deviation is equals to 11 and x bar minus standard deviation is equals to 3. That is the interval for one standard deviation of the mean. We can break it down like this. If we did say the 2 standard deviation of the mean, then we would just put a constant of 2 here. But then now we're just interested in 1 standard deviation of the mean. So we can use either equation. We're going to get to the same answer. Let's use the second one. So x bar, we know that it is 7. So we have 7 minus the standard deviation being equals to 3. It should be easy to see that the standard deviation is equals to 4. Can we find the equation of line BD if we are given the equation of line AC? Yes, we can. The equation of line AC is given by minus 1 divided by 2x plus 2. AC is perpendicular BD. That should tell us that the gradient of AC multiplied by the gradient of BD is equals to minus 1. So the gradient of BD will be equals to minus 1 divided by the gradient of AC. From the equation, we know that the gradient of AC is minus 1 divided by 2. So we divide in minus 1 by minus 1 divided by 2. The gradient of BD will be equals to 2. So now we know that for BD, y is equals to mx plus c, but the gradient is 2. So we have 2x plus c. All we need to do is substitute a point on our line BD and find the value of c. Just like that, we're going to have the equation of BD. We are given the coordinates of B, so let's go ahead and substitute that into our equation. We're going to have minus 7 being equals to 2 multiplied by minus 2 plus c. Minus 3 is equals to c. So now we can say that the equation of BD, we have 2x minus 3. Let's move to the following equation, 3.2. We are supposed to find the coordinates of E. E is the point where AC intersects BD. This is a very common type of question. You shouldn't be getting this wrong. What are we going to do in a case like this? We're going to equate the equation of BD and the equation of AC. If we do that, we're going to have 2x minus 3 being equals to minus a half divided by 2x plus 2. We're going to find the x value of E and substitute it into either the equation of AC or the equation of BD. So minus 1 divided by 2x, if we take that to the left-hand side, we're going to have 5 divided by 2x being equals to. Minus 3 to the right-hand side, we have 2 plus 3. So this is equals to 5. So x is equals to 5 multiplied by 2 divided by 5. X is equals to 2. So that is the x coordinate at E. Let's substitute 2 into 2x minus 3. If we do that, we're going to have y being equals to 2 multiplied by 2 minus 3. This is just equals to 1. So the coordinates of E, we have x being equals to 2 and y being equals to 1. That is 3.2. Let's do 3.3. If the ratio CE is to EA is equals to 1 is to 3, determine the coordinates of A. That is not too difficult. Let's see what we can do. So E is to C and A is to E. We have 1 is to 3. So let's play around with these numbers. The coordinates of E, we have 2 and 1. We want to find the coordinates of A. X of C is 4 and X of E is how much? It is 2. What will be X of A? From X of C to X of E, we moved 2 units to the left. Our ratio is 1 is to 3. If we move 2 units to the left, then from X of E to X of A, we need to move 2 units to the left multiplied by 3. So we have 2 minus 6, which is minus 4. So that is how we can find the X value of A. And then now let's do the same for the Y values. The Y value of C is 0. What is the Y value of E? The Y value of E is 1. And our ratio is still 1 is to 3. Now we're looking for the Y value at A. From Y of C to Y of E, we moved 1 unit upwards. So from Y of E to Y of A, we're going to move 1 multiplied by 3. So that is 1 plus 3, which is equals to 4. So this is the Y coordinate of A. So the coordinates of A, we have minus 4 and positive 4. Our answer to 3.3. 3.4. Kite PQRS is obtained after the measurements of kite ABCD is enlarged by a scale factor 2. Calculate the area of kite PQRS. Right, let's calculate the area of kite ABCD first. And then we're going to multiply it by a factor of 2 to get the area of kite PQRS. So I'm going to erase all this. BC is equals to DC. That is a property of a kite. We don't have to think very hard about that. It's either you know it or you don't. And then AB is equals to AD. So what we can do, we can calculate the area of one triangle. After calculating the area of one triangle, we just multiply it by 2 to get the area of ABCD, because these two triangles ABC and ADC are equals to each other. The area of triangle ABC will be equals to half base. Our base is AC multiplied by our height, which is BE. We need to calculate the length of AC and the length of BE. What is the length of AC? AC will be equals to the square root of y2 minus y1 squared plus x2 minus x1 squared. Let's take our point A as our second point. Let's not forget, here we have coordinates minus 4 and 4. So x2 will be minus 4 and x1 will be 4. So we're going to have minus 4 squared plus y2. y2 is going to be 4 and y1 is 0. AC is equals to 4 square root of 5. Now let's calculate BE. BE will be equals to the square root of, we're looking at BE. Let's take E as our second point. So the coordinates of E, we have 2 and 1. Let's not forget. So y2 is 1 minus y1, which is minus 7. So we have plus 7 squared. Plus x2. x2 is 2 minus x1 minus 2. So we have 2 plus 2 squared. If you put that in your calculator, you're going to get 4 square root of 5. So the area of our triangle ABC is equals to a half multiplied by 4 square root of 5, square root of 5, not square root of 2, multiplied by 4 square root of 5. So now it's just a matter of putting that in your calculator, and we are getting 40. So the area of our kite A, B, C, D will be equals to 40 multiplied by 2, which is 80. And now the area of our kite PQRS will be equals to 80 multiplied by 4 and not 2. This is equals to 320 units squared. Determine the numerical value of m. We are given n, the center of the circle, and that's where we have our variable m. Another information that we're given is the coordinates of r and s, together with the radius of our circle. It is said to be 17 units. So we can go ahead and try setting up an equation for our circle in the form x minus a squared plus y minus b squared being equals to r squared. So we're going to have x minus the x value of our center, which is 2. So we have x minus 2 squared plus y minus the y value at the center of our circle, that is m. We square that, and this is equals to the radius squared. The radius is 17 units, so we're going to have 17 units squared. As you can see, if we substitute a point on our circle, then we're going to easily find the value of m, because we're going to have a value of x and its corresponding y value. The only variable that we're going to have is m. So we can either substitute the coordinates of r or the coordinates of s and get the value of m. The coordinates of r, minus 13 and 5. If we go ahead and substitute that, we're going to have minus 13 minus 2 squared plus 5 minus m squared being equals to 17 squared. Minus 13 minus 2, that is minus 15 squared, plus 5 minus m squared. 5 times 5 is 25. 5 multiplied by minus m is minus 5m. You multiply that by 2, you get minus 10m. And then minus m multiplied by minus m, that is plus m squared. This is all equals to 17 squared. So we're going to have m squared minus 10m plus 25 plus minus 15 squared minus 17 squared being equals to 0. So we're going to have m squared minus 10m minus 39 being equals to 0. So we're factorizing this equation here. The question to ask ourselves, which two numbers do we multiply and get minus 39? But when we add them, we get minus 10. That is minus 13 and plus 3. So we're going to have m minus 13 multiplied by m plus 3 being equals to 0. M is equals to 13 or m is equals to minus 3. Let's look at m and its position and see what makes sense. M is the y coordinate in the first, second, third, fourth. In the fourth quadrant, y is negative. So the answer we're going to take is that m is equals to minus 3. It is not equals to 13. Right, so that is the value of m. The question that follows, we're supposed to determine the equation of the circle in the form x minus a squared plus y minus b squared is equals to r squared. We have all we need to set up this equation. We're going to have x minus 2 squared plus y minus 3. So it is just y plus 3 squared being equals to r squared. We know that our radius is 17 units. So we're going to have 17 squared. What is 17 squared? That is 289. So instead of writing 17 squared, we can write 289. So let me just do that instead. We have 289. And this is the equation of our circle. Let's go to 4.1.2. Determine the gradients of NR. So let's go ahead and look at NR. We have the coordinates of R and we have the coordinates of N. So it will be pretty much straightforward. So NR will be equals to, let's say, y of R minus y of N divided by x of R minus x of N. So what is y of R? That is 5. And y of N is the value of M, which is minus 3. Everything divided by x of R, which is minus 13, minus x of N, which is 2. NR is equals to 8 divided by minus 15. And just like that, we have the gradient of NR. Let's go to the question that follows. B. We're supposed to find the gradient of NS. This is too good to be true. How can we find the gradient of NR? And then after doing that, we find in the gradient of NS. Something seems fishy, but we're going to find out soon. NS, do we have the coordinates of S? Yes, we do. Here they are. They're given to us in our problem statement. So we're going to have y of S minus y of N divided by x of S minus x of N. What is y of S? That is minus 11 minus y of N, which is minus 3. Everything divided by x of S. X of S is minus 13 minus x of N, which is 2. On the numerator, we have minus 8, and on the denominator, we have minus 15. So this is just equals to 8 divided by 15. We have the gradients of NR and that of NS. The question that follows, 4.1.3. The tangents at S and R intersect at P. Calculate the size of P2. 6 marks. So maybe we're calculating the gradients of NR and NS so that we can answer 4.1.3. Because without us calculating the gradients of NR and NS previously, 4.1.3 probably has a 9 or 10 marks. So it makes sense that we had to calculate the gradients of NR and NS so that we can use them to then find the size of angle P2. Let's see how we can actually do that. So P2 is this angle here. Let's just highlight it so that it is clear to see. We have the gradients of NS and that of NR. PS and PR are tangents, and the tangents are perpendicular to the radius. So if we have the gradients of NR and NS, we have the gradients of PS and PR. If we have the gradient of PR, we can find the inclination. Let's call that inclination K. So we have this angle here. Well, not of yet, but we know fully well that it is quite easy to find the size of that angle. And then we have the gradient of line PS. So it will also be easy to find the size of this angle, the inclination. Let's call it Q. But if the inclination of PR is K, then this angle right here should also be equals to K, a vertically opposite angle. So we can say that Q is equals to K plus P1. An exterior angle of a triangle is equals to the sum of the interior opposite. So if we find Q, which we have enough information to do, and we find K, then we can find P1. And if we find P1, we're going to use the sum of angles on a straight line to find P2. So let's start with K. Let's see how we can find the size of angle K. We know fully well that the gradient of NR, what is the gradient of NR again? It is minus 8 divided by 15. We want to use it to find the gradient of PR. So the gradient of PR multiplied by the gradient of NR should give you NR should give you -1. Why are we saying that? The radius is always perpendicular to the tangent. So now we can say that the gradient of PR is equals to -1 divided by -8 divided by 15. This is just equals to -1 multiplied by 15 divided by -8. So the gradient of PR is 15 divided by 8. So let's go ahead and find the value of K, the inclination of PR. So we can say that tan K is equals to the gradient. So our angle K is equals to tan inverse of 15 divided by 8. And if you do that, you should get 61.93 degrees as the size of angle K. So now we have angle K. Let's go ahead and find the size of angle P. So the gradient of PS, will be equals to -1 divided by the gradient of NS. The gradient of NS is 8 divided by 15. So the gradient of PS will be -15 divided by 8. So Q, angle Q, will be equals to tan inverse of -15 divided by 8. This is -61.93. If we have a negative, we can just simply add 180 to find the angle of inclination. We're going to get 118.07 degrees. So now we have Q. Let's not forget, our point is so that we can say Q is equals to K plus P1. Q is 118.07. And what is the value of K? We just calculated it above. That is 61.93. So 61.93 plus P1. P1 should be equals to 118.07 minus 61.93. If you put that in your calculator, you're going to get 56.14 degrees. But then that's not it. We're not looking for P1. We're looking for P2. So P2 will be equals to 180 minus 56.14, and that is 123.86 degrees. Yeah, it is a long and painful exercise, but we have to do what we have to do. So that is 4.1.3. Let's go ahead and do 4.1.4. 4.1.4. Circle N is reflected about the x-axis and then translated 2 units upwards to obtain circle M. Determine the equation of circle M in the form x minus c squared plus y minus d squared is equals to r squared. Okay, we have a few translations here. Let's go ahead and look at the first one. So reflection about the x-axis. You just put a negative sign on the y value. So the coordinates of n were 2 and -3. If we reflect about the x-axis, we're going to get 2 and +3, because minus multiplied by -3 should be +3. So that is our reflection. And now we need our translation, 2 units upwards. So 2 units upwards. How will that affect our equation? Now we have 2 and 3. We need to move 2 units upwards. From +3, if we move 2 units upwards, then we're going to have 2 and 5. If we moved 2 units upwards before the reflection about the x-axis, we were going to have 2 minus 1. But we're reflecting about the x-axis first before our translation. Hence, we have 2 and 5 as the coordinates of our center. Now let's just conclude by setting up our equation. We have x minus 2 squared plus y minus 5 squared being equals to r squared. Nothing was said about the radius, so I'm assuming it's still the same, 289. 4.1.4. Let's move to 4.2. An infinite number of circles, each touching the next, are drawn between O and C. Let's just go ahead and highlight that. We have O at our center and C there. And then the centers of all the circles lie on the negative x-axis. The radius of the largest circle centered at A is 4 units. And the radius of each circle thereafter is halved. B is a point on the largest circle. 4.2.1 show that OC is equals to 16 units. We're supposed to show that OC is equals to 16 units. The first circle has a radius of 4 and a diameter of 8. And then the next circle will have a radius of 2 and a diameter of 4. And then we're going to have plus 2, plus 1, so on and so on until we reach infinity. So what I'm realizing here is that our first term is 8 and our ratio is 1 divided by 2 because the radiuses of our circle are getting halved. So if we have infinity circles between O and C, then we can simply say that the sum to infinity is equals to A divided by 1 minus R. A being the diameter of the first circle, that is 8, and we divide that by 1 minus the ratio. The radiuses are getting halved, so we have 1 divided by 2, and this is equals to 16. So indeed, the value of OC is 16 units. Let's move ahead and do 4.2.2. If BC is a tangent to circle A at B, write down the size of angle ABC, providing a reason for your answer. If BC, let's just join BC so that we can have a bit of clarity. So yeah, we need BC. Let's go ahead and just join those 2 points. BC is a tangent, AB is a radius. We know that the radius is perpendicular to the tangent. So that is to say that the size of angle ABC is 90 degrees because the tangent is perpendicular the radius. 4.2.3, hence determine tan of angle C. So we're looking for tan of this angle right here. Well, now we have a right angle triangle. This angle here is 90. So AC is our hypotenuse. Tan of theta is equals to the opposite divided by the adjacent. So the opposite is AB. So what is AB? AB is equals to 4 units. That is our radius. And what about AC? AC is equals to OC minus OA, right? OC is 16 units, OA is 4 units. So AC is equals to 12 units. AB is our opposite, AC is our hypotenuse. We need to find BC, our adjacent. Let's go ahead and do that and see what we're going to have. We can say that AC squared is equals to AB squared plus BC squared. AC, that will be 12 squared, being equals to AB 4 squared plus BC squared. So it should be easy to see that BC is equals to the square root of 144 minus 16. This is equals to 8 square root of 2. So now we can say that tan of angle C is equals to the opposite. The opposite is 4 units divided by the adjacent, which is 8 square root of 2. We can further simplify that, but let's just leave it like that. And 4.2.4, the last question, we're looking for the equation of BC. Angle C is the inclination of line BC. So this is the gradient of the line BC. So now we can say that y is equals to mx plus c, but we know the value of m. It is 4 divided by 8 square root of 2x plus c. We just need to substitute a point and we have the equation of BC. Which point can we substitute? We can substitute point C, because we know that at C, the x-coordinate is minus 16 and the y-coordinate is 0. So if we substitute that, we're going to get 0 being equals to 4 divided by 8 square root of 2 multiplied by minus 16 plus C. So C will be equals to 4 square root of 2. And now we can conclude and say that the equation of BC, 4 divided by 8 square root of 2x plus 4 square root of 2. Tan of theta is equals to the opposite divided by the adjacent, where most of the time the opposite is y and the adjacent is x. So in our case here, we're going to have tan of alpha being equals to y divided by x. What is the value of y? Let's look at tan of alpha. We can see that the y value is 4 and the x value is 3. So we're going to have 4 divided by 3 as tan of alpha. Let's move to the equation that follows. 5.1.2. Determine the value of sine of 90 degrees plus alpha. Sine of 90 plus alpha will be equals to cos of alpha. Now we just need to figure out what cos of alpha is equals to. Cos of theta is equals to the adjacent divided by the hypotenuse. The adjacent usually being x and the hypotenuse is obviously r. So we have the value of x. X is equals to 3, but we need the hypotenuse. We can say that r squared is equals to x squared plus y squared. So r will be equals to 3 squared plus 4 squared. R is equals to 5. So now it is easy to see that cos of alpha is equals to the adjacent, which is 3, divided by the hypotenuse, which is 5. That is 5.1.2. Let's look at 5.1.3. Determine the values of m if it is given that 12 plus 13 sine of v is equals to 0. So we're looking for this value here of m on our coordinates r. On our coordinate r, we are using angle v, as we can clearly see. What do we have? We have 12 plus 13 sine of v being equals to 0. So sine of v will be equals to minus 12 divided by 13. But we know that sine is equals to the opposite divided by the hypotenuse. The opposite is usually y and the hypotenuse is r, obviously. From our coordinate r, we have the y value, which is minus 12, and we have the hypotenuse, which is 13. We are looking for m. So we can set up our equation in the following way. R squared is equals to x squared plus y squared. Like for us, we have r. So we're going to have 13 squared being equals to m squared plus y squared. That is minus 12 squared. We're going to have m squared being equals to 13 squared minus 12 squared. M squared is equals to 25. So it's either m is equals to 5 or m is equals to minus 5. What makes sense between the two values? X is negative in the third quadrant. So m cannot be equals to 5. M is equals to minus 5. So that is 5.1.3. Let's do 5.1.4. Determine the value of cos of alpha plus b. This is a compound angle. We can expand this in the following way. Cos of alpha multiplied by cos of v minus sine of alpha multiplied by sine of v. We know what cos of alpha is equals to from 5.1.2. It is 3 divided by 5 multiplied by cos of v. Cos is x divided by the hypotenuse. X in our case is the value of m if we are looking at angle v. That is minus 5. And the hypotenuse is 13. So we have that there. Minus sine of alpha. Sine is opposite, which is y. What is the value of y at point P? That is 4. Divided by our hypotenuse, which is 5. Multiplied by sine of v. The value of y at r, that is minus 12. Divided by the hypotenuse, which is equals to 13. This is equals to 33 divided by 65. Determine the values of a and b. We have f of x, which is equals to a sine of x. And we have g of x, which is equals to cos bx. So we're looking for the value of a. How can we simply determine the value of a? We can look at the highest point of our graph, f of x, because that is what a determines. It controls that highest value, the amplitude. So here in our graph, it is easy to see that the highest point that f reaches, f of x, is 2. So we can say that a is equals to 2. And now let's look at g of x. We are interested in the value of b. If you look at the graph, if you look at the sketch, the diagram we have, you're going to realize that we have an original cosine graph. This graph, g of x, it is just equals to cos of x. There's no alterations whatsoever. So the value of b in g of x should be equals to 1, because that is just the shape of cos of x. So what are we saying? We're saying that a is equals to 2 and b is equals to 1. That is 6.1. Let's look at 6.2 and 6.2.1. Consider the interval x is an element of 0 to 180. The first question, let's calculate the values of x for which a sine of x minus cos b of x, not cos b of x, but cos bx is equals to 0. We know the values of a and b, so let's go ahead and substitute those. We're going to have 2 sine of x minus cos x being equals to 0. Let's take cos x to the right hand side. If we do that, we're going to have 2 sine of x being equals to cos of x. Well, if we say sine of x divided by cos of x, then we're going to have tan of x. So let's divide both sides by cos of x. If we do that, we're going to have 2 sine of x divided by cos of x being equals to 1. Cos of x divided by cos of x is 1. But instead of having sine of x divided by cos of x, we can write that as tan of x. This is equals to 1. You can see here that we're going somewhere. Tan of x will be equals to 1 divided by 2. So we can say that x is equals to tan inverse of 1 divided by 2. The value of x is 26.57. And just like that, we've answered 6.2.1. Just a bit of algebraic manipulation. 6.2.2. For which values of x will g of x multiplied by the gradient of f of x be greater or equals to 0? Let's go ahead to our sketch and do some sort of constructions. Let's look at g of x first. Where is g of x positive and where is g of x negative? We're gonna highlight where g of x is positive with a green color and where g of x is negative with a red color. So from this point up until x is equals to 90, g of x is positive. And then from 90 to 180, it is negative. Now let's look at f prime of x. F prime of x, That is the gradient. When is the gradient of f of x positive and where is the gradient of f of x negative? The gradient of f of x is positive when the graph is sloping up. The gradient is just the slope, and it is negative when the graph is sloping down. When is our gradient sloping up? From this point up to x is equals to 90, we have a positive slope. And then from x is equals to 90 to x is equals to 180, we have a negative slope. So as you can see, when g of x is positive, f prime of x is also positive. The product of those two graphs will be positive. And when g of x is negative, the gradient of f of x is also negative. Negative multiplied by negative is positive. So it seems like when x is an element of 0 to 180 degrees, our condition is satisfied. G of x multiplied by the gradient of f of x is greater or equals to 0. Let's look at 6.2.3. Quite an interesting one. Determine the values of y for which y is equals to 2 to the power 2 multiplied by f of x minus 1. Let me know in the comments how you think we should approach this question, because the problem I'm having here is that we're looking for the values of y. So I don't know what y is, but I also have f of x and I'm not given one value of x. So how are we gonna navigate that? We don't have any information and we have two variables. Please let me know in the comments. I think I've cracked this topic. Let me tell you why I'm saying that. I know all the exact steps that you need to follow to be able to answer any question. Determine whether your triangle is right angled or not. If it is right angled, then the first thing you should try is to use trig ratio. Sine of theta, cos of theta, and tan of theta. And if trig ratios don't work and it is a right angled triangle, then you can use the theorem of Pythagoras. C squared is equals to b squared plus a squared. This is the first two things you should be looking at. And if it is not a right angled triangle, then we're going to move to the sine rule. This is step number 2 if step number 1 seems to not work. And if the sine rule doesn't work, we're going to use the cosine rule. Right, and if the cosine rule fails, then the area rule is going to work. This is the approach you should be taking. Let's see if it is going to work on this question. Well, we're not seeing. I know it is going to work. Let me show you that it works instead. 7.1, write BF in terms of theta and y. So let's go ahead and look at BF. BF is this side. It's our triangle right angled. Well, it is not. There is no angle which is equals to 90 degrees. So we cannot use trig ratio or theorem of Pythagoras. The second step is using the sine rule. So let's see if we can apply it. We're looking for BF. BF is opposite angle theta. And then we have side AF, which is opposite angle B of size 30 degrees. As you can see, the sine rule is going to work. So in triangle ABF, we have sine of 30 degrees divided by y. You see the angle divided by the side opposite. This is equals to sine of theta divided by BF. Let's cross multiply. We're going to get BF multiplied by sine of 30 degrees being equals to y multiplied by sine of theta. So BF is equals to y multiplied by sine of theta divided by sine of 30. But sine of 30 is special. So BF is going to be equals to y sine of theta divided by a half. This is just equals to 2y sine of theta. Our answer to 7.1. Let's go ahead and look at 7.2. So again, we're looking at our steps. The first step is to determine whether our triangle is right angle or not. DF is a side on triangle DFE. So we're going to use that triangle. So we're going to say that in triangle DEF, it is not the right angled triangle. So we cannot use trig ratios or theorem of Pythagoras. We're looking for DF. DF is opposite angle alpha. And then we have angle F of size 30 degrees, which is opposite x. So the sine rule is going to work again. Sine of 30 divided by x is equals to sine of alpha divided by df. Let's cross multiply. Sine of 30 is a half, so we're going to have a half multiplied by df being equals to x sine of alpha. So df, if we divide by a half on both sides, we're going to have 2x sine of alpha. So there we go. We have the size of angle df in terms of alpha and x. 7.3. Prove that BD squared is equals to 4x squared sine alpha squared plus 4y squared sine theta squared. BD squared. Let's go ahead and look at BD. BD is this side right here. If we look at triangle BDF, you will realize that we have a right angled triangle. So we can use theorem of Pythagoras to find the size of BD. We have BF, we determined it, and we also have DF. So we can say that BD squared is equals to DF squared plus BF squared. BD squared will be equals to DF squared. That is 2x sine of alpha squared plus BF squared. That is 2y sine of theta squared. So BD squared will be equals to 2x squared. That is 4x squared. And then sine of alpha squared plus 2y squared. That will be 4y squared sine of theta squared. So we have proved what we are required to prove. That is 7.3. Let's go ahead and do 7.4. In our equation, we have the variables x and y. So we should be using a triangle that have those variables. Let me just erase all this for the sake of clarity. We have BD squared. We just determined it in the equation above. And BC is 3x and CD is 4x. Our triangle is right angled. So we can go ahead and try using the theorem of Pythagoras. CD is clearly our hypotenuse. So we can say that 4x squared is equals to 3x squared plus BD squared. But we know what BD squared is equals to. But what about 4x squared? 4x squared is just 16x squared being equals to 3x squared, that is 9x squared plus BD squared. BD squared is 4x squared sine of alpha squared plus 4y squared sine of theta squared. Let's take all the terms with x to the left-hand side. We have 9x squared and 4x squared sine of alpha squared. If we take that on the left-hand side, we're going to have 16x squared minus 9x squared minus 4x squared sine of alpha squared being equals to 4y squared sine of theta squared. So what is 16x squared minus 9x squared? That is 7x squared. And then minus 4x squared sine of alpha squared. This is all equals to 4y squared sine of theta squared. So on the left hand side, we can take x squared as a common factor. If we do that, we're going to have x squared multiplied by 7 minus 4 sine of alpha squared. This is all equals to 4y squared sine squared of theta. We can divide both sides by 7 minus 4 sine of alpha squared. If we do that, we're going to have x squared being equals to 4y squared sine of theta squared, everything divided by 7 minus 4 sine of alpha squared. Taking square roots on both sides, we're going to get x being equals to the square root of 4y squared sine theta squared divided by 7 minus 4 sine of alpha squared. We will find keywords in our question statement, and we're going to use those keywords to answer all our questions. So in the diagram, ABC is a tangent. So tangent is a keyword. We know that we have the tan chord theorem. So tangent is a word we are interested in. So I have tangent. And then it goes on to say that F, E, and D are points on the circle. EF is equals to BF. Let's write that down. EF is equals to BF. I think that's all. Let's see if we can use these keywords to answer our questions. 8.1. Determine with reasons the size of the following angles. We have angle E1. Angle E1 is right here. Let's see if we can use the first keyword to determine the size of angle E1. The first keyword is tangent. So I'm thinking tan chord theorem. Well, my tangent is ABC. And between ABC and line FB, that chord, there's an angle of 32 degrees. That angle should be equal to the angle subtended by that chord at the circumference of the circle. So now we can say that E1 is equal to angle ABF. Why are we saying that? This is the tan chord theorem. Angle F given reasons. So let's go ahead and highlight angle F. We have said that angle E1 is equal to 32 degrees. But I want you to realize something. Our second keyword, EF is equal to BF. Angles opposite equal sides. So E1 is equal to B1 because those two angles are opposite equal sides. So they should be equals to each other. So if E1 is 32 and B1 is 32, it will be easy to find the size of angle F using the sum of angles on a triangle. So we're going to have 2E1 plus angle F being equals to 180 degrees. This is the sum of angles on a triangle. So angle F is equals to 180 minus 2 multiplied by 32. 2 multiplied by 32, that is 64. So we have 180 minus 64, which is 116 degrees. So that is the size of angle F. And then after angle F, we are now looking for angle D. Angle D is right here, far away from all the other angles. Looking at E, F, B, D, that is a cyclic quadrilateral. F plus D, angle F plus angle D should be equals to 180 degrees. This is because the opposite angles of a cyclic quad are supplementary. So D is 180 minus 116. We know that this is equals to 64 degrees. So we have the size of angle D. Let's see what else we need to find. We need to find the size of angle O1. So O1, it is at the center of the circle. Well, without thinking too much, the angle at the center of the circle is twice the angle on the same arc that is on the circumference of the circle. So that is our angle D. So what are we saying? We're saying that O1 is equals to 2 times angle D. Angle at center is 2 times the angle at the circumference. They have to be in the same arc or subtended by the same chord. So O1 is 2 multiplied by 64, 120, and 128. So O1 is 128 degrees. The last question, we are looking for E2. So right, let's go ahead and see what we have for E2. Well, at this point, we know fully well that O1 is equals to 128, but OB is a radius and OE is also a radius. So E2 is equals to B2 because angles opposite equal size. 2E2 plus O1 is equals to 180 degrees. So 2E2 will be equals to 180 minus 128. Everything we're dividing by 2 on both sides. So let's just go ahead and show that. If we do that, then E2 is equals to 26 degrees. If angle ABR is equals to x, write down 3 other angles in the diagram which are also equal to x, providing reasons. So let's go ahead and read our question statement and extract a few keywords that we're going to use to answer all the questions that follow. So the question says that in the diagram, RS is a tangent. So there goes our first keyword, tangent. We know that with regards to a tangent, we have the tan chord theorem. And on top of that, the tangent is always perpendicular to the radius. Let's carry on. SAB is a line that passes through the circle. And RT is parallel SAB. RT is parallel SAB. There's a few things we know about parallel lines. Alternating angles, cointerior, so on and so on. The other keyword that we have is that MT is equals to AB. That can come in handy because equal cause subtend the equal angles at the circumference of the circle. So let's go ahead and answer our questions. 9.2.1. We want 3 other angles that are equals to x while giving reasons. So let's go ahead and try our first keyword, which is the tangent. Well, angle x is subtended by line RA. Well, let me not say line, but say chord. It is subtended by chord RA. But then, between chord RA and our tangent RS, there's an angle R1. We have the tan chord theorem right there. So we can say that R1 is equals to x because of the tan chord theorem. So we've used our first keyword to find an angle that is equals to x. Let's see if we can use the second keyword to find an angle that is equals to x. So the second keyword, RT, is parallel SAB. So where is RT? Let's go ahead and look for that. We have RT right here and is parallel SAB. So this line. If these two lines are parallel, then angle x should be equals to angle R3, alternating angles. So R3 is equals to x because they are alternating angles. So we have used the first 2 keywords. Let's see if we can use the third one. Well, neither MT or AB is subtending angle x. So I don't think we can use that. Let's go to our diagram now and see what we can come up with. Well, you should realize that the chord RA is subtending x, but at the same time, it is subtending M1. So x and M1 should be equal to each other. So now we can say that M1 is equals to x. And why are we saying that? Angles in the same segment. They are angles in the same segment. So there we go. We have 3 angles that are equals to x. So let's go ahead and answer the following question. But before we do that, let's put x in place of R1, R3, and M1 because we are saying that those angles are equals to x. It will help us when we answer other questions. So here at R1, we have x. At R3, we have x. And at M1, we have x. Right, now we can carry on and answer our questions. 9.2.2. If angle ARB is equals to y, this angle right here, provide the reason why MRT is equals to 1. Why angle MRT is equals to 1. Which angle is MRT? This angle here. Apparently, they are equals to each other. What I'm realizing is that angle R2, or our angle Y, is subtended by AB, and angle R4 is subtended by MT. But we know that MT and AB are equals to each other. That is our third keyword. And equal chords subtend equal angles at the circumference of the circle. So that is the reason we are supposed to give. Equal chords will subtend equal angles at the circumference of the circle. So instead of having R4, let's replace it with Y, because now we know that it is actually equals to Y. So we have Y here. Here we also have Y, and here we have X. 9.2.3. Write A1 in terms of X and Y. What is A1? A1 is this angle here. It should be easy to see that A1 should be equals to X plus Y. An exterior angle of a triangle is equals to the sum of the opposite interior. Right, angle A1 is an exterior angle of triangle ABR. It is an exterior angle of that triangle. So it is equals to X plus Y. Yeah, that one is quite easy to see. Oh, this was A, and now we at B. B is saying that we must write N1 in terms of X and Y. N1, we have the same reasons as A1. It is an exterior angle of a triangle. In this case, it is an exterior angle of triangle NMR. So N1 is also equals to X plus Y. That is 9.2.3. And 9.2.4, we're supposed to prove that triangle SAR is similar to triangle KNR. Let me just go ahead and highlight those triangles first before we carry on. There we go. These triangles are named such that S in triangle SAR should be equals to K in triangle KNR. And then A and N should be equals to each other. The same with R and R. That is a huge tip. If you're not aware of that, it is very difficult to answer these questions. Let's look at angle S and angle K. We have angle S right here, and here we have angle K. But then previously, we have not talked about angle K and angle S. So it will be quite difficult for us to prove that they are equals to each other. Compared to angle A and N, which we've talked about, and angle R. Let's see if we can use angle A and N and angle R and R. In triangle ARS, angle A1, we know that angle A1 is equals to X plus Y. And then in triangle KNR, we know that angle N1 is also equals to X plus Y. That's what we figured out in 9.2.3. So we can say that A1 is equals to N1 because they are both equals to X plus Y. Now we just need another pair of angles that are equals to each other in the two triangles. And we have proved that they are similar. Let's go and look at angle R and angle R. In triangle SAR, we have R1, which is equals to X. So we know that R1 is equals to X. And in triangle NKR, we have R3, which is also equals to X. So we can say that R1 is equals to R3 because they are both equals to X. And if that is the case, then we have proved that the two triangles are similar. We can just go ahead and say that angle K2 should be equals to angle S because of the sum of angles on a triangle. Triangle SAR is indeed similar to triangle KNR. Angle, angle, angle. All three angles are equals to each other in those two triangles. The last question, 9.2.5. Let's hear the stories. Prove with reasons that SAKR is a cyclic quadrilateral. SAKR. So let's just go ahead and look at SAKR. SAKR. Q2 is equals to angle S, as you can see right here. This is because triangle SAR is similar to triangle KNR. So SAKR will be a cyclic quad because the exterior angle is equal to the interior opposite. Prove that P1 is equal to A1 plus B1. That is the first question, 10.1. If you're wondering why I didn't include the question statement, it is because there is absolutely no keyword. But we can come up with a few. You should be able to realize that PQCB is a cyclic quad on the smaller circle, and BRAC is a cyclic quad on the bigger circle. So let's go ahead and see how we can get to P1 being equals to A1 plus B1. But let's stick to the basics here. We have P1 as an exterior angle of triangle ARP. So we can say that P1 is equals to A1 plus R2 because P1 is an exterior angle of that triangle. It is equals to the sum of the two opposite interior. But we can also say that P1 is equals to angle C. Why are we saying that P1 is equals to angle C? An exterior angle of a cyclic quad is equals to the opposite interior. So P1 is equals to angle C. So we need to prove that A1 plus B1 is equals to A1 plus R2. Basically prove that B1 is equals to R2. Or we need to prove that A1 plus B1 is equals to C. We need to prove one between these two. If we do that, then P1 is equals to A1 plus B1. So let's go ahead and look at the first option, proving that B1 is equals to R2. If B1 is equals to R2, then P1 is equals to A1 plus R2. So let's go ahead and look at that. We have B1 here, as I've indicated, and where is R2? We have R2 right here. Right, if you take some time and try figuring out if you can see that R2 is equals to B1, you're going to realize that it is a quite difficult exercise. I couldn't prove that. That is why I moved to option 2. A1 plus B1 is equals to angle C. Let's see how that comes about. So in triangle ARB, take your attention to triangle ARB. You will realize that A1 plus B1 plus angle ARB is equals to 180 degrees. This is just the sum of angles on a triangle. Then angle ARB will be equals to 180 minus A1 minus B1. That is the size of angle ARB. It is 180 minus A1 minus B1. But this angle ARB, this entire angle ARB, if we add it to angle C, we must get 180 degrees. The opposite angles of a cyclic quad are supplementary. So angle ARB is equals to 180 degrees minus angle C. clearly, if those two statements are true, then A1 plus B1 should be equals to angle C. So A1 plus B1, they're equals to angle C. So we can conclude and say that P1 is equals to angle A1 plus angle B1. Why are we saying that? They both equals to angle C. That is 10.1. Quite a tricky equation, but it is doable if you give yourself enough time. Let's move to 10.2. We're supposed to prove that AR squared is equals to AP multiplied by AB. Well, usually when we have an equation like this, we need to prove similarity. Well, we have side AR, AP, and AB. Let's see if we can find the two triangles that have only those sides. Right, let's just erase all this so we can have a bit of clarity. We have side AR right here, and we have AP. Wait, side AP? Side AP is right here. And then if we join R and P, we have a triangle. And then another side we have is AB. So it seems like we are also interested in this triangle. We have to state that we're interested in triangle ARP and triangle ABR. Right, so in those two triangles, angle A1 is equals to angle A1. Why are we saying that? It is just a common angle. It's shared by the two triangles. In 10.1, this is how we started. We said that P1 is equals to A1 plus R2. This was because P1, it is an exterior angle of the triangle ARP, right? But then we ended up concluding that P1 is equals to A1 plus B1. We were actually asked to prove that, and we were able to prove it at the end. If P1 is equals to A1 plus R2 and P1 is equals to A1 plus B1, then that tells us that R2 is equals to B1. We can clearly see that R2 is equals to B1. R2 is equals to B1, and angle A is common. Now we can say that angle P4 is equals to angle R2 plus R1. If those pairs of angles are equals to each other, then P4 should be equals to R2 plus R1 because of the sum of angles on a triangle. And just like that, we can conclude and say that triangle ARP is similar to triangle ABR. Angle, angle, angle. AR divided by AB is equals to AP divided by AR. This is because triangle ARP is similar to triangle ABR. If we cross multiply, you're going to get AR squared being equals to AB multiplied by AP.
So let me just brief you in on what's happening here. So we have a teacher with two classes, 12A and 12B. So what's happening here is that in 12A, they're having phase 2 phase classes. And then in 12B, they're having online classes. And then this table here gives us the time spent teaching, right, the two classes. And then here we have the average result of 12A, right, the weekly results. And then here we have the average weekly results for 12B. So that is the data we're dealing with here. And then 1.1 says that let's determine the equation of the least squares regression line of 12A, right? So our x here is going to be the time spent teaching, right? So let me write that down. and then our y is going to be the average result for the class, right? So we have the average result for grade 12A, right? So you cannot really calculate the least squares regression line manually, right? More especially if the question has only 3 marks. So to do this, we're going to use a calculator, right? So let me show you how we actually do that. So on your calculator, you want to press mode or setup there, right? And then this menu here will pop up. When this menu pops up, you press 3, right? When you press 3, then this menu here will pop up. We're looking for the equation for the least regression line, right? That equation says that y is equals to a plus bx, right? So we're going to press 2 so that we can open this tab here, right? So I'm just gonna press 2. When we press 2, we have x and y, right? So our x is going to be the time spent teaching, and our y is going to be the average results for that class, right? 12A. So let's put in the values for x. So on this table here, you can see that we have 2, 4, 2, 8, 4, 6, 12, 10, 11. So I'm just gonna put that in, right? So I have 2, and then I press equals to, and then I have 8, I have 4, I have 6, and then I have 12, I have 10, and I have 11, right? That's for the x values. Now I have to go to the y values. So to go to the y values, I'm gonna move to that column there, and then I'm gonna move up to the first one. So the first y value for 12A, right, the result, we have 42 here. So I'm gonna put 42. After 42 we have 62, and then we have 48. After 48, 52, 64, press equals to, and then 63, pressing equals to again, 67, and then that's it, right? We only have 7 data points. So after you put all your numbers, you press equals to, right? And then after you do that, you're gonna press AC, just like I'm doing right now. So there we go, I press AC. When you press AC, you'll come back to this menu right here where we started. But then now we want to go and retrieve our value for A and our value for B, right? So that we can have the equation of the least squares regression line. So how do we do that? To press shift. After pressing shift, we press 1, and then this menu pops up, right? We want the least squares regression line. So we're gonna press 5 because that's where we have regression, right? REG. So when you press 5, this menu pops up. You can see that on 1 we have A, on 2 we have B, and so on. So we're looking for A, right? So let's press 1, and then an A will pop up in your screen. You press equals to, and you will get the corresponding value. So now we know that A is equals to what? 38.26. And then now we're looking for B, right? B is equals to what? So now what you want to do, you're going to press AC again, you press shift, you press 1, you press 5, and then you press 2, right? And then what is B? So B is 2.46, right? So now our equation for the least squares regression line will be y is equals to 38.26 plus B, which is 2.46 multiplied by x, right? What we're substituting in. And then just like that, you have calculated your least squares regression line. Now let's do 1.2. So 1.2 says that let's write down the correlation coefficient of the grade 12A results in respect of the time spent teaching. So we're looking for R, the correlation, right? In order to find the correlation, we're going to go back to the same menu, right? So that is shift, and then you press 1, and then we press 5 for regression, and then you can see R that is on number 3, right? So if you press 3 and you press equals to, then you get R is equals to 0.9 6, right? So that's just 9, 7, right? If we round it off to 2 decimal places. So that's our correlation coefficient of the grade 12A results in respect to the time spent teaching. And then now 1.3 says that let's comment on the correlation between the time spent teaching and the average results of grade 12A. So we can see that we have a correlation value of 0.97, right? And then this is very high. So for our comment, we can say that we have a very strong positive correlation, right? So you just write down we have a very strong positive correlation between the time spent teaching and the average result. It seems like the more we teaching, the more the results are going up, right? So that's a very strong positive correlation. And then now we can do 1.4. So 1.4 says that the equation of the least squares regression line of grade 12B is, and then so now we have the line for grade 12B, right? Grade 12B is given as y is equals to 15.74 plus 4.54x. And then the question says let's calculate the difference in the result achieved by each class had Miss Molife spent the average time in to complete a particular section, right? So so now for grade 12A, right? For grade 12A, let's just copy down the equation before we can go any further. We have 38.26 plus 2.46x, right? So we want to find the difference in the result achieved by each class if Miss Molife spent the average time to complete a particular section, right? So the difference, we'll be finding the difference between grade 12B and grade 12A, right? If the teacher took the average time. So what we have to do first is to calculate the average time that the teacher took, right? So to do that, we can say that X bar, you know, we're looking for the mean, the average basically. And then the time spent, we have the time here that I just circled in red. So we can just find the average of that. That will be 2 plus 8 plus 4 plus 6 plus 12 plus 10 plus 11, and then we dividing everything by the number of terms. So we have 1, 2, 3, 4, 5, 6, 7. So we are dividing that by 7, right? And then if you put that in your calculator, you should get 7.57, right? So now we have the average time spent. We can then substitute it in our two equations, right? So what are we saying? We're saying that for 12B, we're going to have y is equals to the equation 15.74 plus 4.54, and then in place of x we put in the average time, which is 7.57, right? And then if you put that in your calculator, you should get 50.1078, right? And then if we go to 12A, so let's go to 12A. So for 12A, we have y is equals to 38.26 plus 2.46 multiplied by x, right? X is our average. That will be 7.57. So let me just put that in my calculator. And here I'm getting 56.8822, right? So now we're looking for the difference, right? So let's say the difference, let me just write that in words. So the difference is going to be equals to the highest minus the lowest, right? So that will be 56.8822 minus 50.1078, and the answer for that shall be 6.77. So that is the difference when the teacher spends the average time to complete a particular section. Now let's do 1.5. So 1.5 here is saying that let's identify an outlier in grade 12B. So let's go to grade 12B and see if we can find an outlier, right? So for 2 hours spent teaching, the average result is 9%, right? And then for 4 hours, the average time is 45. For 6 hours, 47. For 8 hours, 63. And then for 12, we have 61. For 10, we have 64. And then for 11, we have 62. So you can see clearly here that, and then for 12A, for 2 hours, we have 42%, right? So you can see that this 9% here is an outlier. It's very far away from all the other data points, right? So we can say that when X is equals to 2, and our Y is equals to 9, that's where our outlier lies, right? Because for 2 hours, we expecting an average result of around 40%, right? Because that is what is happening in 12A. So that point there is our outlier. And then 1.6 is saying that let's indicate a valid reason for this outlier. So let's not forget that for 12B, they were being taught online, right? So what valid reason can we give for that outlier? Maybe the learner was not attending, right? You just open that Zoom link and you let it play while you do something else. Or maybe the learner did want to attend, but there were connectivity issues. A lot of, issues can arise. The question starts off fairly weak with 3.1, just asking us to find the gradient of BC. So we are given all the coordinates of B, and we are also given the coordinates of C. So we're supposed to substitute directly, not trickery whatsoever. So the gradient of BC will be equals to y2 minus y1 divided by x2 minus x1. So let's take B as our second point. If we do that, the value of y2 will be 8 minus the value of y1, which is going to be 0, divided by the value of x2, which is 4, minus the value of x1, which is 5. So we have 8 divided by minus 1, which is equals to minus 8. So that is the gradient of BC. Let's move forward and look at 3.2. So what does the question say? If the distance between points A and B is equals to square root of 65, calculate the value of K. So let's put that in math. They say that the distance between A and B is equals to square root of 65. So let's have the distance formula. If we do that, we're gonna have y2 minus y1 squared plus x2 minus x1 squared being equals to square root of 65. So when we substitute the coordinates of A and B, the only unknown variable we're gonna have is K, and then that is how we are going to find it. Let's go ahead and do that. So if we take B as our second coordinate, y2 is going to be 8, and then y1 is going to be k. We square that plus x2, that is 4, minus x1, which is minus 3. So it will be 4 plus 3. We square that, and it is equals to square root of 65. Let's go ahead and solve what is inside the bracket. So we have 8 minus k squared. How do you solve that? What is 8 multiplied by 8? That is 64. And then you multiply 8 by minus k, it will give you minus 8k. You multiply that by 2, you're gonna get minus 16k. And then minus k multiplied by minus k, that is just plus k squared. And then 4 plus 3, that is 7. You square that, you get plus 49 being equals to square root of 65. So what can we do here? We can take square roots of both sides. If we do that, if we square both sides, we're gonna have 64 minus 16k plus k squared plus 49 being equals to 65. If we take 64 to the right hand side, we're gonna have 1, and then if we take that 1 back, then we're gonna have 49 minus 1, which is 48. So we have k squared minus 16k plus 48 being equals to 0. So let's go ahead and factorize. Which two numbers do we multiply and get 48? But when we add them, we get minus 16. That is minus 4 and minus 12. So that is to say that k minus 4 multiplied by k minus 12 is equals to 0. So it's either k is equals to 4 or k is equals to 12. Let's look at what makes sense between 4 and 12. B is clearly above A in terms of the y value. So if the y value of B is 8, then the y value of A should be less than 8. So this k is equals to 12 cannot be correct, meaning that the answer is k is equals to 4, the y value of A. Let's move to 3.3. 3.3, we are supposed to prove using analytical geometry methods that BP is perpendicular to AC. So what are we required to prove? We are required to prove that the gradient of BP multiplied by the gradient of AC will be equals to minus 1. That's what we mean when we say BP is perpendicular to AC. So let's go to our sketch and see how we can find our way. So where is BP? BP is right here. And then AC is right here. There we go. We have AC. So A, we have the coordinates of A. We have all the coordinates of A. And we have all the coordinates of C. So it's easy to calculate the gradient of AC, right? So we have that figured out. What about BP? We don't have the coordinates of P. P lies on BD and we have the coordinates of D. So we can just use the coordinates of BD to find the gradient of BP. For the gradient of BP, we're going to say y of B minus y of D divided by x of B minus x of D multiplied by AC. So let's say y of A minus y of C divided by x of A minus x of C. Right. And then what is y of B? Y of B is 8 minus y of D, which is minus 4, divided by x of B, which is 4, minus x of D, which is minus 2. And then we multiply that by y of A. We know what the value of k is now. The value of k is 4 minus y of C, which is 0, divided by x of A minus 3 minus x of C, which is minus 5. So what is 8 minus 4? That is 12 divided by 6 multiplied by 4 divided by minus 8. So we have 2 multiplied by minus a half, and this is equals to minus 1. So there we go. Those two lines are perpendicular as the product of the gradients is equals to minus 1. Let's move to 3.4. 3.4, we're supposed to calculate the coordinates of F. If it is given that ACFD is a parallelogram. So let's go ahead and look at F. F is right here. So if it is a parallelogram, let's go ahead and connect those points. If it is a parallelogram, then A and C, D and not A and C, but C and F, and then D and F. Yeah, we have something like this as our parallelogram, right? So in order to find the coordinates of F, we can use the midpoint of DC as it will be the midpoint of AF, but that is a painful exercise. Instead of doing that, we're gonna use translation. Let me show you how, if you're not familiar with the concepts. So let's look at the x value of A. The x value of A is minus 3. And the x value of D, it is minus 2. And then the x value of C is 5. What will be the x value of F? right? So the way the x value of A and D differ is the same way the x values of C and F are gonna differ if A, C, D, F is a parallelogram. So here we have -3 and -2. You can see that from A to D is +1. Here we have 5. So for the x value of F, we must have 5 plus 1, which is 6. So we have covered the x value of F. Let's look at the y values. The y value of A is 4. The y value of D is -4. So from 4 to -4, that is -8. What is the y value of C? The y value of C is 0. So the way the y value of A and D differ should be the same way the y value of C and F differ. So that will be 0 minus 8, which is -8. So the coordinates of F is 6 and -8. Yeah, so you can do that instead of using the midpoint. Right, let's move to the following question. 3.5. So 3.5, calculate the size of EDO correct to 1 decimal place. So let's go to our diagram and look for EDO. EDO is this angle right here. This is EDO. How can we possibly find EDO? Well, I can see fairly quick that I can find the value of this angle here. If I find the value of that angle, then that angle will be equals to this angle. I think they are called vertical opposite angles, and they're supposed to be equal to each other. So I can use that angle to find this angle. And then I can find this angle. And then that angle should be equals to our angle of interest plus this angle here. The exterior angle of a triangle is equal to the sum of the two opposite interior. So how can I find this first angle that I'm claiming I can find? I can use the gradient of BD. I can use the gradient of BD, which I already have, because tan theta is equal to M. And then how can I find this angle? I can use the gradient of AD to find that angle. So let's go ahead and compute that. We're gonna see that tan of that angle is equals to the gradient of BD. That angle will be equals to tan arc of BD. But we have the gradient of BD. We calculated it when we were trying to prove that AC is parallel to BP. And it was 2. So what is tan arc of 2? That will give you so yeah, that angle is covered. Let's find this exterior angle of our triangle. We're going to use the gradient of AD. So we're going to say that that angle, what is it? Is it alpha? Yeah, we're going to say that alpha is equals to tan arc of y2 minus y1 divided by x2 minus, what am I doing? I already have the gradient of that line, because this line is supposed to be parallel to this line because our shape is a rhombus, right? So we said that the gradient of this line is -8. So we're gonna go ahead and substitute that. So we have -8. This will give you -82.874875. If it is minus, you must always add 180. If you do that, you're gonna get 97.125. So now we can say that our exterior angle is equals to 64.63 plus EDO plus our angle EDO. But we know that alpha is 97.125. So let's take 63.63 to the left hand side. We're gonna get 97.125 minus 64.63 being equals to ADO. If you put that in your calculator, you should get 33.7 being equals to EDO. The last question, let's do the last question. We're supposed to calculate the area of ADC. We're supposed to calculate the area of ADC. Let me highlight ADC because I cannot even see it. It's just a mess. With A is right here, and then D is right here. With C is right here. Because our shape is a rhombus, we have a 90 degrees angle here. And then if that is the case, then we can take AC as our base and DP as our height. So we can say that the area of triangle ADC is equals to half AC multiplied by DP. So we have the coordinates of A and C, so we can easily find AC. We have the coordinates of D, but we can find the coordinates of P using the midpoint theorem. So we basically have DP. Now it's just a matter of putting that in your calculator and finding your final answer, which should be equals to 30 square units. Write the equation of the circle in the form x minus a squared plus y minus b squared is equals to r squared. We are given an equation. It is said to be x squared plus y squared minus 4x minus 2y minus 13 is equals to 0. Before we do anything fancy, let's just group their like terms. If we do that, we're going to have x squared minus 4x plus y squared minus 2y. Let's take the constant to the right hand side. If we do that, this is going to be equals to 13. The next step you probably want to take is to complete the square. What do we mean by that? So we have x minus 4 divided by 2 squared plus y minus 2 divided by 2 squared being equals to 13 plus minus 4 divided by 2 squared plus minus 2 divided by 2 squared. There we go. So we're going to have x minus 2 squared plus y minus 1 squared being equals to 18. So that is the equation of the circle. Let's do 4.2. Write down the coordinates of n and the length of nt. So n is our center of the circle and nt is the radius. So the coordinates of n from our equation, the x value is going to be 2 and the y value is going to be 1 at the center. So we're saying that the x value is 2 and the y value is 1. And then how can we find the length of nt? Like we've already deduced, nt is the radius, and on our equation we have radius squared. So we can go ahead and say that nt is equals to the square root of 18, because 18 is radius squared and nt is our radius, so nt shall be equals to the square root of 18. Let's move to 4.3. So in 4.3, determine the equation of the tangent qt in the form y is equals to mx plus c. So let's go ahead and do some analysis. We have qt right here as our tangent. In order to find the gradient of qt, because we need to find the gradient if we want the equation, we're going to have to find the coordinates of t. Well, we don't have to necessarily find the coordinates of t for the gradient, because we can just use the coordinates of n, which is 2 and 1, and the coordinates of p. But then in order to find C, we're gonna need a point that lies on the line QT. So let's just go ahead and find the coordinates of T, and then I'm gonna use the coordinates of T to find the gradient, and after finding the gradient, we're gonna use the same coordinates of T to find C. So how are we gonna find the coordinates of T? TP is a diameter, so that tells us that N is the midpoint of PT. So we can use the midpoint theorem. We can say that x of N is equals to x of T plus x of P divided by 2. So x of N, that is 2, x of T, it's what we're interested in. X of P is 5 divided by 2. If we cross multiply, we get 4 is equals to x of T plus 5. So x of T is equals to minus 1. Now we just need y of T. Y of N is going to be equals to y of T plus y of P divided by 2. What is y of N? That is 1. And then y of T, what we're interested in, y of P is 4 divided by 2. We cross multiply, we get 2 is equals to y of T plus 4. So y of T is equals to 2 minus 4, which is minus 2. So the coordinates of T, we have minus 1 and minus 2. So we can go ahead and find the gradient of QT. The tangent is perpendicular to the radius. So if we find the gradient of the radius, then we can use that to find the gradient of the tangent. We're going to have the gradient of NT being equals to y of N minus y of T divided by x of N minus x of T. Y of N, that is 1, minus y of T, which is minus 2. We have it right here. And then everything divided by x of N, which is 2, minus x of T, which is minus 1. So we have 3 divided by 2 minus minus 1, that is 3. So the gradient of NT is 1. Right, so now we can say that the gradient of NT multiplied by the gradient of QT is equals to minus 1. So the gradient of QT is going to be equals to minus 1 divided by the gradient of NT, which is 1. So the gradient of QT is equals to minus 1. So now we know that for our equation of the straight line of the tangent, y is equals to minus x plus c. Now we just need to find c. We're gonna substitute t of coordinates minus 1 and minus 2. If we do that, we're gonna get minus 2 in place of y and minus 1 in place of x plus c. So minus 2 is equals to 1 plus c minus 3 is equals to c. So now we have y being equals to minus x minus 3. And now we have the equation of QT. Let's move ahead and do 4.4. So in 4.4, the circle with center S of coordinates A and B touches the circle with center N externally at T. QT is a tangent to both of these circles. If NS is equals to 3NT, determine the coordinates of S. Yeah, there's a lot going on there. So let's go ahead and have a sketch for that circle and then try make sense of the situation we have. So they touch at T, and then QT is also a tangent at that circle. Yeah, another key point is that they touch externally, because if the question says they just touch, then that is very unclear. But now if we know that they touch externally, we can do something about that. Well, let's just take that as our circle and try make something of it. So it has a center S of coordinates A and B. So the coordinates of T, we have minus 1 and minus 2. What other information do we have? We're given the fact that NS is equals to 3NT. So let's try denote that in our sketch. Where is NS? ns. So this is the center of the circle S. So ns is equals to 3nt. This circle is actually supposed to be bigger than how I made it look, but well, that is that. The best way to approach equation is to start with the information that is given. So obviously, ns is equals to 3nt. That is the first thing I'll be thinking about. So ns using the distance formula. Right, let's go ahead and do that. So this is equals to 3nt. We have 2 and 1 as the coordinates of n. If we take S as our second point, we're going to have y2 being equals to b minus y1, which is equals to 1, the y value of n. And then plus x2, which is equals to a, minus x1, which is equals to 2, the x value of n. If we square both sides, we're going to have b minus 1 squared plus a minus 2 squared. We actually know the value of nt because nt is the radius of the circle we started with, and that is square root of 18. So here we essentially squaring 3 multiplied by square root of 18. If we square that, we should get 162. So let's just put that there. We have 162. We know that nt is perpendicular to qt, and then we also know that qt is perpendicular to st. So that tells us that the gradient of st will also be equals to 1. We can actually say that y of t minus y of s divided by x of t minus x of s should be equals to 1. So what is y of t? That is minus 2. Y of s, that is b, divided by y of t, x of t minus 1 minus x of s, which is a, being equals to 1. So if we cross multiply, we're going to get minus 2 minus b is equals to minus 1 minus a. We can make 1 the subject of the formula here. Let's make b the subject of the formula. If we do that, we're going to get minus b being equals to minus 1 plus 2, that is 1, and then minus a. We divide both sides by minus, we get b is equals to a minus 1. We can call this our equation 1. And then what we want to do is to substitute this equation into this equation. So let's do that. Instead of having b, we're going to have a minus 1 and then minus 1 squared plus a minus 2 squared is equals to 162. So we're going to have a minus 2 squared plus a minus 2 squared being equals to 162. A minus 2 squared is equals to a squared minus 4a plus 4 plus a squared minus 4a plus 4. If we take 162 to the left hand side, we're going to get minus 162 is equals to 0. So we're going to get 2a squared minus 8a minus 154 is equals to 0. We can take 2 as a common factor and get a squared minus 4a minus 77 is equals to 0. So now it's just a matter of factorizing this. Which two numbers do we multiply and get minus 77? But when we add them, we get minus 4. That is minus 11 and positive 7. So a minus 11 multiplied by a plus 7 should be equals to 0. A is equals to 11 or a is equals to minus 7. So we need to pick a value that makes sense. You can see that s is on the third quadrant, so the y value must be negative. So a cannot be equals to 11. It is equals to minus 7. And now we have a. We can find b because b is equals to a minus 1 So that is minus 7 minus 1, which is minus 8. So the coordinates of S is actually minus 7 and minus 8. This question just shows how important it is to always read the question and analyze the information before attempting any question, right? Because when I looked at 5.1.1, I'm like, okay, 5.1.1, we have cos of 2 theta. Right, so I'm going to use a double angle identity here. I'm just going to say that cos of 2 theta is equals to 1 minus 2 sine of theta squared, right? So if I find sine of theta, then it will be easy to find cos of 2 theta. But when I looked at the question again, I realized that the reflex angle itself is cos of 2 theta. So for 5.1.1, I don't have to use a double angle identity, right? I can just say 5.1.1, we have cos of 2 theta being equals to the adjacent divided by the hypotenuse, right? Because the angle itself is 2 theta that is given to us as the reflex angle, right? We're not given theta and then now we asked to find cos of 2 theta. No, we actually have the angle being 2 theta, which is a very special case. This is actually the first time I'm approaching equation and then we have something like this, right? So if we go ahead and calculate that, what is the adjacent? The adjacent is the x value of the given point, right? So there we have minus 3. So that will be equals to minus 3 divided by the hypotenuse. The hypotenuse is r, right? So we can just go ahead and calculate that with our point that is given to us, right? So we can say our hypotenuse, so we can say r squared will be equals to x squared plus y squared. So r should be equals to what is x? X is minus 3, so we have minus 3 squared plus minus 3 square root of 3 and then squared, everything to the power a half, right? We're taking square root on both sides, and if you put that in your calculator, you should get r being equals to 6. So right now we're just saying, let's not forget we're here. So right now we're just saying that cos of 2 theta is equals to minus 3 divided by 6, and then that should be equals to minus 1 divided by 2. And as simple as that, we have solved our problem. But then if you had not analyzed the equation and realized that the reflex angle is 2 theta, you're gonna do something completely wrong, right? And then now let's do 5.1.2, and then for 5.1.2, this is where we are gonna actually use a double angle identity and not 5.1.1. Let me show you what I'm talking about, right? So we have sine of theta, right? But then even though we have sine of theta, the angle given to us is 2 theta. So we cannot say sine of theta will be equals to the opposite divided by the hypotenuse. We cannot do that because the angle given to us is not theta, it is 2 theta. That is our reflex angle, right? But then we can use the answer in 5.1.1 to find the answer for 5.1.2. So we're going to introduce a double angle identity, right? We're going to say that cos of 2 theta will be equals to 1 minus 2 sine of theta squared, right? Now you should realize that we have cos of 2 theta. 1 is just a constant. So if we are able to find sin squared of theta, then we know what sin theta is, right? So let's go ahead and solve our problem. So for cos of 2 theta, we're gonna have minus a half being equals to 1 minus 2 sine of theta squared, right? So now we just solving for sine of theta squared. So if we do that, we're gonna get minus a half minus 1 is equals to minus 2 sine of theta squared. So let's just divide both sides by minus 2. So this would imply that we would get sine of theta squared being equals to minus 1 divided by 2 minus 1 divided by minus 2, and we should get 3 divided by 4, right? Being equals to sine of theta squared. So now we just take in the square root on both sides. If we do that, we should get sine of theta is equals to the square root of 3, right, divided by the square root of 4. The square root of 4 is 2. So our answer for this question would actually be sine of theta is equals to the square root of 3 divided by the square root of 2. So all the time when you get a question like this, don't rush to assume that this angle here is theta. Always check and see if it's not 2 theta or anything else they can possibly give you. The best way to draw a graph of a trig function is to substitute all values of x but moving with an interval of 30. Because if you substitute 1, 2, 3 up to 180, you're going to take the entire day. So you move with an interval of 30. Look at 6.1. The question here is saying that let's draw the graph of g of x if g of x is equals to minus 10 3 divided by 2x for the interval x is an element of minus 90 to 180 on the grid provided in the answer book. Clearly show all asymptotes, intercepts to the axis, and endpoints of the graph. So we are going to do that exact thing. We are going to substitute values of x in our function g of x while moving with an interval of 30. Let's see how that will look like. We are going to start at minus 90. If you substitute minus 90 into g of x, you're going to get minus 1. So that is 1 point that lies on the graph. And then if you substitute minus 60, you're going to get undefined. So we know that at minus 60, we have an asymptote. When you substitute minus 30, the corresponding y value is positive 1. When you substitute 0, the corresponding value is 0. When you substitute x is equals to 30, the corresponding value is minus 1. And when you substitute x is equals to 60, you're going to get undefined. So every time we get undefined, we know that we have an asymptote. When we substitute 90, we get y is equals to 1. When you substitute 120, we get y is equals to 0. When you substitute 150, we get minus 1. And then when you substitute 180, you get undefined. So we have another asymptote at that point, which we need to indicate. You can substitute a value between minus 90 and 60 just to see whether your graph is going up or down at this part. You shall be able to see that it is going down. And then on the other hand, we just need to connect all these 3 points, and the remaining 3 points we have something like this. Substituting values of x with an interval of 30 degrees seems to always work. Let's move to the following question, 6.2. We're supposed to determine the period of g. First of all, g of x is equals to minus 10 of 3 divided by 2x. And now we're looking for the period of g of x. The period of tan of x is equals to 180. But we don't have tan of x, we have minus tan 3 divided by 2x. So how do we go from the period of tan of x to the period of minus tan 3 divided by 2x? You divide the period of tan of x by 3 divided by 2, or the coefficient of x. If it's 1, you just divide by 1 and you get 180. So if we divide 180 by 3 divided by 2, we're going to get 120. If we had tan 4x, we would divide by 4. If we had tan 1 divided by 2x, we would divide by a half. So whatever coefficient of x you have, you just divide the original period with. So the period of our graph is 120. But if you look at the sketch, you can also see that it is indeed 120, because the graph can complete itself between minus 60 degrees and plus 60 degrees. And from minus 60 to 60 is 120 degrees. Let's look at 6.3. Write down the values of x in the interval minus 90 to 180 degrees for which f is decreasing. Right, let's go to our function. So at this point, it is actually quite easy to answer this question. Our graph f of x starts decreasing up to this point where it actually starts increasing again. So what are we saying? We're saying that when x is between 0 degrees and 180 degrees, our graph f of x is actually decreasing. Let's look at 6.4. So 6.4, use the graph of g to determine for which values of x will g of x be greater or equals to 1 for the interval minus 90 to 180 degrees. G of x is minus tan 3 divided by 2x. So let's go ahead and find out. We need our graph to be greater or equals to positive 1. So at minus 90, it is equals to 1. It means that this part of the graph should be part of our solution. Let's go ahead and look for other points for which it is greater or equals to 1. Again, when x is equals to 90 and going in that direction should be part of our solution. I think that's all the points for which g of x is equals to or greater than 1. When x is equals to minus 30 degrees or less, and when x is greater than minus 60 degrees, our condition is satisfied. Obviously, we cannot include minus 60 because our function is undefined at that point. And when x is equals to 90 or less and it is greater than 60 degrees, let's look at 6.5. 6.5, the function h is obtained by translating the graph of g 30 units to the right. Write down the equation of h. So h of x will be equals to g of x minus 30. Let's think about that. When you want to shift your graph to the right, you minus the x values, and then when you want to shift your graph to the left, you plus your x values. So it seems counterintuitive that how do we move right by subtracting and move left by adding? That's how it is. So h of x will be equals to minus tan 3 divided by 2 x minus 30. Right. We can further simplify this and say that h of x is equals to minus tan and then 3 divided by 2x minus 45 degrees. Let's determine CD, the distance between the two angles in terms of age. So what you want to do in this kind of problem, you will realize it towards the end, is that you have to start with the triangle that has the most information and move towards the triangle that has the least information. So let's look at our line CD. So here's CD here, right? And then apart from CD, we have an angle to theta here, which I just highlighted, right? And then we are told that AC and AD are equals to each other, right? So this angle here should be equals to this angle. So let's just, go ahead and calculate those angles. So we're saying that in triangle ADC, we have 2 theta plus angle ADC plus angle ACD being equals to 180 degrees. But then because ADC and ACD are equals to each other, we can just say that ADC is equals to ACD. The two triangles will be equals to each other since the lines are equals to each other. So now we're going to have 2 theta plus 2 ADC being equals to 180 degrees. So now we have 2 ADC being equals to 180 degrees minus 2 theta. So if you divide both sides by 2, you get ADC is equals to 90 degrees minus theta. So now we have this angle here, which is 90 degrees minus theta. this angle here is also 90 degrees minus theta. Let's not forget our aim. We want to determine line DC, right? In terms of h. So what can we do here? We can use the sine rule, right? We can say that sine of A divided by the side A will be equals to sine of B divided by the side B. We're still in triangle ADC, right? So let's take sine of 2 theta. So we're saying that sine of 2 theta divided by the opposite side, right? DC will be equals to, let's take this angle here, 90 minus theta, right? You're going to see why I'm saying we should take that one. Then we're going to get sine of 90 minus theta divided by the opposite side. The opposite side is AC. So if we cross multiply, we get DC multiplied by sine of 90 minus theta, that is just cos of theta, right? And then that is equals to AC sine of 2 theta. So DC is equals to AC sine of 2 theta, everything divided by cos of theta. But we know fully well from Trig, right, that sine of 2 theta is equals to 2 sine of theta cos of theta. So we can just substitute that in. We're going to get DC is equals to AC 2 sine of theta cos of theta, everything divided by cos of theta, right? And then now it's easy to see that cos of theta and cos of theta cancel out. So now we have DC is equals to basically 2 AC sine of theta, right? But then we're supposed to determine DC in terms of age, right? So how are we gonna do that? Now, this is what I was talking about. Starting from the triangle that has the most information, moving to the triangle that has the least information. So now we're looking for the length of AC. So let me just highlight AC here for you. We're looking for AC, right? So to find AC, we're going to regard triangle ABC. In triangle ABC, we have 90 here. Here we have an angle theta. So we can use that angle. We can say that sine of theta is equals to the opposite divided by the hypotenuse. Here you can see now our hypotenuse is going to be AC, right? So we're basically done with the problem. So sine of theta will just stay as sine of theta because that angle is theta, right? So we're going to have sine of theta being equals to the opposite, which is h, divided by the hypotenuse, which is AC. And then if we solve for AC, we get AC is equals to h divided by sine theta. For the faint-hearted ones, what we did here, we cross-multiplied. We got AC sine of theta is equals to h, so AC will be h divided by sine of theta for the faint-hearted ones. So now that we have AC, right, we can substitute AC back into DC, right? So let me just do it there so that, yeah, you can see what I'm talking about. So now we're gonna have DC is equals to 2 multiplied by AC. AC, we're saying that is h divided by sine of theta, right? So we have h divided by sine of theta, and then multiply by sine of theta. Sine of theta and sine of theta, they cancel out. So DC is equals to 2h.
From the question statement, we know that our circle is centered at O. So let's go ahead and write it down. We have a center at O. What else do we know? We know that UV is a tangent to the circle at P. So we have tangent as another keyword that we are interested in. We are also told that SP is equals to SR. So we have SP being equals to SR. If you look at your diagram, you're going to realize also that OP is equals to OR because they are radiuses. So OP is equals to OR. Look at the vertices of PSRQ. They lie on the circumference of the circle. So we have a cyclic,
quad. This is all we need to answer all the questions that are going to follow. Let's look at 8.1.1. The question is saying, let's determine, given reasons, the size of angle PSR. So PSR is this angle right here. Right, let's go ahead and look at the first keyword, center. Well, if we add the size of O1, then O1 should be 2 times angle PSR. But we don't have the size of angle O1, so we cannot use that to determine PSR. Tangent. This angle here should be equals to PSR, but we don't have that angle as of yet, so we cannot use that to find angle PSR. SP is equals to SR. It will be easy to find the size of that angle if, for instance, we had P4 or we had R3, right? And then OP is equals to OR. It has nothing to do with that angle. And then the last keyword is cyclic quad. And as you can see, angle WQP, this angle here of 106 degrees, should be equal to angle PSR. An exterior angle of a cyclic quad is equal to interior opposite. So we can say that PSR is equal to 106 degrees. That is because an exterior angle of a cyclic quad is equal to interior opposite angle. Let's move to 8.1.2. So in 8.1.2, we're looking for the size of angle R3. We're looking for the size of angle R3. So let's replace angle PSR with 106. Let's replace that with 106. So we have 106, and we're looking for the angle for the size of angle R3. R3 should be equals to P4. Angles opposite equal size. So what does that mean? It means that P4 is equals to R3. Let's start here first, and then we can see that angles opposite equal size, they should be equal to each other. So now we can say that P4 plus R3 plus PSR is equals to 180 degrees, the sum of angles on a triangle. And then P4 is R3, so we basically have 2R3 plus PSR, which is 106 degrees, being equals to 180 degrees. So R3 is equals to 180 degrees minus 106 degrees divided by 2. And then if you put that in your calculator, you should get 37 degrees. So that is the size of angle R3 and P4, because R3 is equals to P4. Let's look at the question that follows, P5. So we're looking for the size of angle P5. Right, let's go back to our keywords, because that's the only thing we're supposed to use. Can we use the center to find the size of angle P5? Well, not quite. Can we use the tangent? Let's go ahead and find out. We have the tan chord theorem. So angle P5 should be equals to angle R3. Angle P5 should be equals to angle R3. That is the tan chord theorem. Yeah, the angle between the tangent and the chord should be equals to the angle subtended by that chord on the circumference of the circle. So 8.1.3, we're saying that P5 is equals to R3 because of the tan chord theorem. So P5 is actually 37 degrees. Let's move to 8.1.4. 8.1.4, we're looking for the size of O1. Well, like we have already deduced earlier in the video, we have said that O1 should be equals to 2 times angle PSR. Yeah, the angle at the center is twice the angle at the circumference, if they come from the same arc. So O1 is equals to 2 multiplied by PSR. So this is just 2 multiplied by 106, which is equals to 212 degrees. So O1 is equals to 212 degrees. Reason being that the angle at the center is 2 times the angle in the circumference. You have to give reasons for all the statements you're making. Let's look at 8.1.5. So 8.1.5, we're looking for the size of angle P3. Looking for the size of angle P3. Yeah, that should be easy to compute. Why am I saying that? P3 is equals to R2 because they are all radiuses, right? They are all radiuses. And then if we have the size of angle O1, then we have the size of this angle POR. So we can say that POR is equals to 360 minus 212 degrees, because the angle around the point is 360. That is 148 degrees. So now in triangle POR, we can say that P3 plus R2 plus 148 is equals to 180 degrees. But P3 is equals to R2. So we can go ahead and say that 2P3 is equals to 180 minus 148. We divide both sides by 2, and P3 should be equals to 180 minus 148. That will be 32 divided by 2, should be 16 degrees.
The answers to this question are actually on the question itself. Let me show you what I'm talking about. So this question here is saying that in the diagram below, A, B, C, D, and E are points on a circle centered at O. AC, OC, and ED are drawn, and then chord BC is equal to chord CD. So let's just go ahead and write that down. So we're saying that chord BC is equal to chord CD, right? And then we are told that let's let angle CED here be equals to X, right? And then let's look at our diagram. If you look at our diagram, you will realize that AOD is a diameter, right? There it is. So here in our keywords, let's just write diameter. Why are we writing that down? Because it's important in Euclidean geometry, right? So essentially, we should be able to solve our problems with only these two keywords here and nothing else, right? Except from just the basics, sum of angles in a straight line and so on. So let's look at 8.1. So we have 8.2.1. So 8.2.1 says that determine with reasons two other angles which are equals to X. So we are told by the first keyword, right, that chord BC is equals to chord CD, and we know fully well that equal chords subtend equal angles, right? So if you can see here, you will realize that chord CD subtends X, right? And then chord CD is equals to chord BC, and chord BC subtends A1, right? Equal chords subtend equal angles. So what are we saying now? We're saying that angle X is equals to A1, and then the reason for that is that equal chords subtend equal angles, right? Now let's look at our second keyword, diameter, right? What do we know about a diameter? All we know is that it subtends an angle on the circumference of a circle of 90 degrees, right? So this here is 90 degrees, but then that's all we know, nothing else. So let's go back to our first keyword and see how we can use the cos to find another angle which is equals to X. So you will now realize, if you haven't already, that not only does chord CD subtend this angle X here, but then it also subtends this angle A2 here. So that angle A2 is also equals to X because they have been subtended by the same chord. So now we can say that X is equals to A2. Why are we saying X is equals to A2? They have been subtended by the same chord, right? They've been subtended by the same chord on the circumference of our circle. So we have done 8.2.1. We can now do 8.2.2. So 8.2.2 is saying that let's determine the size of angle ABC in terms of x, right? So let me just clear these lines that I've drawn here so that we can have a bit of clarity. So we want the size of angle ABC. Yes, angle ABC here. Just place the dot. So again, we should be able to find the size of angle ABC just sticking to the basics and the keywords we have, right? In triangle, so let's regard triangle ACD, right? So in triangle ACD, you will realize that here A2 is x, right? So if you say that A2 plus this angle, which is 90 degrees, right? Plus angle ACD plus D1, this should be equals to 180 degrees, right? The sum of angles in a triangle. So now we're gonna have A2 is x, and then angle ACD, that is 90 degrees, right? And then plus D1 should be equals to 180 degrees. So D1, if we solve for D1, we should get 180 minus 90 minus x. So D1 should be 90 degrees minus x, right? So this angle here, D1, we're saying that it is 90 minus x. Now what you have to realize is that ABCD is a cyclic quad, right? All the corners of this quadrilateral, they are lying on the circumference of the circle. So what does that tell us? We know fully well that the opposite angles of a cyclic quad add up to 180, right? So we say that D1 plus our angle ABC that we're looking for, plus our angle ABC should be equals to 180 degrees, right? It's the basics, it's not me. So what is D1? We know fully well that D1 is 90 minus x, and then plus ABC should be equals to 180 degrees. If you solve for ABC, you're gonna get ABC being equals to some 180 degrees minus 90 plus x, right? So 90, when you take it to the other side, it will become minus 90, and then minus x, it will become plus x, right? So ABC will be equals to 180 minus 90, that is 90 plus x, right? And we have determined the size of angle ABC. And then last but not least, 8.2.3 says let's prove beyond reasonable doubt that AB is parallel to CO. So let's go ahead and look at AB and CO and see what we can do there. So we have AB here, and then this is CO. And they're telling us that these two, they're parallel, right? And we're supposed to prove that. If they're parallel, then this angle here, A1 plus A2, should be equals to angle O1, right? Corresponding angles, right? So we're saying that we need A1 plus A2 to be equals to O1. This is what we are required to prove, essentially, right? So let's see what we can do here. We know that A1 is x and A2 is x, right? So A1 plus A2 should be equals to x plus x. So this is equals to 2x. So if we find a way to say that O1 is equals to 2x, then we are done with our problem, right? But then I kid you not, if you look here, you will realize that O1 is an angle at the center, and it should be 2 times the angle at the circumference, right? So O1 here should be 2 times angle E, right? And angle E is x. So now it will be easy to see that O1 is equals to 2 multiplied by angle E, right? Why are we saying that? The angle at the center should be 2 times the angle at the circumference, right? So you write that down. We're saying that the angle at the center should be 2 times the angle at the circumference, right? So now we have O1 being equals to 2 multiplied by x. So now A1 plus A2 is indeed equals to 01 because they're all equals to 2x. And then by saying that, we've essentially proved that our line AB is parallel to CO. This is the easiest question because all the answers are given to you on the statement, right? So let's look at this. In the diagram below, BOA is a diameter. We know that in Euclidean geometry, a diameter is important to us, right? So let's take that as a keyword and write it down. So we have diameter, right? And then it goes on to say that of the circle centered at O, BA is a tangent. So let's write that down, tangent, because we know that we have the tan chord theorem, and where the tangent and the radius meet, we have an angle of 90. Now let's go on and see what else we have. We are told that EA cuts the circle at D, right? And then F is the midpoint of AD. So let me show you what we're talking about. So EA cuts the circle at D, and then F here is the midpoint of AD. If F is the midpoint of AD, then this angle here should be 90 degrees, and this angle should also be 90 degrees because of theorem 1. So let's write that down. We also have theorem 1. And then that's all the information we have, right? We don't have anything else. So we should be able to get the 11 marks for this question only using these 3 statements. So let's see what happens. We have 9.1.1, which says that let's prove given reasons that OBEF is a cyclic quadrilateral. OBEF is a cyclic quadrilateral, right? So let me just highlight OBEF. So here's OB, and then we have EF, and this should be a cyclic quadrilateral. So back to the definitions, right? If it's a cyclic quadrilateral, then what should happen? O1, right? This angle O1 should be equals to this angle E. The exterior angle should be equals to the interior opposite, right? Or F1 should be equals to the entire of B. That's if indeed it's a cyclic quad. So that's what we're essentially trying to prove. And then how are we going to prove it? We are going to stick to these 3 keywords that we have. So let's look at the diameter, right? Because the first keyword is diameter. So we have our diameter OB. Our diameter subtends angle D, right? Which is 90 degrees. But then that's all it does. It has nothing to do with what we're trying to prove, right? So at this point, our diameter is failing us. Let's move to the tangent. So we have the tangent EB, right? Which is subtending A. So now we can say that angle B2 is equals to A. But then that doesn't help us with anything, right? So we cannot use the tangent to answer this one. Let's look at theorem 1, right? So by theorem 1, we have already said that this angle F1 here is 90 degrees, right? We know that F1 is supposed to be equals to the entire of this angle B here, right? So now let's just say that F1 is equals to 90 degrees. Why are we saying so? We have a line from the center to the midpoint of a chord, right? That angle there should be 90 degrees. But then we need the entire of angle B to be also equals to 90 degrees. And then we will have proved that OBEF is a cyclic quadrilateral. And indeed, we can say that our angle B is equals to 90 degrees. And then you might be asking why. Why are we saying that? That is because the tangent will always be perpendicular to the radius, right? So that angle there should be equals to 90 degrees. So since angle B is equals to angle F, we have our cyclic quad because an exterior angle will be equals to opposite interior angle, as you can see. And then now let's do 9.1.2. So for 9.1.2, we're supposed to prove given reasons that triangle ADB, it's similar to triangle BDE. And let me tell you something, right? So the way they name their triangles in an examination, right? Angle A here should be equals to this angle B on the other triangle, and then angle D should be equal to angle D on the other triangle, and then consequently B and E should be equals to each other. So what are we saying? We're saying that let me just highlight the triangle so that we can have a bit of clarity, right? So we want triangle ADB, right? So let me highlight this. So we have triangle ADB, and then there we go, and we're also looking for triangle BDE, right? So we have BDE, right? So we're saying that angle A should be equals to angle B. So let's look at angle A here. Here we have angle A, right? We're saying that it should be equals to this angle B here. So let's go to our keywords and see which keyword we can use. You can already see that we're going to use the tangent, right? Because EB is a tangent and BD subtends angle A, right? So already here we can say that angle A is equals to angle B. And then why are we saying that? This is because of the tan-chord theorem, right? And then now we can go ahead and see that angle D in triangle ADB is equals to angle D in triangle BDE. So we're saying that this angle here should be equals to this angle here, right? Which keyword are we going to use? We have diameter, tangent, and theorem 1. We're going to use diameter in this question, right? Why are we saying diameter? Because D1 is equals to 90 degrees. Why are we saying is equals to 90 degrees? It's being subtended by a diameter, right? But then at the same time, D1 plus D2 should be equals to 180 degrees, right? This is the sum of angles on a straight line, right? The sum of angles on a straight line. So you can see here that consequently D2 will be equals to 180 minus 90, which is just 90 degrees. So now D1 is equals to D2. They're all equals to 90 degrees, right? It becomes easy to see now that this angle here B1 should be equals to the angle E, because they are the only remaining angles, right? So now we can see that B1 is equals to angle E, right? But then you don't have to say this, but then I'm just assuming that we might need to use it when we solve other problems. Let's move ahead with our equation. So we have 9.1.3. So 9.1.3 is saying, let's prove given reasons that OB is a tangent to the circle passing through BDE. So let's construct that circle so that we can have clarity, right? So we want a circle passing through BDE. So it's a circle that looks something like this. It's passing through B, it's passing through D, and then it should pass through E. So it's a circle like that, right? And now we have to prove that OB is a tangent. If OB is indeed a tangent, then the tan-chord theorem should hold. This angle here, B1, between a chord and the tangent should be equals to this angle E here, right? Which is subtended by that chord. How can that be true? That's what we were talking about in 9.1.2, right? That the true angles of those true triangles are equals to each other. So the remaining two should also be equals, because all those angles add up to 180 degrees in a triangle, right? So now we're just going to say that B1 is equals to angle E. And then why are we saying B1 is equals to angle E? Because third angle in a triangle, right? The third angles in a triangle should be equals to each other if the other two are equals to each other. And then where is the privilege to say that coming from? It's coming from the fact that triangle ADB is clearly similar to triangle BDE, right? Like we just proved. And now we can do 9.2, right? So 9.2 says that let's prove that OF squared is equals to AD, not triangle D, but AD multiplied by DE divided by 4. So as soon as you see a question asking you to prove something like this, right? It's either you have parallel lines or you have similar triangles. If you have parallel lines, then you can play with the sides. If you have similar triangles, then you can play with the sides, right? So clearly here, we have similar triangles, so we're going to use them, right? If we had parallel lines, we're going to use the parallel lines. We know fully well our theorems. So let's look at the sides we're interested in here. We're interested in AD, DE, and OF, right? We have triangle ADB, and here we have triangle BDE, right? And then which sides are we looking for? We're looking for AD and DE. So because the two triangles are similar, we can say that line AD, right, on this first triangle here, divided by line DB on that triangle will be equals to line BD, right, on this triangle here, divided by line DE, right? The sides will be in proportion because the two triangles are similar, right? And then we must state here that we're saying that because we know fully well that triangle ADB is similar to triangle BDE, right? So now we can cross multiply, and then we can get DB squared is equals to AD multiplied by DE, because look here, DB is just BD, right? So we can just say DB squared is equals to AD multiplied by DE. And then we're not done, right? Here we have DB squared, but in what we are required to prove, we have OF squared, right? So let's try and find how DB squared and OF squared are related. It's not really easy to see here, but then 2OF is equals to DB. Let me tell you why, right? Don't forget that we have already deduced that F1 is 90, right? But then also D1 is 90. Because it's been subtended by the diameter, right? So if F1 is 90 and D1 is 90, then we know that OF should be parallel to DB, right? OF is parallel to DB. But because F is the midpoint of AD, then we have AF being equals to FD. If AF is equals to FD, then OF should be half of DB. So that is why here I'm saying that 2OF is equals to DB, right? So if we substitute that back in our equation, we're gonna get 2OF squared being equals to AD multiplied by DE. So it should be easy to see now that we're gonna get 4OF squared is equals to AD multiplied by DE. So now we divide in both sides by 4, right? If we do that, we get OF squared is equals to AD multiplied by DE, and then everything divided by 4.
Determine the equation of the least squares regression line for the data. So let's take a look and see what's happening. So we have the weight of 15 players, right, of a rugby team. And then we have the number of push-ups per minute that they can do. 1.1, determine the equation of the least squares regression line for the data. So the weight is our X, right? And then the number of push-ups that a person can do in a minute is our Y. Well, we don't even have to guess that or find a way to reach that conclusion ourselves. It is given, right? Weight, and then in brackets we have X, and then the number of push-ups we have Y. So we want to find the equation of the least squares regression line. So that is to say, we are looking for Y is equals to A plus BX. We are going to use our calculator in order to do this. So let me show you how we do that. We want to go to our calculator, press mode setup, and then we want to press 3, right? Because that's the option for stat. So after you press 3, then you press option 2, which says A plus BX. In a different calculator, it can be a different option, but we want the number that has A plus BX. Press that number, and then we can enter our X values. So you can see the data that we have 34, followed by 32, 40, 27. You have to be very careful when you enter your data, because if you make one mistake, all the answers are going to be incorrect if you make one mistake. So you have to be very careful when you enter this data. After 27, we have 55, and then, is that 39? Yes, 39, 44, followed by 30, 57, 28, 32, and 31. Right, so those are our 15 entries as far as the x values are concerned. So now we need to go up there and enter the corresponding y values, right? So we have 26, 21, followed by 6, and then we have 20, 16, followed by 26, 33, oh, 23, not 33. You see there, almost made a mistake and all my answers were going to be incorrect. So 28 goes with 26, 27 goes with 23. Okay, and then 55 goes with 7. And then we have 18, 14, 17, 8, 28, and lastly, oh, not lastly, but second last, 25. And lastly, we have 20. So we've entered our data, right? I press equals to, and then after that, I can press AC, right? And then I press Shift 1, and then I press 5, right? That REG, I think it stands for regression. And then when we press 5, we have our variables. You can see we have A, we have B, right? So when I press 1, in order to access the value of A, and then press equals to, and then that is 39.46. So A is equals to 39.46. What about B? So I press AC, Shift 1, 5 for regression, and then B. So I press 2, and that is minus 0.59. So that's the value of A, that's the value of B. So Y is equals to 39.46 minus 0.59x, right? So that is the first question, 1.1 out of 3 marks. And then 1.2, we're looking for the correlation coefficient. So that is R, right? So we've already entered our data. We just press AC, Shift 1, 5, and then you can see that R is option 3 there. And then when I press equals to, I get minus 0.7979. So minus 0.8. That is the correlation coefficient. And then 1.4, write down the mean number of push-ups for the given data. The mean number of push-ups for the given data. So the number of push-ups is our Y, right? Let's see if we can find that when we press Shift 1. So Shift 1, and then let me hit 5 and see what happens. We have X and Y there. Yeah, I think that is Y bar. Let's see. 5 is equals to, oh, okay. Did I just get error? Okay, so I don't know whether that is supposed to give us the mean or what, but just to be safe, let's just press Shift 9, clear everything, you know, exit stats, and then just calculate the average manually. So we want the mean number of push-ups. So the mean number of push-ups, so our Y bar is going to be equals to. So now we need to enter all those numbers on Y, right? So 26 plus 21, plus 21 plus 6 plus 20 plus 16 plus 26 plus 23 plus 7 plus 18 plus 14 plus 17 And then we have 8, 28, 25 plus 20. And then we divide that with 15, right? Because we know that we're talking about 15 players here. And then that is 18.3 recurring. So the mean number of push-ups for the given data is 18.33. That is 1.4. Right. Does it make sense to be 18.33? It makes sense. The highest number is 28. Most numbers are below 20. So a mean of 18.3 makes sense. Okay. And then 1.6, or not 1.6, but 1.5. The players trained hard during the season. Well, you would like to assume. At the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the last season. How does the increase in the number of push-ups influence the standard deviation of the data? This is just theory, essentially, right? This question does not have anything to do with the question we have at hand. It's just testing to see if you know the theory. So if all the numbers, all the data points increase but the same value, it's not going to affect the standard deviation. The standard deviation is still going to be the same. They're going to deviate from each other by the same number because they've all increased in the same fashion. If it was decreased, they would have all decreased in the same fashion. So there's no difference in the standard deviation. So yeah, standard deviation remains the same. And then 1.6, I want you to let me know in the comments. At the beginning of the season, the coach used the least squares regression line as the minimum target for a player to aim for. Determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. Right, so that is for 2 marks. Let me know in the comments, how do you approach this question? 1.6, there we go. Let's calculate the gradient of DC. The best thing to do in this case is to choose which point between C and D we are taking as 0.2 and which point we are taking as 0.1. So if we take point C as 0.1, we're going to have x1, y1. And then if we take D as our second point, we're going to have x2, y2. But whatever point you take as 0.1, 0.2, it really doesn't matter. We should get to the same answer ultimately. So let's go ahead and do that. The gradient of DC will be equals to y2 minus y1, everything divided by x2 minus x1. Sticking to the basics, right? So in our case, y2 is going to be minus 9 minus y1, which is 0. Everything divided by x2, which is 3, minus x1, which is minus 9. So this is equals to minus 9 divided by plus 12, right? And then if you put this in your calculator, or if you simply divide the numerator and the denominator by 3, you should get minus 3 divided by 4. So this right here is the gradient of DC. Sticking to the basics, nothing complicated really. And then the second question, 3.2, determine the equation of DC. So we're looking for the equation of DC in the form y is equals to mx plus c. Another equation that is very basic, right? No complications. We're just sticking to the basics here. We have 2 points C and D. We want to find the equation. So there shouldn't be no way to run this equation for ourselves. It's really straightforward. Doesn't require us to come up with any creativity whatsoever. But anyway, stories. Let's take a look. 3.2. So the gradient, we already know that it is minus 3 over 4 x plus c, right? And then we can substitute D, we can substitute C, and then find C, right? C, I mean the constant, and we will have our equation. So if we substitute C, I want to substitute C because I have 0 there and it is going to make my life simple. C has coordinates minus 9 and 0. So when we substitute it here, we're going to have the y value is 0, minus 3 over 4, x is minus 9. plus c. So we have 0 being equals to minus 3 multiplied by minus 9, that is plus 27, 9, 18, 27, right? Divided by 4 plus c. Should be easy to see that c is equals to minus 27 over 4. So what is y? Y is equals to minus 3 over 4x minus 27 over 4. There we go. We have the equation of DC. Sticking to the basics. Let's take a look at 3.3. So in 3.3, we're supposed to show that k is equals to minus 6. K is the y value at B, right? Is the y value at B. And B is a point that lies on the line CD. So we already have the equation. We know that B has coordinates minus 1 and k. If we substitute this in our equation, in place of y, we put k. And then in place of x, we substitute minus 1. And then minus 27 over 4. So k is equals to minus 3 multiplied by minus 1. That will be 3. So 3 over 4 minus 27 over 4. And then this is just a minus 24 over 4. 6, 12, 18, 24. So this is equals to minus 6. So there we go. Just like we're supposed to show, k is indeed equals to minus 6. What about 3.4? Calculate the length of DC. So if you take a look at this question, 3.1, 3.2 up to 3.4, there's really no creativity. We are just sticking to the basics, right? So in order to find DC, well, we have the distance formula being y2 minus y1 squared plus x2 minus x1 squared. But I'm going to take a shortcut here, if you allow me to do that. So take a look at this. Y2 minus y1. We already have that when we were calculating the gradient, right? Y2 minus y1 is minus 9. So here I have minus 9 squared plus x2 minus x1 is plus 12. So I have plus 12 squared. So now you just put that in your calculator and DC is equals to 15 units, right? And then 3.5, calculate the ratio of dB over DC. Ratio of dB over DC. dB is a length, right? And the DC is also a length. Okay, so how can we solve this question? The problem that we have here is that we don't have the coordinates of B. That is a problem. Oh, well, at this point we do, because we have the value of k. We know fully well that it is minus 6. So we have the value of k. So option 1. Option 1 is to calculate the length of dB, right? Because we already have the length of DC. DC is equals to 15 units. So we can just calculate the length of dB, and then we find the ratio of the two. We say dB over DC. And then there's another option. We can just rotate this. Oh, okay, I can't rotate this. I wanted to rotate the diagram here. But then if you rotate this diagram, this can be a straight line if you rotate it, right? Anti-clockwise. And then you just find the distance from C to B and the distance from B to D. But let's just calculate the length of dB. It's fine. So the length of dB, therefore, will be equals to y2. Let's take D as our second point. So we're going to have minus 9 minus minus 6, because k is minus 6, right? So that is plus 6 squared, plus x2 3 plus 1 squared. Okay, so if you put this in your calculator, I mean, we have minus 9 plus 6, that is going to give us 3, and then 3 plus 1 is 4. So we have a triangle here. One side is 3, another is 4. The hypotenuse will be 5. So dB is 5 units. So dB over DC is equals to, what is dB? dB is 5, DC is 15. So this is equals to 1 over 3. So there we go. Right. I do realize that there are other ways we can use to solve this question, but if you get to 1 over 3 and then you didn't break any rule, you should probably be fine. And then that is 3.5. Let's take a look at 3.6. So 3.6, it's out of 4 marks, but for some reason I did take more time thinking about 3.6 as compared to 3.7. I didn't take much time with 3.7 because we need to do a lot of things, but it is a very basic equation. We have seen such equations before. The problem was with 3.6. Maybe it has been there before, but I don't remember solving 3.6, so I had to really think. So let's take a look and see what is happening. If M is a point on AD, okay, so let me just erase some of this junk. M is a point on AD such that AC is parallel to MB. Calculate the ratio of the area of MBD divided by the area of ACD. So, okay, we need some point on AD such that AD and MB are parallel to each other. So, you can see that I'm using a ruler here. So, I just need to go down until I touch a point B. And then I will draw a line and put M. So, there we go. I just need to put a line here. And here I have my coordinate M. So, yeah, M is such that CAC and MB are parallel to each other. So there we go, I have M. But I want the area of this true triangle, MBD. So area of MBD, triangle MBD. So let's go ahead and take a look at triangle MBD. Let's just highlight triangle MBD, right? It's the smaller one. This is MBD. Let me change the color and take a look at the other triangle. The other triangle that we're interested in is triangle ACD. So ACD, right? We have two triangles here, and then MB is parallel to AC, and we want to find the ratio of the triangles. One thing that I realized is that, okay, in 3.5, I found the ratio of DB over DC. So I assume that is essential in 3.6. I might need to use that, right? So let's just keep it in mind that DB over DC is equals to 1 over 3. But we cannot calculate the area with just one side, right? We cannot calculate the area with just one side. We need two sides and the angle that they sandwich. Okay, but take a look at this. Let me show you something. I realized not fairly quick after some time. Not fairly quick. It was not quick. It took some time. So I realized that this true triangle, what is this point again? This is point D. This is point D. These two triangles are similar to each other. That's what I ended up realizing. Let me prove the similarity. First of all, in these two triangles, triangle AMBD and triangle ACD, you will realize that angle D is equals to angle D, right? That is just a common angle. This angle right here is just a common angle. Apart from that, you will realize that this angle here, right, angle MBD should be equals to angle ACD, right? Angle MBD should be equals to angle ACD. They should be equals to each other because the two lines AC is parallel to MB. So the two angles should be equal to each other. So we have proved that two pairs of angles are equal to each other. Of course, the third angle is going to be equal. So now we know that triangle MBD is similar to triangle ACD, right? Now we know that. But why is it essential for us to prove similarity? We want to prove similarity so that we can use proportions. We want to prove similarity so that we can use proportions, right? Proving similarity is the only thing that will allow us to use proportions here as far as this question is concerned. So let me show you what we're going to do. Therefore, we can say that we already know from the question above, right, that DB, well, what am I saying? that dB over dC is equals to 1 over 3. Right, we already know that. But now we can play around with the other sides. Okay, so what can we say? We can say that, dB over dC, right, should be equals to, let's pick any other side. It is equals to, we can say dB over dC is equals to dm over dA, right, the other side, because we said that these divided by these, but now because we know that the two triangles are similar, we can now say these divided by this should also be equals to the ratio of the other sides. So this should also be equals to 1 over 3, right? And why are we saying that? Because the two triangles are similar. MBD is similar to triangle ACD. So we've proved that the two triangles are similar and that all the sides will be in proportion, therefore. But why are we doing that? Let me show you. We can say that the area of triangle MBD, the smaller triangle, right, is equals to half dB multiplied by dm, and then we say sine of angle D, right? Because angle D is the side, is the angle that those two sides sandwich. And then as far as the area of triangle ADC is concerned, we can say half, and then we use DC and DA, right? And then we take sine of the same angle because well, it is the same angle that is sandwiched by those two sides. So now we can proceed to the ratio and say that the area of triangle MBD over the area of triangle ADC is equals to a half dB dm sine of angle D, everything divided by a half DC dA sine of angle D, right? So take a look at this. A half and a half cancels out, sine of angle D and sine of angle D cancels out. We are left with dB over DC multiplied by dm over dA. dB over DC, what is dB over DC? We know that dB is 1, right, 1 unit, and then DC, yeah, so from D to B we know that it is 5 units, and then from D to C, let's take a look once more. Let me make sure that I'm not making any mistake here. From D to C, is it 3 units? From D to C, we had 15 here from D to C, and then from D to B we had 1, right? So okay, everything is fine. So dB, we have 1 there, and then DC we have 3, multiplied by dm, same thing, right, 1 over 3. So we are going to have 1 multiplied by 1, which is 1, 3 multiplied by 3, which is 9. So the ratio of the area of the two triangles is 1 over 9. So there we go. That is 3.7. And then 3.6 I meant. 3.7, it is further given that the gradient of AD is minus 4. So the gradient of AD is minus 4. And the length of AD is 612 units. So the length of AD is 612 units. So we can say that y, right, being the equation of AD is equals to minus 4x plus c. So let's take a look at AD. We do have the coordinates of D, which happen to be 3 and minus 9. Okay, so we can substitute this here, right, where y is minus 9 and then minus 4 multiplied by 3 plus c. So minus 9 is equals to minus 12 plus c. So 3 is equals to c. Okay, so we have y being equals to minus 4x plus 3 as the equation of the line AD. Okay, but we are looking for the coordinates of A. So now that we have the equation of AD, we can say that instead of having the coordinates of A as some x and y, we can say that A is x, but x being x, y should be minus 4x plus 3. This should not be groundbreaking. Should have come across something like this at some point of time. So those are the coordinates of A. Let's now use the other piece of information that we have to actually find the coordinates of A, because now we have the coordinates of A in terms of x and y, right? But we can use this distance to actually find the coordinates of A. So we can say that AD is equals to the square root of x2 minus x1. So let's take D as our second point. X2 is going to be 3. So we have 3 minus x squared, right? And then plus y2. Y2 is minus 9. So we have minus 9 minus 4x plus 3. So that is going to be plus 4x minus 3. Okay, so AD is equals to the square root of, let's not forget that we have AD. AD is square root of 612. So square root of 612. So we have 3 minus x squared, right? And then here we have plus minus 9 minus 3. Minus 9 minus 3, that is minus 12. So we have 4x minus 12 squared. So what do we want to do? We want to square both sides. So let's go ahead and do that. If we square both sides, we're going to get 612, right? And then we get rid of that square root, and then we just solve what's inside the brackets there. So when we solve that, minus x multiplied by minus x is x squared, and then we have minus 6x plus 9. That is that first part. And then the second part, seems like I need my calculator now. We have 4x multiplied by 4x, that is 16x squared. And then minus 12 multiplied by 4, that is minus 12 minus 24 minus 48. And we multiply that by 2, minus 96. So we have minus 96x and then plus 144. So 612 is equals to x squared minus 6x minus 96x. Oh, well, we have 16 here. It's 16 there. So let's write that as 17x squared and add those two. And then minus 6x minus 96x. So 96 plus 6, that is 102. So we have minus 102x. And then 9 plus 144. So 144 plus 10 is 154. So that is 153. So we have plus 153. And then we take 612 to the other side. Okay, so 17x squared minus 102x plus 153. I'm going to take my calculator. Clearly, I underestimated the problem. So we have 553 minus 612, which is minus 459, being equals to 0. So let me see if I can divide all these terms by 17. 459 divided by 17. Yeah, 17 is a factor of all these terms. So we have x squared 102 divided by 17 minus 6x. 459 divided by 17 minus 27, being equals to 0. Factors of 27, 9, 18, 27, 9 and 3. Okay, so x plus 9, no, minus 9 multiplied by x plus 3. I think this works. Yes, so x is equals to 9, or x is equals to minus 3. But I like minus 3. because A is in the second quadrant, so its x value must be negative, right? So now that I have x, let me substitute it into minus 4x plus c. What is c? C is 3. Okay, so this should give us 15. So the coordinates of x is minus 3, y is 15. There we go. Tell me, which video should we do next? Here we go. Let's take a look at 4.1. Write down the coordinates of L. So I do have a few issues with this equation. I'm about to show you why in a second. So let's take a look at the equation statement. In the diagram, M is the center of the circle. The center cuts the x-axis at N. Easy to see on the diagram. ST is a tangent to the circle at P. Easy to see also. We have the point R and then L lie on circle. O and V are the x-intercepts of PL. O and V. Okay, O and V are the x-intercepts of PL and RL respectively. Okay, I was a bit surprised, but there we go. That is the information we have. And we are supposed to somehow write down the coordinates of L. So the assumption here, only possible solution to this question is to assume that PL is a straight line. That is the only way we can be able to find the coordinates of L, which is not given, right? It is not said that PL is a diameter, or it's not said that PM and L are collinear. They do look like they form a straight line, but it is not said. So I have a problem with that, because since when do we just assume? We don't have that information, but we're expected to assume, right? I did say the same thing about equation in mathematics paper 1, that we were supposed to make an assumption that A is an x-intercept, while it is not told. Why it is not, there's no hint to suggest that it is, right? So let's go ahead and find the coordinates of L. But I don't like the equation, because we have to assume that PL is a straight line, which might not necessarily be true. But either way, if PL is a straight line, take a look at this. M is the midpoint, because M is the center of the circle, right? So the distance from P to L is equal to the distance from M to L, right? So we are going to use translation to find the coordinates of L. We don't have to use translation. We can find the equation of the line, right? Because we have P and M. We can find the equation of the line. But if we use the translation, take a look at this. So we have L, we have M, and we have P. So let's look at their coordinates, right? So the x coordinate of M is 1. The x coordinate of P is 3. So the difference in the x coordinates from M to P should be the same difference from L to M, because M is essentially the midpoint of PL, right? So if the x coordinate of M is 1 and that of P is 3, the difference is 2. That should be easy to see. The same should be true with regards to the distance from L to M. So here we must have minus 1, right? Because from minus 1 to 1 is 2 units. From 1 to 3 is 2 units. We can do the same about the y values. So the y value of P is 9. That of M is 3. We can see that the difference is 6. So what must be the y value of L? It must be minus 3. So this is L, minus 1 and minus 3. Obviously, you can use, what do we call this? We can use the midpoint theorem also and find the coordinates of L. But anyway, stories. Let's take a look at 4.2. So 4.2, determine the equation of tangent ST to the circle at P. So we are interested in the tangent of ST. So the tangent ST rather. Let me just highlight that. So this is too thick, you know. Let's be a bit slim. So this is ST. This is ST. ST is that tangent. Obviously, we know that the tangent is perpendicular to the radius, right? And MP is clearly a radius. So we can say that the gradient of MP multiplied by the gradient of ST should give us minus 1. So the gradient of ST is equals to minus 1 divided by the gradient of MP. right? But then what is the gradient of MP? The gradient of MP, y2 minus y1 divided by x2 minus x1, right? So we're going to have minus 1 divided by the gradient of MP. So let's take P as our second point. If we do that, y2 minus y1 is going to be 9 minus 3, right? And then x2 minus x1 is going to be 3 minus 1. So this is equals to minus 1 divided by 9 minus 3 is 6. 3 minus 1 is 2. So 6 divided by 2 is 3. So this is the gradient of ST. It is minus 1 over 3. The question says the tangent, actually, not the gradient, but we are a step closer. So we have y is equals to minus 1 over 3 x plus c. We just need to substitute a point on ST, which is P. So if we substitute P of coordinates 3 and 9, we're going to have 9 being equals to minus 1 over 3 x plus c. Well, x is 3 here because we're substituting P. So we have 3 plus c. 9 is equals to minus 1 plus c. 10 is equals to c. So y is equals to minus 1 over 3 x plus 10. We're good to go. Okay, so this is 4.2. Let's take a look at 4.3. So 4.3 says that show that the equation of the circle with center M is x squared plus y squared minus 2x minus 6y minus 30 is equals to 0. Okay, I think this is we should be grateful that this is the equation that we found in the exam. Most people, if they're given this and they're supposed to write it in the other form, x minus a squared plus y minus b squared is equals to r squared, they are going to have issues compared to if you're given if you're given, what do we call this? If you're given the point and the center and you're supposed to write it in that way. But anyway, stories. We know fully well that the equation of the circle, well, I've already written that it is 4.3, can be given by x minus a squared plus y minus b squared is equals to r squared. So our center is M, right? 1 and 3. So we're going to have x minus 1 squared plus y minus 3 squared being equals to r squared. Do we have the radius? Okay, we don't have the radius at this point, but obviously we can find the radius. Yeah, let's just go ahead and, okay, let me just say r squared. Let me find the radius, right? So the radius, we can use MP. We can use MP because MP is the radius. And then this is y2 minus y1 squared plus x2 minus x1 squared. So we're going to have 9 minus 3 squared plus 3 minus 1 squared. Okay, so MP is equals to square root of 9 minus 3, that's 6, so we have 36 plus 4, right? So let's square MP. Let's square both sides because we are looking for the radius squared either way. So MP squared is equals to, this is 36, so MP squared is equals to 40. Okay, so we know that radius squared is 40, right? And then x minus 1 squared, that is x squared minus 2x plus 1. And then we have y minus 3 squared, that is going to be plus y squared minus 6y plus 9. Everything is equals to 40 because r squared is 40. So let's rewrite that in this form that we are supposed to. So we have x squared plus y squared, right? It is there. We're just putting them next to each other. And then minus 2x. It's easy to see how that comes about. Minus 6y. And then plus 1 plus 9 is 10. And then 10 minus 40 is minus 30. So this is what we are supposed to show. And yeah, as you can see, we have that. And then now in 4.4, we are supposed to show that D is equals to 7. So D is the x coordinate of R, where the y coordinate is 1. So right, we can substitute r into this equation in that form, or we can substitute r there. I think it's better if we substitute it here, right? So we have x minus 1 squared plus y minus 3 squared is equals to 40, right? X is what you're looking for, so we have d minus 1 squared plus y 1 minus 3 squared is equals to 40. So d minus 1 squared, 1 minus 3, that is minus 2, we square that, we get plus 4. So plus 4 is equals to 40. So d minus 1 squared is equals to 36. I can take square roots on both sides. D minus 1 is equals to, well, plus or minus, okay, d minus 1 is equals to 6. Let me not complicate things. D is equals to 7, right? We have showed that d is equals to 7. If you substitute r on the other equation, it is also fine. It is also fine. You don't have to ask me and say, if I substitute it in the other equation, is it also fine? Will I get all the marks? It is fine. As long as you're not lying. As long as everything is mathematically correct. So that is 4.4. Now let's take a look at 4.5. So 4.5, calculate the size of angle L. So we are looking for the size of this angle. We're looking for the size of this angle. Let me just put a dot there. But we found the coordinates of L by saying that PL should be a diameter, right? And then if PL is a diameter, this here should be 90 degrees. This here should be 90 degrees. If that is 90 degrees, and then we have L, not L, but ML, and then here we have MP. We will end up with equal angles, like opposite angles, not opposite angles, opposite angles opposite equal sides. That's what I'm looking for. We're going to end up with angles opposite equal sides. That's what we are going to end up with. We're going to end up with angles opposite equal sides. Okay, so we will end up with having angle R plus angle L plus angle P being equals to 180 degrees, because those are that's the sum of angles on a triangle. But angle P should be equals to angle R, not R, but angle L rather, should be equals to angle L, right? So by saying that, we can then say angle R plus 2 angle L is 180 degrees. But you know that R is 90, so we have 2L being equals to 90, right? 180 minus 90. So angle L should be 45 degrees. That is 4.5. Okay. And then let's carry on. 4.6. TR is a tangent to the circle at R. So let's just, okay, this is TR. This is TR. It is a tangent to the circle at R. And then the question says, prove that PT is perpendicular to RT. So I'm not gonna give myself a headache. I'm just gonna find the gradient of PT and find the gradient of RT and compare the two. We do have the gradient of PT because PT same as ST, right, is the same line. So let's just go up and see what that gradient is equals to. Minus 1 over 3. So the gradient of PT is equals to minus 1 over 3. This is from 4.82. Yeah, because PT and ST, coordinates of the same line. So we have that. Now we just need the gradient of RT. So how can we do that? Well, we can find the gradient of MR, because MR should be a radius there, and then that gradient should be perpendicular to that of RT. So the gradient of MR is equals to y2 minus y1 divided by x2 minus x1. What is y2? Let's take the coordinates of R. Y is 1, and then y2 is 1, y1 should be 3. And then the coordinates of D is 7, so we have 7 minus 1. So this is minus 2 divided by 6, which is equals to minus 1 over 3. So the gradient of MR multiplied by gradient of TR should be minus 1. So the gradient of TR is minus 1 divided by minus 1 over 3, which is equals to 3. So 3 multiplied by, this is the gradient of TR, multiplied by minus 1 over 3, the gradient of PT, gives us minus 1. So we have showed that these two lines are perpendicular to each other, as we can clearly see here. But in closing, let's go back to 4.5. I'm thinking about something here. Is it that easy? Do we just say L is equals to P? Do we just say L is equals to P? Do we do that? Or we have to actually show first that RL is equals to PT? Do we have to show first that RL is equals to PT? Well, if we have to show first, we have the coordinates of P, we have the coordinates of R, we have the coordinates of L. So we can find PR and find LR to convince ourselves that indeed PR is equals to LR. And then we can use angles opposite equal sides. There we go. Which video do you want me to do next? Let me know in the comments. Determine without using a calculator the value of cos A. So let's go ahead and take a look at what is happening. So we have a point P, which is what we usually have, right? And then on this point P, obviously we have the X and the Y. The X happens to be minus 3 and the Y value is minus 4. Why don't we find the hypotenuse? Why don't we find R from the get-go? So if we do that, R squared plus, well, not R squared plus, but R squared should be equals to X squared plus Y squared. So R squared will be equals to minus 3 squared plus minus 4 squared. Should be easy to see that R is actually equals to 5. So we have our X, our Y, and our hypotenuse. Minus 3, minus 4, and 5. Now let's go ahead and solve our equations. We are looking for cos of A. So cos of theta is equals to the adjacent over the hypotenuse, right? The adjacent is usually the X and the hypotenuse is R. So in this case of ours, we're going to have cos of A being equals to minus 3 over 5. Okay, and then 5.1.2, we have cos of 2A. This is very typical that 5.1.1 will be pretty much straightforward, and 5.1.2 we have these kind of trig ratios. We have cos of 2A. It is very typical, but we just need to know that cos of 2A is equals to 1 we just need to recall that cos of 2A is equals to 2 cos of A squared. Cos of A squared, let me just rewrite that, cos of A squared minus 1. So do we have cos of A? We do. So we're going to have 2 cos of A is minus 3 over 5. We square that and subtract 1. So let me just put that in my calculator and not complicate my life. So 2 multiplied by minus 3 over 5 squared minus 1. That is minus 7 over 25. So we have minus 7 over 25. Okay. And then the equation that follows, 5.1.3, we are determining the value of sine of A minus B if it is given that sine of b is equals to 4 over 5, where b lies between 90 and 360. Okay, so let's take a look. We know from the basics, right, that sine of a minus b is equals to something. So the best thing to do with this kind of questions is to not write the formula from your head. You have the question paper, copy it down. So in this case, we will have sine a cos b minus cos a sine b. Okay, so we have sine b, it is given to us, right, 4 over 5. And then what else do we have? We have sine b, and we have cos a. We have cos a from the question above. So we have sine b and cos a. So what is there to worry about? We need to find a way to find sine a and a way to find cos b. So let's think about that and see what happens. We are given that sine of b is equals to 4 over 5. Sine is equals to the opposite, which is y, over the hypotenuse, which is r, right? So we can find x using that. We can say that x squared plus y squared is equals to r squared. So x squared is equals to 5 squared minus 4 squared. So x squared is equals to 9. X is equals to plus or minus 3. So there we go. We have plus or minus 3. We have a decision to make. Is it plus 3 or minus 3? That's where these information comes in handy. So B range is running from 90. So from 90 is somewhere here, right, to 360. Yeah, that's where B is running. So what is the okay, so let's just sketch. Let's just sketch, because I don't want to explain too many things without sketching, because it will become a bit troublesome. So we have our Cartesian plane there. We have y. Y is 4, right? So y is right here. We have 4. And then our x, that's what you're looking for. Is it plus 3 or minus 3? Okay. Our angle is between 90 and 360, right? So we can take x as minus 3. So there we go. We have x is minus 3, and then our r is going to be 5. Okay. So there we go. We can have that like that. So that will help us with sine A and cos B. So sine A is from the diagram we started with, right? So sine A should be opposite y over r. So sine A y, we said that it is minus 4, right? And r is 5. And then what about cos? Is it cos that you are worried about? Cos of b. Cos of b, it is gonna be x over r. So let's figure out what that is. X minus 3 r is 5. So there we go. We have sine A and cos of b. So sine A minus b is going to be equals to sine A, which is, let me take a look. Sine A. Sine A is y over r, right? So minus 4 over 5. And then cos B. Cos B is minus 3 over 5. Then we have minus cos A. Cos A, we calculated it in 5.1.1. It is, let's see. Oh, okay, let's see. Minus 3 over 5. So we have minus 3 over 5. And then what about sine B? Sine B, cos, that is cos A. What about sine B? Do we have sine B? Yeah, sine B is 4 over 5. So we have 4/5. Okay, so let's take a look. Let me just put that in my calculator and not complicate my life. Minus 4/5 minus 3/5 minus 3/5 multiplied by 4/5. I get 24/25. So yes, that's what we end up with there. And then 5.2. Yeah, 5.2 is quite a beautiful equation. 5.2 is quite a beautiful equation. Let me show you why I say that. So if cos of alpha is equals to p, express the following in terms of p. Yeah, we have that expression there, right? But let me just show you something. Let's slow down a bit. Okay, we know that sine of 2x is equals to 2 sine of x cos of x. So from this, it should be easy to see that sine of x cos of x is equals to sine of 2x over 2. So I want us to apply this idea here, right? Because here we have cos of what is inside the brackets here, and then we have sine of what is inside the bracket over 2, right? So sine of x cos of x is equals to sine of 2x over 2. So we want to use this in order to answer this question. So in our case, sine of 2x in our case, so we have sine of, in our case, we have, let me open a bra first. Okay, we have sine of 2, right? And then x is alpha over 2 minus 45. This is what we have in our case. Everything divided by 2, right? And then this is equals to sine of 2 and 2. I will cancel out, right? We're gonna be left with alpha minus 90. Everything over 2, right? So we can substitute this back here, right? Because this thing is equals to sine of x cos of x, right? So we will say that on the numerator here, we're going to have sine of alpha minus 90 over 2, right? These two, and then everything divided by, let me write that again, everything divided by 2, these two, right? So this is going to be equals to sine of alpha minus 90 over 4, right? So what is sine of alpha minus 90? Sine of alpha minus 90 is equals to minus cos of alpha over 4. So this is where 5.2 ends up. It's the last question, 7.4, that I'm really interested in, and you'll see why. Let's go through 7.1 first. So the question, write down the equation of the asymptote of f in the interval 0 to 180. Like I said, when we're doing paper 1, most people, they know the answers to this kind of question. But the problem is the interval. They forget to only look at the interval. So we wanted the equation of the asymptote of f in the interval x runs from 0 to 180. Let me show you what happens here. So we have to focus on only this interval. If you look at everything else, anything else, it is wrong. You need to focus on only this interval. Let me show you what I mean by that. So we can see that between 0 and 80, we have a asymptote at x is equals to 90. So the answer to 7.1, x is equals to 90. You might think it's not a big deal, but I can assure you there's somebody else who took minus 90, right? They forget to only focus on the interval that is given. But anyway, stories. Let's take a look at 7.2. So 7.2, write down the values of x in the interval. Again, we have an interval which we need to pay attention to. Minus 180 to 0. So minus 180 to 0. where f of x is less than 0. It's less or equals to, rather. Right. So we are looking for where f of x is 0 or negative, essentially, in that interval. So let's take a look. From minus 180 to 90 degrees, we can see that it is greater than 0, right? Well, at minus 180 is equals to, is it defined at minus 180? That's another question we should ask ourselves. Is it defined at minus 180? At minus 180, okay, it is defined. So we don't have an issue there at minus 180. So minus 180 should be part of our solution. Why do I say it should be part of our solution? Because you're looking for parts where f of x is less or equals to 0 in this interval. And that interval includes minus 180. So already we can see that x, oh well, let me change the color there. Already we can see that x is equals to 180 degrees, because when x is equals to 180 degrees, tan of 180 is 0. So that should be minus 180. I think the effect should be the same, really. Yes, it is the same. Tan of 180 is equals to tan of minus 180. So that is part of our solution. But then from minus 180 to, I don't want to say to 90, but to very close to minus 90, we can see that it is greater than 0. So we are not looking for that. That is not part of our solution. But when we go from minus 90 to 0, you can see that it is less than 0. So that should be part of our solution. X is also an element of, do we include minus 90? We don't. Why don't we include minus 90? Because it is not defined. But do we include 0? Let's see. Tan of 0 is equals to 0. It is defined there. So let's include 0 because it is defined at 0. So this is the values of x for which f of x is less or equals to 0. There we go. Okay. So that is 7.2. Let's take a look at 7.3. 7.1. Okay, let's take a look and see what is happening. We're given that g of x is equals to cos of 2x plus 1. The question says write down the period of g. So obviously the period is going to be equals to 360 over 2. Where are we getting the 2? Right here, right? Where it says cos of 2x. Yeah, we divide 360 by that 2. And then the period is going to be 180 degrees. So we have the period. And 7.3.2 on the grid given in the answer book, draw the graph of g of x is equals to cos of 2x plus 1 for the interval, and clearly show the intercepts with the axis as well as the coordinates of the turning points. Okay, so I don't have the grid, obviously. So I'm just going to use this Cartesian plane that is already in front of us here. So let's see how we can use that in order to actually answer this question. So which interval do I want to use? Let me use an interval of 30. So from minus 180, I'm going to have minus 150. I'm going to have minus 120, minus 90, minus 60, minus 30, 30, 60, 90, 120, 150. What's the interval again? Minus 180 to 180. So I need all those points. I need to substitute those points into, I need to put that in my calculator and find the corresponding y values. Okay, so cos of 2 multiplied by what? 120 minus 120, everything plus 1. So I'm getting a half. So we have a coordinate here. Oh, not there, but I shall start with minus 180 and not minus 120. What am I doing? So here we get 2, right? So somewhere here we have our first point. And then let me substitute minus 150. 3 over 2, which is 1.5. So somewhere here. I want these dots to be straight. And then let me substitute minus 120. I get a half. So there we go. And then when I substitute 0, oh no, minus 90. Why do I want to substitute 0? Minus 90, I get 0. And then minus 60, I get a half. So there, minus 30, I am getting 1.5. So we are somewhere there. And then 0, I'm expecting 2. Yes, we have 2. I think we can already see the trend. We can already see what is happening here. And then from there, I want to substitute 30. I get 1.5. When I substitute 60, I get a half. When I substitute 90, I get 0, right? These points are important because I need to show all the intercepts. Okay, and then when I substitute 120, I get half again, 150, that is 1.5, and then lastly 180, I get 2. 180, I get 2. So let me join these points. Let me just use a faint, well lined. Let's see. I want to join these points. So you should have something like this. You should have something like this. We can clearly see that the period is 1 each here because we have 2 cycles over 360. So that is 7.3.2. Now let's do 7.4. Right, the beautiful question. Clearly show the intercepts with the axis. So you will provide the intercepts there. We can see the intercept. We have 2 minus 90. We have 90. So you will show that there in coordinate form. Yeah, but that is essentially what we need to have. Use the graphs to determine the general solution of 2 cos of cos to the 3x rather minus sine of x is equals to 0. So when I looked at these, I sort of knew that well, the question says use the graphs, but you know, even if the question didn't say use the graphs, I would know that I'm supposed to use the graphs some way somehow. But we don't have the graph of cos of x to the power 3, and you know, so how do we then use the graph to answer this, which looks unrelated to the graphs? Let me show you. So first thing, 2 cos of x to the 3 is equals to sine of x, right? So it became pretty much, you know, straightforward that if I divide both sides by cos of x here, then at least I'm gonna have the graph of tan of x. As you can clearly see, I have tan of x there. So that is tan of x. It's one of the graphs that I have. So I don't want to mingle with that. I don't want to interfere with that. You know, I want to leave that as it is. So how do I then work on this so that it can be equals to my other graph, which is cos of 2x plus 1? I'm like, oh, okay, you know what? Let me take my question paper. Let me go to the back and look at those identities and see if I can come up with something. And then I realized that cos of 2x, right, is equals to 2 cos of squared x minus 1. So take a look at what we have. We have 2 cos of x squared. So clearly 2 cos of x squared is equals to cos of 2x plus 1. And this right here is the graph that we have, right? So we can say 2, not 2, but cos of 2x plus 1 is equals to tan of x. So in order to find the general solution using the graphs, we just go into our graphs and looking for values of x for which the two graphs are equal to each other, right? So if we go there, we can see clearly here that we have they are equal to each other at that point there, okay? And then where else are they equal to each other? They're equal to each other at that point. They're equal to each other at that point. Do we have any other point where they're equal to each other? It seems like those are the only points that they're equal to each other. So we need to read off those points. Those points, they look like they are between minus 150 and minus 120, right? So I can just test that. I can say tan of between 150 and 125. So 150 plus 120 rather. That is 270. We divide that by 2. We get 135. Okay. I get minus 135 as the number between minus 150 and minus 120. So let me just substitute it into these two graphs, these two functions, and see what I get. When I substitute minus 135, here I get 1. So let me substitute it here. 2 minus 135. Well, minus 135. I also get 1 here. So x is equal to minus 135 degrees. It's one of the solutions, right? And then here we have 30 and 60. So I'm thinking I'm thinking that the point in between is 45. So tan of 45, it's 1. And then cos of 2 multiplied by 45 plus 1 is also 1. So x can also be equal to 45 degrees. Calculate the length of AC, the distance between the observer at A and the foot of the building. So let's go ahead and take a look and see what is happening. So in the diagram, C is the foot of a vertical building. So yes, C, right? The foot of the vertical building. And D is the top of the same building. There we go, our haunted house. And then the height of the building CD is 16 meters. We can clearly see it is shown here, 16 meters. Let me change that a bit. So we have 16 meters. Still not really visible. Maybe I should use the red. Let me give it a try. Or let me just write it on this side. So that is 16 meters. And then the two observers are standing 19 meters apart at points A and B. So we have an observer at A and another one at B. They're 19 meters apart. A and B are where A, B, and C lie on the same horizontal plane. Okay. A painter, right, is working at point E, somewhere here, right? And then on the building, the angle of elevation of D from A is 46.85. We can clearly see that on our sketch. And then DEB is 122. Here it is. And BCA is 105.61. So let's go. We're looking for the length of AC. We can see here that we have a right angle, the triangle, right? We are looking for the length of AC. The first thing that I think about is trig ratios, because I have a right angle, the triangle. So I have the opposite, which is 16 meters, right? Opposite to the angle A here. And I'm looking for the adjacent. So which trig ratio do I use in this case? Well, tan of theta is equal to y over x. Tan of theta gives us the gradient. So it is y over x. In this case, we're going to have tan of 46.85 being equal to 16 over AC. So AC is equal to 16 over tan of 46.85. So now I just need to put that in my calculator. 16 over 46.85. And then that is 14.9987. I think I can round that off to 2 decimal places and write it as 15 meters. That is 8.1. What about 8.2? Let's hear the stories. Calculate how far the painter at E is from the top of the building. Okay, so like I've always said, it's better to start from a triangle with a lot of information and move towards the triangle without. So let's see how that plays out. In this question. We know that AC is 15, right? So we have 15. We have 16 in place of CD. So and then AB is said to be 19. AB is said to be 19. And then we have the angle C. We have the angle C. So how can we move from AC to finding C? Well, E, right? Or at least CE. Because if we have CE, we can just say 16 minus CE. So how can we do that? How can we move in that fashion? Right. So we have the length of AC, which is 15. We have AB, which is 19. And we are given this angle, right? 105.61. If we apply the sine rule on this triangle, we can say angle C over sine of angle C over the opposite side, and then we can say 50, no, not 15, but sine of B over the opposite side, which is AC. And then if we do that, we're gonna have the size of angle B. But why do we want the size of angle B? Why do you want the size of angle B? Well, if we have angle B, let's say we do manage to calculate the size of angle B, then we're going to be able to find the size of this angle here, angle A, right? And then why is it important for us to find the size of angle A? If we find angle A, then we can use the sine rule once more to find the length of BC. Okay, if we have the length of BC, what can we do? Okay, we have BC, and then we have this angle here, right? Because we have that other one which is at the top, and that's a straight line. So we have 122, so the one at the bottom, it should be 180 minus 122, which is 58. So we are going to have BC. We're going to have the angle there at the top. This is 90. So we can also find this angle. I think using trig ratios, we should be able to find CE. Okay. So let's go ahead and put all of that in motion. So we are saying we want to start by finding the size of angle B. Okay. So we're going to say sine of C, angle C, right? Divided by AB is equals to sine of B divided by AC. So here we have sine of 105.61 divided by AB, which is 19, being equals to sine of B. So this is what we want to find, divided by AC, which is 15 units, right? So sine of B is equals to, so this is 15. I have 15 multiplied by sine of 105.61 divided by 19. Yes. And then I'm getting sine of B being equals to 0.7604. So B is equals to, let me take sine inverse here. When I do that, I get angle B being equals to 49.4955. So this is the size of angle B. This is the size of angle C. So we should be able to find the size of angle A. So angle A is going to be 180 minus 105.61 minus 49.4955. So allow me to put that in my calculator. 180 minus 105.61 minus 49.4955. I'm getting 24.8945. So 24.8945 8945. So now we will use angle A to find CB, right? So we're gonna say sine of A over CB is equals to sine of, yeah, now we have the freedom of choice, C over AB. So CB is going to be equals to sine of A multiplied by AB divided by sine of angle C. So let me put that in my calculator. Sine of A is 24.8955 multiplied by AB is 19 divided by sine of C is 105.61. So CB is equals to 8.3. So this is 8.3 meters. So we have CB, which is 8.3 meters. Let me just erase some of these things. So CB 8.3. So this is 8.3. So I can use trig ratios here. Which trig ratio though? Do I have the size of angle B? Oh, okay. Not yet. I don't have the size of angle B as of yet. But obviously I can also use this angle 58 degrees. Yeah. So this 8.3, if I use 58, is going to be my opposite, right? So I'm looking for the adjacent. So tan of 58 is equals to 8.3 divided by CE. So CE is equals to 8.3 divided by tan of 58, 5.1864. So from C to E is 5.1864. So how far is E from D? Well, 16 minus the answer. It is 10.81 meters apart. What is the question? Yeah, it is, how far is it? It is 10.81 meters far from point D. Calculate with reason the value of A1. So let's take a look and see what is happening here. So the first thing that we must do in Euclidean geometry is to write down the keywords, because that's what's going to help us to actually answer all the questions that we will come across. So in the diagram, ABCD is a cyclic quad. So already we have the first keyword there, cyclic quad. Right, let's carry on. BC is produced to E, AC is drawn, and we are told that A1 is equals to half of B. So A1 is equals to half of B, right? And then A2 is equals to 46, C is equals to 86. So let's see how we can use these two keywords to answer these two questions that we find in front of us. So 9.1, we are looking for the value of A1. The first keyword is cyclic quad. So let's see how we can use the cyclic quad to find A1. So A, B, C, D is a cyclic quad. Immediately I'm realizing that C1 is an exterior angle of that cyclic quad, and it should be equals to A2 plus A1, right? So C1 should be equals to A2 plus A1. We're supposed to give a reason. The reason is that an exterior angle of a cyclic quad is equals to the interior opposite. So 86 is equals to 46 plus A1. A1 is equals to 40 degrees. Okay, there we go. That is the size of angle A1. Okay, let's carry on and do 9.2. So 9.2, hence prove that AD is equals to DC. AD is equals to DC. So let's go ahead and take a look at AD and DC. They are said to be equals to, we're supposed to prove that they're equals to each other, right? If they are equals to each other, we must have angles opposite equal sides. So C2 must also be 40 degrees, right? If they are indeed equal to each other. So if we prove that C2 is 40 degrees, then we have proved that AD is equal to DC. So how can we do that? Back to our keywords. The first keyword is cyclic quad. So let's see how we can use that. So C2. Well, we know that A1 plus A2. A1 plus A2. If we add A1 plus A2 and C2 plus C3, we should get 180 degrees because they're opposite angles of a cyclic quad. But I can see that C1 is 86. So because C1 is 86, I can find the sum of C2 plus C3 using the sum of angles on a straight line. So C2 plus C3 is equals to 180 minus 86. So 180 minus 86, that is 94 degrees. So C2 plus C3 is 94 degrees. Okay. And then what else do we have? We have C2 plus C3, which are equals to 94 degrees. And then A1 plus A2 are equals to 86 degrees. Yeah, so clearly when we add these two, they will give us 180. But we still need to find the actual value of C2. We still need to prove that C2 is 40 degrees. So how can we go about that? Well, we've tried to use the first keyword. Yeah, let's try and use the second keyword and see what happens. So we know that A1 is half angle B. So A1 is 40 degrees, right? So angle B should be 80 degrees because A1 is half angle B. So here we have 80 degrees. Okay, so how can we use that therefore? Well, we have A2, which is 46. We have B, which is 80. So we should be able to find C3, right? Using the sum of angles on a triangle. So C3 is equals to 180 minus 80 minus 46. So 180 minus 80 minus 46 is equals to 54. So C3 is equals to 54. So C2 should be equals to 94, right? Minus 54, which is 40 degrees. So we have shown that C2 is equals to 40. So we can say that AD is equals to DC. C2 is equals to A1. Angles opposite equal sides. Yeah, we're sort of reaching there in reverse. So that is question 9. You know, quite a easy question to do, really. Shouldn't take too much time. Prove with reasons that OR is to WS is equals to 1 is to 2. So let's go ahead and take a look at our question statement and see which keywords we can extract. In the diagram, O is the center of the circle. Easy to see. Triangle PWS. So here's P, we have W, and S is drawn with PW and S on the circle. OR is perpendicular to PS. There's an angle of 90 degrees there. So that is also easy to see. PRS is produced to T. SW and OT intersected V. And then you are told that OV is to OT is equals to 1 is to 4. The first question, back to the first question, prove with reasons that OR is to WS is equals to 1 is to 2. Okay, we don't have much to work with as far as the keywords in the question are concerned. But let's take a look at our sketch. Maybe there's something we can cook there. So first of all, PWS is a triangle, right? So PW must be a straight line. Yeah, here we have PW. This must be a straight line. Yeah, since PWS is a triangle. If PW is a straight line, then PW should be a diameter, right? That should be easy to see. And in saying that PW is a diameter, then we are saying that angle S is 90 degrees, right? But now look at this. Angle S is 90 degrees. Angle R is also 90 degrees. So WS should be parallel to OR, right? Now let's take a look at the equation we actually have in hand. We want to find the ratio of OR. So here's OR and WS. Okay, but if you take a look at OR, we can say that OR is a base, right, or a side on triangle PRO, and then WS is a side on triangle PWS, right? But these two triangles are similar to each other. Why? R is equals to S. They are both equals to 90. We have talked about why angle S is equals to 90. Angle S is equals to 90 because it's been subtended by diameter SW. Okay, but in triangle POR, well, triangle POR and PWS, they share this angle right here. They share that angle P, right? So angle P is equals to angle P, right? It is a common angle. So in saying that the third angle of the two triangles should be close to each other. So now we have the privilege to can say that the triangle POR is similar to triangle PWS, angle. Right, so now that we've proved that the two triangles are similar, we can play around with proportions because we've proved that the two triangles are similar. But I want you to realize something. OP is a radius. This is a radius right here. And then OW is a radius, right? So PO divided by OW should be 1 over 1 because it's a radius. So there we go. PO divided by OW is equals to 1 over 1. So we can see that no issue whatsoever. But then let's look at the two triangles that we have. On triangle POR, we have a side PO, right? We have a side PO. And then on triangle PWS, we have a side PW. But what is PW? PW is 2R, is 2 radiuses, right? So PO divided by PW should be equals to R divided by 2R, which is equals to 1 over 2. So this is PO divided by PW, right? But we are interested in OR and WS. But OR is this side on the smaller triangle, and WS is this side on the bigger triangle. So we can also use that those sides, they should also be in proportion. So we can say that PO over PW is equals to OR over WS. So OR over WS. The reason here, right, I'm forgetting to give the reason. The reason is that POR is similar to PWS. That is the reason there. So OR over WS is 1 over 2. So OR is to WS is equals to 1 is to 2. Okay, that is 10.2.1. Let's take a look at 10.2.2. Calculate the length of PT. What is PT? If ST is equals to 15 units. What was I writing there? So ST is 15 units. Okay, so let me erase some things here so that I can have a bit of clarity. What are we saying? Let's see. So calculate the length of PT. This is PT. PT is this entire line. And then ST is 15 units. So this is 15 units. Okay. In our question here, we are given that OV. Well, I hate this is to thing. Let me just say OV over OT. This is to thing. It annoys me. So OV over OT is equals to 1 over 4. This OV is true. I don't like it at all. Okay, so let's see what we can cook there. This is like we've showed parallel to this. Yeah, that is important. We need that there. And then OV, where is OV? OV is this side, right? So the ratio is 1 over 4. So if this is x, then OT should be 4x, right? Meaning that here, let me write it like this. Yeah, this is x. Here we should have 3x, so that OT can be 4x. That's what we know. But OR and VS are parallel, so this should also be x, and then this should be 3x. Do you see that? Do you see that? Okay, so let's get formal. OV over, I don't want to say OT, I want to say VT is equals to RS over ST. So OV over VT, that is going to be x over 3x. RS, we don't know that one. And then ST is 15, right? So this is 1 over 3 being equals to RS over 15. So 3 RS is equals to 15. RS is equals to 5. Okay, so here we have 5. ST is 15. So now we just need to find PR. We need to find the length of PR. Okay, but we know that from O to P is equals to the distance from O to W. So from R to S should be equals to the distance from R to P. So we also have 5 here. So PT is equals to 15 plus 5, which is equals to 25. There we go. Question 10. The matric learners of a certain high school like to vote for the chairperson of the RCL. The scatter plot below shows the IQ of the 10 learners who received the most votes and the number of votes that they received. Before the election, the popularity of each of the 10 learners was established and a popularity score was assigned to each. The popularity scores and the number of votes of the same 10 learners who received the most votes are shown in the table below, right? And then the first question, 1.1, 1.1.1. Let's calculate the mean of the number of votes that these learners received. So I'm not going to do anything manually. I'm going to calculate using my calculator. So let me go ahead and do that. I want to find the mean of the number of votes. So I'm concentrating on only one variable. I'm going to press mode setup and then 3 for stats, 1 for one variable, right? Because I'm only interested in one variable. So the number of votes, we have 9, followed by 22, 10, 21, 11, 15, 20, 12, 19, and 16. Right, you have to verify that you've entered the correct data, because if you've not, your answers are going to be incorrect. Right, now you press equals to a couple of times and then you press AC. From there on, shift 1 and then you go to option 4, VAR. Right, and then when you press option 4, you're going to have X bar, which is the mean. So when I press 2 and equals to, I get 15.5. So that is the mean. The Y bar in this case, because the number of the votes are Y bar is equals to 15.5. You might be asking yourself, but we are only writing the answer. What about the formula or the substitution? Am I not going to lose marks? No. Even if you write only the answer, you get full marks. So you don't have to worry about that. 1.1.2, we're looking for the standard deviation of the number of votes that these learners received. So let's go ahead and find the standard deviation. we're going to press AC. Shift, we've already entered our data. We don't have to tamper with it or enter it again. So Shift 1, and then we're going to choose option 4, and then now we press standard deviation, which is option 3, right? In your calculator, it might be a different option, but as long as you choose the correct option. Equals 2, and I'm getting 4.59 if I round it off to 2 decimal places. So our standard deviation is equals to 4.59 rounded off to 2 decimal places. Let's go ahead and do 1.2. So in 1.2, the question is saying that the learners who received fewer votes than 1 standard deviation below the mean were not invited for an interview. How many learners were invited? So now we have to determine the value of 1 standard deviation below the mean. So we're going to have y bar minus the standard deviation, right? This is equals to what is the mean? 15.5. The standard deviation 4.59, and this should be equals to 10.91. So how many learners had less than 10.91 votes? Let's go ahead and find out. So we have 1, the learners received 9 votes. 2, what else? Right, so 2 learners were not invited for the interview. So the learners that were invited, we're going to have 10 minus 2, which is equals to 8. So only 8 learners were invited. 2 learners had the votes, 1 standard deviation below the mean. That is 1.1. Let's take a look at 1.3. In 1.3, we're supposed to determine the equation of the least squares regression line for the data given in the table. How are we going to do that? AC mode 3 for stats, and now we're interested in 2 variables. So that is option 2, a plus bx, which is the equation of our least squares regression line. Y is equals to a plus bx. So let's go ahead and press 2 and enter our data. We're going to start with the x values. As far as the x values are concerned, we have 32, 89, 35, 30, not 32, but 82, right? 50, 59, 81, 40, 79, 65. Right, now I have to go ahead and punch in the y values. So let me go up to the first x value. So you have to punch in the y value close to its corresponding x value, right? So 39 is going with 9, 89 is going with 22, 35 with 10, 21, 11, 15, 20, 12, 19, and 16. There we go. I have my data. 16, not 17, right? The y value is 65 and the x value is 16. Right, there we go. Now I can press AC, Shift 1. Instead of choosing option 4, I'm gonna choose option 5, which is regression. So in option 5, I have my variables a and b, which I need, right? So for the variable a, you press 1 and then press equals to. As you can see, a is equals to 1.77 rounded off to 2 decimal places. Let's go ahead and find b. So if I want to find b, then it is AC Shift 1, well, Shift 1, right, 5, and then I'm looking for b now. That is option 2. This is equals to. 0.22. So B is equals to 0.22. Y is equals to 1.77 plus 0.22 x. Yeah, there we go. We have the equation of the least squares regression line. Let's go ahead and do 1.4. So 1.4, predict the number of votes that a learner with a popularity score of 72 will receive. The popularity score is the x value, so we just need to substitute it into this equation. We're going to have y being equals to 1.77 plus 0.22 multiplied by x. What is the value of x? The popularity score, 72. In your calculator, you're going to get 17.61, but we cannot have 17.61 votes. So let's just round it off to 18. So yes, if you have a popularity score of 72, you're going to get right about 18 votes. Right, let's go ahead and do 1.5.1. Use the scatter plot and the table above and provide a reason why IQ is not a good indicator for the number of votes that a learner could receive. As you can see from the scatter plot here, there's no correlation between IQ and the number of votes. This person has a very low IQ and so many votes, and this person has a very high IQ and they have a lot of votes. Even the people in the middle with average IQ, they have a lot of votes. So there isn't really a relationship between IQ and the number of votes, it seems. Right. And then, so that is why IQ is not a good indicator, because, yeah, there is a very low correlation between the IQ and the number of votes. Why is the prediction in 1.4 reliable? Well, in 1.4, we are using the popularity score to determine the number of votes that a person is going to get. That is because we have a very high correlation. Well, you can use shift 1 and go to 5 for regression and press the option that gives you the correlation coefficient. In this case, it is going to be 0.98. A very high correlation will lead to a reliable prediction. How many people are employed at this company? We are given the cumulative frequency, which is 60. So 60 people are employed at this company. That is 2.1. Let's go ahead and take a look at 2.2. Write down the model class of the data. Well, let's read through our statement and see what is happening. So a company conducted research among all its employees on what percentage of their monthly salary was spent on fuel in a particular month. The data is represented in the cumulative frequency graph below. Okay, so we're looking for the model class of the data. The model class derived from the board, it's where we have the highest frequency. So let's go ahead and take a look at that. From 5 to 10%, this is the frequency. From 10 to 15, this is the frequency. From 15 to 20, this is the frequency. And then 20 to 25, 25 to 30, 30 to 35. 20 to 25 is where we have the highest frequency. So that is our model class. 20 to 25. 2.3, how many employees spent more than 22.5% of their salary on fuel? Let's go ahead and find 22.5. This is 20, this is 25. So 22.5 should be in the middle, right? Let me just erase all this for the sake of clarity. And let me draw a line so that we can see the cumulative frequency at that point. At 22.5, we are trying to figure out the cumulative frequency, 34. So employees that spent more than 22.5% of their salary on fuel will be 60 minus 34. We have a total of 60 people. 34 people spent less than 22.5%. So people who spent more than 22.5% is 60 minus 34, which is 26 employees. So that is the number of people that are spending more than 22.5% of their salary on fuel. Right, 2.4. An employee spent 2,400 of his salary on fuel in that particular month. Determine the monthly salary of this employee if he spends 7% of his salary on fuel. So he spent 2,400 on fuel, and this is only 7% of his salary. What is his entire salary? We know fully well that if we say salary multiplied by 7%, it will give us 2,400, right? 7% of this person's salary is spent on fuel, which is 2,400. So in order to find the salary, it's just a matter of dividing both sides by 7%. And if we do that, we're going to get 34,285.71. 2.5. The monthly salaries of these employees remains constant, and the number of liters of fuel used in each month also remains constant. So salary is constant. The liters of fuel required are constant. If the fuel price increases from 21.43 to 22.79 per liter at the beginning of the next month, how will the above cumulative frequency graph change? What is going to change is the percentage of salary spent on fuel. People are still traveling the same distance, but now the fuel costs more. So the percentage of salary spent on fuel will increase. So we would expect our cumulative frequency graph to shift to the right as we have higher percentages towards the right.
Let's go ahead and calculate the gradient of AB, right? So we say that the gradient of AB will be equals to y2 minus y1 divided by x2 minus x1. So we have to decide which point we take in as point 2 and which point we take in as point 1, right? So let's take point A as point 2. So we're going to have 4 being x2 and then 2 being y2. And then here for B, we're going to have x1 and y1. So if we substitute that, for y2 we have 2, and then for y1 we have minus 4. So that will just be plus 4. And then everything divided by x2. What is x2? x2 is 4, right? And then minus x1. X1 is 6, so we have minus 6. So we have 2 plus 4, which is 6, divided by minus 2, right? And then this should be equals to minus 3, right? That should be equals to minus 3. Now let's do 3.1.2. That is saying, let's calculate the size of this angle here, right? So if we want to calculate the size of that angle, and we already have the gradient of AB, we can just say that tan of that angle will be equals to the gradient of AB, right? So that angle there will be equals to tan inverse of the gradient, which is minus 3, right? And if you put that in your calculator, you should get minus 71.557 degrees, right? If we get a negative angle, we always add 1/8, right? And then if you do that, that angle should be 108.43 degrees. And we're moving on to 3.1.3. 3.1.3 says, let's calculate the coordinates of D. We can see that T is the midpoint of CB, because CT is equals to TB, right? So we're going to use the midpoint theorem, so to say. So what are we saying? For T, using the midpoint theorem, we're going to have x2 plus x1 divided by 2, and then for the y coordinate we have y2 plus y1 everything divided by 2, right? Since we have let B have x1 and y1 as the coordinates, let's C have x2 and y2. So if we compute that, we're gonna have the coordinates of t being -2 plus 6 divided by 2, and then -3 minus 4, right? And then divided by 2. So here we're gonna have t having coordinates. So we have -2 plus 6 divided by 2, which will give us 2, right? And then -3 minus 4 divided by 2 should give us -7 divided by 2, right? And let's use 3.1.4. So 3.1.4 here is saying that let's determine the coordinates of S. Lucky we are given the equation of line AC, right? It's given to us here in the equation. We're given the equation for line AC. They're saying that equation we have 5x minus 6y being equals to 8, right? So we can just so S, let's look at S. You can see that the x coordinate of S then is going to be 0, right? So we can just substitute that. If we substitute that, we're gonna get 5, 0 minus 6x is equals to 8. So that 5 is just gonna fall away, right? So you just have y being equals to 8 divided by -6, right? If we divide everything by 2 there, we should get 4 divided by -3. So the coordinates of S is 0 and -4 divided by 3. Now let's do 3.2. So 3.2 here is saying that let's determine the equation of CD in the form y is equals to mx plus c. So let's go ahead and look at CD. So we have a CD here. So here's CD, right? But then is said to us that CD is parallel to AB, right? So we already know that M is equals to -3, because don't forget that in 3.1.1, when we calculated the gradient of AB, we got -3. So now we just are looking for C here, right? Of which we're gonna do by substituting our point C, right? If we substitute C of coordinates -2 and -3, we shall get y is equals to in place of y we put in -3. We're gonna have -3 is equals to, and then the gradient is -3, right? So we have -3, and then x is -2 plus c. So we have -3 -6 being equals to c, right? So -9 is equals to c. So equation is now y is equals to -3x plus c. C is -9. So let me just see if that works real quick. So if we substitute -2 and then with -9, we're gonna get 6 minus 9, which is equals to -3. So it seems like we're on the right track here. Yeah, let's carry on and see what happens. So if we do, if we come to 3.3 here, and then 3.3.1 is saying that let's find the size of DCA. So DCA, let me just erase what we have here for a bit of clarity. So DCA is this angle here. This question is for 4 marks, right? I did spend some time thinking about this question. I don't want you to think that I just saw the question and then I jumped straight into the answer. I had to, think about a lot of things in order to answer this question that we have here. So these kind of questions, they demand a lot of thinking, right? And you should be willing to do that. But let me show you something. This size here, this angle here, A, right? This angle here should also be A, because DC is parallel to AB, right? So, and then apart from that, using CA, we can find this angle of inclination that is here, right? And then if we have that angle of inclination, we can say that this angle here is equals to DCA plus this angle here, right? An exterior angle of a triangle is equals to the sum of the two interior opposite, right? And then from there on, we can then find that angle DCA. So let me show you what I'm talking about. We're saying that angle DPO will be equals to this angle here. We calculated it. We say it is 108.43. So 108.43 degrees, right? And then we say that we need this angle because it will be equals to this angle here, and then we're gonna use exterior angle of a triangle, right? So let's calculate that angle. How are we gonna calculate it? We're gonna say that tan of theta is equals to the gradient, right? So here we're gonna say that theta is equals to tan arc of the gradient. So what are we saying? We're saying y2 minus y1 divided by x2 minus x1. But then just for the sake of time, we're just gonna do it without writing the formula down, right? So what is y2? Let's take a as our second point, right? So y2 should be 2 here, and then y1 should be minus 3, right? So that will be plus 3 because we say y2 minus y1. And then now let's look at x2 minus x1. So x1 is 4, and then x2 is minus 2, so that should be plus 2. So we're saying that theta is equals to tan inverse of 2 plus 3 divided by 6 essentially, right? And that should be equals to 39.81 degrees. So this angle, we can replace it with 31. We're replacing it with 31.81, right? So this angle here should also be equals to 39.81. I meant, yeah, what am I writing? I'm saying 39.81. Yeah, that's what the calculator says. 39.81. I don't know what I was writing there. So now we can say that angle DPO is equals to angle DCA plus angle what? Angle PFC, PFC, right? And then we're given the reason the exterior angle of a triangle is equals to two opposite interior, right? Yeah, the story goes on. So what is DPO? DPO, we know that it is 108.43, and that should be equals to DCA, which we are looking for, plus PCF, which is 39.81. So now DCA should be equals to, so we say in 108.43 minus 39.81. I'm getting 68.62 degrees. It doesn't look too bad, right? 68.62 degrees is believable. Let's do the last question. 3.32 area of POSC. So let's erase everything again and just look at POAC. So we have POSC, not AC, POSC. So let's look at POSC. Okay. I think, yeah, thought of a way. So because let's do this. Because we have this angle here, right? We know the size of that angle. We can use the side CF and the side CP to calculate the size of that of triangle PCF, right? After we have calculated the size of triangle PCF, then we can subtract triangle OFS, right? We can subtract the triangle, and then we're gonna have the size of, or the area of POSC. So let's go ahead and do that. So we're saying that we're using CP and CF, right? So let's calculate CP. Here comes the distance formula. The formula I hate more than any other. So we need the coordinates of P, right? And then we have the equation of CD, right? We calculated it in 3.2. So on the equation of CD here, if we substitute, so we're letting y be equals to 0, right? So if y is equals to 0, let's just work it out here. if y is equals to 0, then 9 should be equals to minus 3x. So x should be equals to minus 3, right? So we're saying for p, we have minus 3 and 0. And then which other one do we need? We also need the coordinates of f, right? We have the y coordinate of f is 0, and we are given the equation of AC. So let's look at the equation of AC. The equation of AC is given as 5x minus 6y is equals to 8. So what is 5x? We say in y is 0, so we're gonna have 5x being equals to 8. So x is equals to 8 divided by 5. So here let's say 8 divided by 5. Yeah, so let's go ahead and calculate CP. So CP is going to be equals to so distance formula, we say y2 minus y1 squared plus x2 minus x1 squared, right? So CP, let's let P be the second point. So if we say y2 minus y1, we're gonna get 0 plus 3 squared plus x2 and then plus 2 squared, right? So let me just compute that real quick and see what I get here. Square root of 10, right? So now let me do CF. CF is equals to so CF, let's take f as the second point. So we're gonna have y2 minus y1, so we have 0 plus 3 and then squared plus x2 minus x1, so we're gonna have 8 divided by 5 plus 2 squared, right? CF, I'm getting 4.6869. let's say 6861. Let's not round off to 2 decimal places when we're not at the final answer, right? So now we can say that the area of triangle CPF is equals to I have side 1, side 2, and then sine of the angle of the two sides sandwich, right? So that will be angle DCA. So the area of CPF will be square root of 10 multiplied by 4.6861 multiplied by sine of that angle. We said that angle is equals to 68.62. 68.62, and that should be equals to 6.8995 units squared, right? So now we can calculate the area of triangle OCF and subtract it from the triangle PFC to find the area of OSCP. So what are we saying now? We're saying that the area of that triangle. So let's analyze that triangle. So we can easily find the length of OF, right? And we can easily find the length of OS. And then the angle they will sandwich is this one, which is 90, right? So I think that's the best way to go. So we can say that OF is equals to 8 divided by 5, right? It's easy to see. And then OS is equals to do we have the coordinates of S? Yeah, 3.1.4. Let me look. So that will be 4 divided by 3, right? So OS is equals to 4 divided by 3. So I can say that the area of triangle Triangle OSF will be equals to a half multiplied by 8 divided by 5 multiplied by 4 divided by 3 multiplied by sine of 90, which is just 1, right? So we just have a half multiplied by 8 divided by 5 multiplied by 4 divided by 3, which is equals to 1.0667. So now we can say that the area of POSC should be equals to 6 point, this is units squared, should be equals to 6.8 1.8995 minus 1.0667, right? And that should be equals to 5.8333 units squared. Let me know what you think in the comments.
Let's go ahead and calculate the coordinates of P. So we have 4.1, which is saying that let's calculate the coordinates of P. We can see fully well here that M is the midpoint of the line PN, right? So if we were looking for the x coordinate of M, we would say that xm is equals to x of n plus x of p divided by 2, right? That's what we would do. We would be applying the midpoint theorem, right? If we substitute the corresponding values now, we're gonna get 3 being equals to x of n, which is 7, plus x of p divided by 2. So if we cross multiply here, we're gonna get 6 being equals to 7 plus x of p. So minus 1 is equals to x of p, right? We can see that. Now let's find y of p, right? We're gonna exploit the coordinate m again. We're gonna say that y of m, if that's what we were looking for, we would say y of n plus y of p divided by 2, right? So if we substitute again, we're getting minus 5 is equals to minus 2 plus y of p divided by 2. If we cross multiply this, we should get minus 10 being equals to minus 2 plus y of p. So minus 8 is equals to y of p. So the coordinates of p is minus 1 and minus 8, right? And minus 8. Let's do 4.2.1. So 4.2 and then we have 4.2.1. So 4.2.1 is saying that let's determine the equation of the cycle in the form x minus a plus y minus b squared is equals to r squared. So here we're going to use the coordinates of m again, right? 3 will be a and y will be b, right? Or minus 5. So if we put that into this equation, we shall get x minus 3 with squared here, right? Squared plus y minus 5, so that will just be plus 5, right? Squared is equals to r squared, right? Now we have to find r squared. So to find r squared, we're just gonna take a point on the circumference of the circle and substitute into this equation, right? Or we can just determine the length of mn using the distance formula, but then let's just substitute it into the equation. So if we sub in n of coordinate 7 and minus 2, we're gonna get so what are we getting? 7 minus 3 squared plus y is minus 2, so we're gonna get minus 2 plus 5 squared being equals to r squared, right? So there we just have 4 squared plus what? I think that's supposed to be 3 plus 3 squared, so we have 25 being equals to r squared. So now our equation will be x minus 3 squared plus minus 3 squared plus y plus 5 squared being equals to 25, right? 4.2.2. So 4.2.2 is saying let's determine the equation of KL in the form y is equals to mx plus c. So let's look at KL. Is this line here, which is a tangent to the cycle, right? So we don't have the coordinates of k, we don't have the coordinates of l, but if we calculate the gradient of mn, then we're gonna use that to find the gradient of KL, right? Let me show you what I'm talking about. So we're gonna say that the gradient of mn multiplied by the gradient of KL should be equals to -1, right? Because the radius is perpendicular to the tangent, right? So if we make the gradient of KL the subject of the formula here, we're gonna get -1 divided by the gradient of Mn, right? So the gradient of KL will be equals to -1 divided by y2 minus y1 divided by x2 minus x2 minus x1, right? Obviously you can do this separately. You calculate the gradient of Mn separately, right? But then I'm just gonna put it all in at once and yeah, see what happens. So doing that, -1 divided by y2, so let's take n as the second coordinator, so that will be -2 minus 5, so that will be +5, and then divided by x2, so we have 7 minus 3, right? And then now let me just put that in my calculator real quick and see what I get. So I have 3 basically, and then divided by 4, right? So yeah, the gradient of KL is -4 divided by 3, right? So now we can say that y is equals to -4 divided by 3x plus c. Now we can sub in n, right, in order to find c. So if we sub in n, we're gonna get -2 being equals to -4 divided by 3 multiplied by 7 plus c, right? So c should be equals to -2 plus 4 divided by 3 multiplied by 7, and this should be equals to, so we have -2 plus 4 divided by 3 multiplied by 7, so c is 22 divided by 3, right? So y is equals to -4 divided by 3x plus 22 divided by 3. But then this equation looks shady, so let me just substitute the x value of n and see if I will get the y value, right? Perfect, I'm getting -2 when I substitute 7, so I think we're good to go. And then the follow-up question 4.3, so 4.3 is saying that for which values of k will y is equals to -4 divided by 3x plus k be a secant to the circle. So a tangent touches the circle once, right? And then a secant, it goes through the circle. So this line here would be a secant. It's going through a circle. This line here would be a secant. It's going through a circle, going through a circle, going through a circle, going through a circle. So as long as the line is going through the circle, then it's a secant, right? But then, yeah, don't think this question was easy at all. But yeah, let me propose something here. The gradient of this line KL is equals to -4 divided by 3, right? And the line we are also interested in has a gradient of -4 divided by 3, right? So let me show you something. If we shift k some units, right, and then it's somewhere here, right, it still has the same gradient, right? Then it will be a secant to our circle, right? And then we can even put it here. It will be secant to the circle. We can put it here. It will be secant to the circle. We can put it here. It still is a secant to the circle because it's going through the circle, right? But then the only problem arises when it is somewhere here, when it touches the circle only once at P, right? Then it will no longer be a secant anymore. So as long as the y-intercept, right, the y-intercept is between the y-intercept of KL and the y-intercept when it touches the circle at P, then for those values of k, because k is the y-intercept, right, x is 0. So for those values of k, that equation will be a secant, right? So we need basically the upper limit and the lower limit, but we already have this value here, right? Because we know fully well that that value is from the line KL, right? and then that value is 22 divided by 3. So we already know what k should not be greater than. Now we only need what k shouldn't be less than, right? And in order to do that, we're going to substitute the values of p, right? So we're gonna say that y is equals to minus 4 divided by 3x plus k, obviously, right? And then we subbing in p, right? We know the coordinates of p, minus 1 and minus 8 from the above equations. So if we substitute p here, we're gonna get minus 8 being equals to minus 4 divided by 3, and then in place of x we have minus 1 plus k, right? So k will just be equals to minus 8 minus 4 divided by 3, basically, right? So k will be equals to minus 28 divided by 3. So when k is between 20 what, the y-intercept, 22 divided by 3 and minus 28 divided by 3, right? That line y is equals to minus 4 divided by 3x plus k is a second to the cycle. Now let's do 4.4. So 4.4 is saying that we have points A of some coordinate t and t, and B that are not shown on the diagram, right? And then 4.4.1 is saying that so we are told that from point A, another tangent is drawn to touch the cycle with center M at B, right? And then 4.4.1 is saying that let's show that the length of the tangent AB is equals to t squared, 2t squared plus 4t plus 9, right? I would like to know how you guys solve this problem. So if you did solve it, please leave your solution on the comment section and I will pin the comment, right? But still, let's do 4.4.2, right? This is very similar to that equation that was saying that let's find the minimum distance between f is equals to x squared and that coordinate, I think it was like 10 and 2. But then anyway, so let's solve the problem we have. The problem here is in that let's determine the minimum length of AB. So we know that AB is equals to 2t squared plus 4t plus 9, right? So because we have a square root here and I don't like dealing with square roots, I'm going to square both sides, right? So that I can easily digest the problem. So I will have AB squared being equals to 2t squared plus 4t plus 9. Since we're looking for the minimum length, I can derivate this and equate to the 0, right? Because let me show you something. This graph is going to be concave up, right? If it's concave up, then here at the turning point, we're going to have the minimum value, right? So we can derivate this and equate to 0 and then find the value of t of which we are going to have the minimum value, right? So if we do that, we're gonna get qt squared. If we derivate in that, so we say in AB squared, we're finding the derivative of that. We're gonna get 4t plus 4 being equals to 0. So t here should be equals to minus 1. Let me show you something. Because we're basically looking for the x value of the turning point, right? We can also see that that x value t is equals to minus b divided by 2a, right? Because we just have a quadratic function. So this will be minus 4 divided by 2 multiplied by 2, which is equals to minus 1 again, right? So the distance, the length is at a minimum when t is equals to minus 1, right? But now let's substitute minus 1 into our equation and actually determine the minimum length, right? So the minimum length will be, so we have 2 multiplied by minus 1 squared plus 4 multiplied by minus 1 plus 9, right? So AB will be equals to so minus 1 squared, so we're just gonna get 2 and then minus 4 plus 9, so we have
2 minus 4, that should be minus 2, right, plus 9. So we have the square root of 7 basically as the minimum length of AB. Let's do 5.2. 5.2. Determine the value of the following expression without using a calculator. So we have cos of 90 plus theta divided by sine of theta minus 180 degrees plus 3 sine of minus theta, right? So when I get a problem like this, I actually put it in the calculator first, right, so that I can get an answer, and instead of just solving, I'm now actually proving. So if you put this expression inside of a calculator, right, instead of theta, you just put any number between 0 and 90, right? So you can put 3 here, right? If you do that, you're gonna find out that this thing will give you 1 divided by 4, right? So when you solve this problem, if you end up not getting 1 divided by 4, you have clearly done something wrong. We should get 1 divided by 4, right? So let's, go ahead and solve a problem and see what happens. So this should be equals to, so we have cos of 90 plus theta, right? So as soon as we see cos of 90 plus, right, we know that that's going to change to sine, right? Let's just put that in mind first. But then is cos positive or negative in the second quadrant? Because we have 90 plus, right? So we move into the second quadrant. Cos is negative because cos is only positive on the first and on the fourth, right? So here we're gonna have minus, but cos is gonna change into sine. So we have minus sine of theta, right? And then divided by sine of theta minus 180 degrees. So sine of theta, we here in the first quadrant, right? Because that is just theta. So if we minus 180 from theta, right, we're going to end up in the third quadrant, right? Why are we saying we're gonna end up in the third quadrant if you minus 180 from theta? Theta, it's a number between 0 and 90. Right? If you minus 180 from a number between 0 and 90, your answer will be between 180 and 270, right? So sine of theta minus 180, we're going to end up in the third quadrant, right? Is sine positive or negative in the third quadrant? Clearly, it is negative because sine is only positive on the first and the second, right? So here we're going to have minus sine of theta. And then we have plus 3 sine of minus theta, right? So we can just pull the minus out there. If we pull the minus out, you're just gonna have minus 3 sine of theta, right? And there isn't much we can do there, right? We just have minus 3 sine of theta. So if we go ahead and solve this, we're gonna get minus sine of theta divided by minus sine of theta minus 3 sine of theta. So that will be minus 4 sine of theta, right? Sine of theta and sine of theta cancels out, so we just left with 1 divided by 4, like we had said that we're supposed to have. Yeah, now let's do 5.3. Let's do 5.3. So we have 5.3. So 5.3 saying that determine the general solution of the following equation. We have cos of x plus 2 sine of x multiplied by 3 sine of 2x minus 1 being equal to 0. So if you multiply in two numbers and you get in 0, then one between the two numbers must be 0, right? Like it's given. So now we can say that cos x plus 2 sine of x should at least be equal to 0, right? If it's not, then 3 sine of 2x minus 1 should be equal to 0. Yeah, 1 must be equal to 0, right? If we, take 2 sine of x to the right hand side, then we can divide both sides by cos of x and end up getting tan, right? So let's do that. If we do that, we're gonna get cos of x being equals to minus 2 sine of x, right? So if we divide both sides by cos, right, we're gonna get 1 being equals to
minus 2 sine of x divided by cos of x. That will be tan of x, right? So minus 1 divided by 2 is equals to it's equals to what? It's equals to tan of x, right? It's equals to tan of x. So let's note here that we're getting tan of x being negative, right? It's gonna be important as we solve our problem going further. Let's note that tan of x is negative, right? So we know that we're supposed to use the quadrants where tan of x is negative, right? So now we're gonna say x is equals to tan arc of, so here we're just going to use 1 divided by 2, right, without the negative sign. We're just going to use 1 divided by 2 without the negative sign, right? If we do that, we're gonna get 26.57 degrees, right? So yeah, now let's move to the other equation and solve that, and then when we get to this step, then yeah, we're gonna carry on. So if we solve that part of the equation, we're gonna get 3 sine of 2x being equals to 1. So sine of 2x is equals to 1 divided by 3. So 2x is equals to sine arc of 1 divided by 3. So let's note this again. We have 1 divided by 3, right? Which is positive. So we want quadrants where sine is positive in this part of the equation. Right? Let's just take note of that. So if we say sine arc of 1 divided by 3, we're gonna get 2x being equals to, so we have 2x being equals to 19.47 degrees, right? So now, yeah, we are where we are. Let's go ahead and solve tan, right? So for tan, let's have our general solutions for tan, right? So we're gonna say that x is equals to, so one of our general solutions, right? One of our general solutions, x is equals to. So we're saying that we want quadrants where tan is negative, right? Tan is negative on the 4th and on the 2nd, right? So let's start with the 2nd. So what we're gonna do, we're gonna say on the 2nd we have 180, right? So we're gonna say 180 minus the critical angle, which is 26.57, right? Plus k multiplied by the period of tan, which is 180, right? K being an element of integers, right? And then yeah, now we have done the second quadrant, so we can say this is equals to, so 180 minus 26.57 will give us 153.43 plus k multiplied by 180, k being some integer, right? Being some integer of choice. And then the second general solution, x is equals to, so where is tan negative? Also tan is also negative on the 4th quadrant, right? So we're gonna have 360 minus the critical angle 26.57 plus k multiplied by 180, and then yeah, k being an element of some integer. So if we say 360 minus 26.57, we should get, what should we get? We should get 333.43 plus k multiplied by 180 period of tan, right? Where k is an element of integers, right? And then now we are done with that part. We can move to the part where we had the sign, right? So the general solution for that part where we had the sign, we're gonna have the first one, x being equals to, so look here, what we circled here, right? We want quadrants where sign is positive, right? This is not x here, it's supposed to be 2x. So we have 2x being equals to, so in the first quadrant, we just use the angle as it is, right? So here we're just gonna have what do we have? 19. So we have 19.47 plus k multiplied by the period of sine, right? What is the period of sine? The period of sine is 360. So we have 360 k, an element of some integer, right? So what we want to do here, we have 2x, right? So we're going to divide throughout by 2 so that we can have the value of x. If we do that, we're going to get x being equals to, so 19.47 divided by 2 should be 9.735 plus k, and then 360 divided by 2, that should be 180, right? K is still an element of some integer, right? So that's one of the solutions. And then now let's move to the second quadrant, because sign is also positive there. If we move there, we're going to get 2x being equals to 180 minus the critical 19.47 plus k multiplied by 360, k being an element of some integer, right? And then yeah, we can just divide by 2 throughout, right? Even though we still have 180 minus 19.47 there. So if we divide by 2 throughout, we're gonna get x being equals to, so we have 180 minus 19.47 divided by 2, which is giving me 80.265 plus k, 360 divided by 2, that's 180. And then we know that k is an element of some integer. Yeah, let's do 5.4 and 5.5 on a separate video, right? This one is already too long.
Write down the period of G. What is the period? The period is the time it takes to complete one cycle. So let's go ahead and take a look at G. As you can see, from x is equals to 0 to x is equals to 180 degrees, we have one complete cycle. The graph completes itself once. So that is the period of G. It is 180 degrees. It takes 180 degrees for the graph to complete itself. And then 6.2.1, let's calculate the value of k. So let's go ahead and look at our graph. K is the y value of our coordinate A. A is the intersection between f of x and g of x. We have the equation of both. We can just go ahead and use the equation of f of x. F of x is equals to tan of x. So if we substitute x is equals to 60, we should have f of 60 being equals to tan of 60 degrees. If you put this in your calculator, you're going to get k is equals to square root of 3, of which in decimal it is equals to 1.73. This is the value of k. 6.2.2, let's go ahead and take a look. In 6.2.2, we're supposed to find the coordinates of B. Let's do some analysis. From B to A, the graph completes itself once. There is one cycle between A and B. And we know the period of G of x. So we can say that the x value at B will be equals to the x value at A minus 180 degrees. This is equals to minus 120 degrees. Yeah, this is because from B to A, it's 180 degrees. So to find the x coordinate of B, we can say 60 minus 180 degrees, which is equals to minus 120 degrees. That is the x coordinate of B. And then the y coordinate, A and B share the same y coordinate. So y of B is also equals to square root of 3. So the coordinates of B, minus 120 degrees and square root of 3. That is 6.2.2. Let's go ahead and take a look at 6.3. So in 6.3, we're supposed to write down the range of 2g of x. But before we can look at 2g of x, let's try determining the range of g of x. Right, g of x is equals to 2 sine of 2x. The range of sine of 2x is -1 to +1. But because we have this amplitude of 2 and not 1, like we usually do, the range of g of x is from -2 to +2. So if we're looking at the range of 2g of x, which will be equals to 4 sine of 2x, then the range y will be an element of -4 to +4. And this right here is the range of 2g of x. We just multiply in the range of g of x by 2. You can always use this technique with any other question that is looking for the range. You find the range for the whatever function you're given, and then if it is 3 multiplied by that function, then you just multiply the range by 3 in this variation. That is 6.3. Let's go ahead and take a look at 6.4. Right, 6.4. For which values of x will g of x plus 5 minus f of x plus 5 be less or equals to 0? So we have x plus 5 and x plus 5. But before we can determine that, let's instead determine g of x minus f of x being less or equals to 0. After we find the answer for g of x minus f of x being less or equals to 0, then we're going to be able to find g of x plus 5 minus f of x plus 5. If we take minus f of x to the right hand side, we're going to have g of x being less or equals to f of x. As you can see now, our question changes. It's now very clear. We're looking for the value of x for which f of x is greater or equals to g of x. So let's go ahead and take a look at our diagram and see where we have. We are looking for the values of x for which f of x is above g of x. But we have an interval between -90 and 0. So this is the only part we are interested in. Yeah, where is f of x above or equals to g of x in that interval? Well, from this point they intersect until x is equals to 0. Do you know the x values for this point where they intersect? Let's go ahead and see if we can deduce that. If you look at a, the x coordinate of a is 60. The x coordinate of this point where they intersect will be -60 degrees. Why are we saying that? Where is that coming from? Take a look at our graph. From -90 to 90, g of x completes itself. From -90 to 90, f of x completes itself. So this point where they touch, let's call this point A prime. It is just a reflection of this point A. That is why if the x value at A was 50, the x value at the point where they touch will be -50. So let's go ahead and write our solution. F of x is greater or equals to g of x when x is equals to -60 greater than until x is equals to 0. This is for g of x being greater or equals to f of x. But instead, what we have is g of x plus 5 being less or equals to f of x plus 5. So what does this x plus 5 do to a function? It shifts the function to the left. If it was minus, it will be shifting it to the right. So if you are at -60 and you shift 5 units to the left, then you will be at -65 degrees. And if you're at 0 and you shift 5 units to the left, that is -5 degrees. And this is the solution we are looking for. Right, this is just helping us get there. Okay, 6.5. Determine the values of p for which sine x multiplied by cos x is equals to p. We'll have exactly two real roots in the interval. X is an element of minus 180 degrees to 180 degrees. So we have sine of x multiplied by cos of x being equals to p. Well, usually these questions, they are all related to each other. What do we have from our previous solutions or from our question that is very close to sine of x cos of x? Well, it is the mere fact that sine of 2x is equals to 2 sine of x cos of x. So what we can do to this equation, we can say 2 sine of x multiplied by cos of x is equals to 2p. We are multiplying by 2 on both sides. Why are we multiplying by 2? So that we can change this term to sine of 2x is equals to 2p. We know fully well that, let me show you, g of x is equals to 2 sine of 2x. So in order to get that, let's multiply out by 2 again. If we do that, we have 2 sine of 2x being equals to 4p. What is the maximum value of 2 sine 2x? Is 2 because of the amplitude. And the minimum value is minus 2. So we can say that 4p can be equals to 2. And 4p can also be equals to minus 2. We know that this is true at some point of time because 2 sine of 2x has a maximum of 2 and a minimum of minus 2. So p is equals to 1 divided by 2, or p is equals to minus 1 divided by 2.
Determine the length of AD in terms of P. So let me just highlight AD here so that we can have a bit of clarity. So there's AD, right? And then we want AD in terms of P, right? If you look at this triangle here, you're going to see that BD has this length of 2P and AB has a length of square root of 5 P, right? So we can use that triangle ABD. It has the most information and it has our variable P that we're supposed to determine AD in terms of. So let's use triangle ADB to determine the length of AD. In triangle ADB, you will realize very quick here that this angle here is 90 degrees, right? And AD is actually the hypotenuse of that triangle. If it is the hypotenuse, then we can use the Pythagoras theorem, right? So we're going to see that 7.1, we have AD squared, right? Hypotenuse squared will be equals to the other two sides squared, right? So BD squared. There we go. So we're going to have AD squared being equals to, what is AB? AB is square root of 5 multiplied by P, right? Squared plus BD squared. What is BD? That is 2P, right? And then we square that. So AD squared will be equals to 5P squared plus 4P squared. Now it's easy to see that AD squared is equals to 9P squared, right? If you take square root on both sides, you're gonna get AD is equals to 3P, right? And just like that, we're done with that question. Now let's solve 7.2. 7.2 says that let's show that the length of CD, let's just highlight CD before we go any further, right? So we are interested in CD, right? Let's show that the length of CD is equals to 3p sine of x plus x divided by square root of 2 sine of x, right? So let's look at CD. So we have the length of AD, right? We're saying that it is 3p, and then we have CD. So if you look at triangle ACD here, you will realize that here we have x, here we have 45. So this angle here should be 180 minus 45 minus x, right? So we have two angles and one known side. We can use the sine rule, right? So let's try apply the sine rule and see what happens. So if we do that, we're gonna get sine of A divided by A. We are in triangle ACD there, right? Let's be very clear about that. Being equals to sine of B divided by b. So you take sine of an angle, and on the denominator you put the side opposite that angle, right? So if we say sine of x here, then we're gonna put 3p as the denominator, right? So let's do that. We're gonna have sine of x divided by 3p, right? Because that is the length of AD, being equals to, let's not forget our aim. We want to prove the length of CD, right? So we're gonna use this angle here, which is 180 minus 45 is 135. So the size of that angle is actually 135 minus x, right? So we're gonna have sine of 135 minus x divided by CD, right? The length we're interested in. But then now it gets a bit complicated. You will realize that here we actually have a compound angle, right? But then that shouldn't be a problem, because we know that if we have sine of a minus b, this will be equals to sine of a cos of b minus cos of a sine of b, right? So we can just use that formula there to get rid of sine of 135 minus x, right? Because we cannot determine that because we don't know what x is. So we're gonna have sine of x divided by 3p being equals to so that will be sine of 135 multiplied by cos of x minus cos of 135 multiplied by sine of x, and then everything divided by CD, right? So we have CD here. So sine of x divided by 3p will be equals to sine of 135. Sine of 135 is square root of 2 divided by 2, and then multiply by cos of x, right? We don't know x, so we cannot do anything to that. And then minus cos of 135. Cos of 135 is minus square root of 2 divided by 2. So this will just become plus square root of 2 divided by 2. And then sine of x is just sine of x, right? There's nothing more we can do there. Divided by CD, right? So sine of x divided by 3p will be equals to, obviously we're taking square root of 2 divided by 2 as a common factor, right? But then before we do that, we know fully well that square root of 2 divided by 2 is equals to 1 divided by square root of 2, right? You can actually prove this. Say square root of 2 divided by 2 minus 1 divided by square root of 2. You will get 0 because they are equals to each other, right? So instead of writing square root of 2 divided by 2, we can write 1 divided by square root of 2, right? And take that as a common factor instead. So we're gonna have cos of x plus sine of x divided by CD, right? So this we can cross multiply here. If we cross multiply, we're gonna get sine of x multiplied by CD being equals to 3p multiplied by 1 divided by square root of 2 multiplied by cos of x plus sine of x, right? And then everything divided by no, we're not dividing yet. But now we can divide both sides by sine of x, right? If we go ahead and divide both sides by sine of x, then we're gonna have CD being equals to 3p multiplied by 1 divided by square root of 2 multiplied by cos of x plus sine of x divided by sine of x, right? But then instead of putting 1 divided by square root of 2 on the numerator, we can just write CD as 3p multiplied by cos of x plus sine of x divided by sine of x, and then multiplied by square root of 2. And we have proved exactly what we are supposed to prove. Now let's do the last question. 7.3 is saying to us, if it is further given that p is equals to 10, so p is equals to 10 and x is equals to 110 degrees, let's calculate the area of triangle ADC, right? The area of triangle ADC. Let me just erase a few stuff so that we can have a bit of clarity here. So we want triangle ADC. We are interested in triangle ADC, right? So when we want to find the area of a triangle, right, we say half side 1, side 2, and then sine of the angle the two sides sandwich, right? So in this question, we know the length of size AD, right? And we know the length of size CD. So we have to use this angle here that they sandwich, right? So if we do that, we're gonna get the area of that triangle being equals to a half and then 3p, right? AD, and then multiply by the other side CD, and then sine of 45 degrees, right? But we know what CD is, so let me just put what CD is there instead. So CD is 3p multiplied by sine of x plus cos of x, everything divided by square root of 2 sine of x, and multiply by sine of 45. We know what P is, right? P is 10, and we know that x is equals to 110. So we can just substitute 10 and 110 there, right? So that I don't waste time, I'm just gonna do it here already, right? So instead of P there, I'm going to put multiply by 10, right? Because P is 10. Here I'm also going to multiply 3 by 10. Instead of sine x and cos x, I'm just going to have sine of 110 plus cos of 110 divided by sine of 110, right? And then if you put this in your calculator, you should get 143.11 units squared. Always the center of the circle, MNPR, it's a cyclic quadrilateral, right? So let's just highlight MNPR. So we're saying that MNPR is a cyclic quadrilateral, and SN is the diameter. So we have SN is the diameter there, and then we have chord MS and radius OR, right? So let's jot down our keywords, right? We know that we can use the properties of a cyclic quad, right? And then what else do we have? We have diameter. We know that it subtends an angle of 90 degrees on the circumference of the circle. And then we have chord, right? Equal chords, subtend equal angles, and so on. And then we are told that M2 is equals to 64 degrees. I think now we can answer our question. 8.1.1 says that let's determine, given reasons, the size of the following angles. And then we started with P, right? P is this angle here. But because we know that MNPR is a cyclic quad, then P plus M2 should be equals to 180 degrees, right? That's a property of a cyclic quad. So we have M2 plus P being equals to 180 degrees, right? Opposite angles of a cyclic quad sum up to 180, right? And then what is the size of M2? M2 is 64 degrees, and then plus P, which we're looking for, being equals to 180 degrees. So now it should be easy to see here that P is equals to 116 degrees, right? And then 8.1.2 saying that let's determine the size of M1. So M1 is this angle here, right? So let's go to our keywords. We've used a cyclic quad already, and then M1 has nothing to do with the cyclic quad, right? So now let's use the keyword diameter, right? If we use the keyword diameter there, we'll see that M1 plus M2 should be equals to 90 degrees, right? Because they're being subtended by diameter SN. So now we're saying that M1 plus M2 should be equals to 90 degrees, right? Why are we saying that it should be equals to 90 degrees? Because it's being subtended by a diameter, right? So now we can say that M1 should be equals to 90 degrees minus 64 degrees, right? That is M2. So M1 should be equals to 26 degrees. And the last one, 8.1.3, we're looking for the size of O1, right? If we come to our keywords here, the only keyword that we have left is quadrant, but it won't help us with much. But what I want you to realize here is that O1 should be twice M1, right? We're saying that O1 here should be twice M1, right? Because an angle at the center of the circle is twice the angle at the circumference if they are from the same arc, right? You can see here that O1 is a consequence of SR here, and the same is true with M1, right? O1 is at the center and M1 is at the circumference. So now we can say that O1 is equals to 2 multiplied by M1. But what is M1? M1 is 26 degrees, right? So 2 multiplied by 26, that should be 52 degrees. So let's give a reason why DE is parallel to BH. So let me just highlight DE real quick. So we have DE here, and then BH is this line here. So we know fully well that if a line parallel to one side of a triangle, so this line DE here, if it's parallel to BG, then it should divide the other two sides proportionally, right? We can see here clearly that for 8.2.1, AD divided by DB should be equals to AE divided by EG, right? Because AD is equals to DB and AE is equals to EG. So we can conclude and say that DE is parallel to BH because it divides AB and AG proportionally. Now let's do 8.2.2. So 8.2.2 is saying that if it is further given that FC divided by BF is equals to 1 divided by 4, and that DE is equals to 3x minus 1, and GH is equals to x plus 1. Let's calculate, given reasons, the value of x, right? When you just look at DE is equals to 3x minus 1 and GH is equals to x plus 1, you can think the problems are really complicated, especially if you look at the sketch again and you look how it is. Yeah, you might get intimidated, and then you even see the mark allocation, 6 marks. But let's see what happens. So right now, we know that, let me just erase this line. So right now we know that FC divided by BF is equals to 1 divided by 4. And then we given DE, right? The length of DE in terms of variables. So we're given 3x plus 3x minus 1 there. So let me just write it down. We're given 3x minus 1 here. And then what else are we given? GH is x plus 1. So here we're given x plus 1. Okay, so now I see what's happening here. If DE, right? If this line here, DE, cuts AB and AG such that AD is equals to DB, right? You can see here, because of these lines that we given, that AD is equals to DB. If DE cuts AB such that AD is equals to DB, then we can say that BG is equals to 2 times BE. Right? DE will only cut AB and AG such that AD is equals to DB if DE is half of BG, or if BG is twice BE, right? So the reason we can give here for this statement here is that AD is equals to DB, right? This statement here is only true if AD is equals to DB. So if we say that, you will realize real quick that BG now becomes 2 multiplied by 3x minus 1, right? So now using that triangle BHC, we can say that in triangle BHC, we can say that, so what do we have? We can say that FC divided by BF should be equals to GH divided by BG. And why are we saying that? We're saying that because FG is parallel to CH, right? We can only see that if we have two parallel lines, right? So what is FC divided by BF is given to us. We have 1 divided by 4. But what is GH? GH is x plus 1. Right, and then BG is 2 multiplied by 3x minus 1, which will just become 6x minus 2. Right, so now we are actually done with the conceptualization, right? We're just computing the value of x. So if we cross multiply here, we're gonna get 6x minus 2 being equals to 4x plus 4. So it should be easy to see here that 2x will be equals to 6, so x should be equals to 3, right?
We need to prove that a line from the center that bisects the chord is perpendicular to the chord. We're going to do that in 3 easy steps, right? So step number 1 is to make some construction, right? So let's go ahead and construct OA and OB. Let me show you what I'm talking about. So we are going to join OA here. So let me just do that real quick, and then we're also going to join OB, right? And now we can move to the second step, right? So the second step, we're going to prove that triangle OAD and triangle OBD are congruent. How can we possibly do that? We can start by saying that OA is equals to OB. They're all radiuses, right? So they're supposed to be equals to each other. And then now we can say that OD is equals to OD in the two triangles because it's a common side, right? So our reason here will be common, is a common side. And lastly, we're going to say that AD is equals to DB, right? That's given. We can clearly see on our sketch that is given to us. So if those 3 sides are equal, we can then conclude that triangle OAD is congruent to triangle OBD. And why are we saying that? Side. All 3 sides are equals to each other. And now we can move to the last step. What do we know about perpendicular lines? We know that if 2 lines are perpendicular, then where they touch, they should make an angle of 90, right? So if we can prove that we have 90 right there, then beyond reasonable doubt, OD is perpendicular to AB. So let's call this angle here D1 and call this angle here D2 as part of our constructions. But we know that D1 is supposed to be equals to D2. Why am I saying that? Triangle OAD is congruent to triangle OBD, right? All corresponding angles should be equals to each other. So D1 should be equals to D2, right? But then it's easy to see that D1 plus D2 is equals to 180 degrees, right? As they are angles on a straight line. But D1 is equals to D2, so we can just say that 2D1 is equals to 180 degrees. So what are we saying? We're saying that D1 is equals to 90 degrees. So now we have proved that D1 is 90 degrees. We're gonna know fully well that consequently D2 is also equals to 90 degrees. Now we can conclude and say that OD and AB are perpendicular to each other because D1 is equals to 90 degrees, right?
9.2.1, let's prove that OTBG is a cyclic quad. So we're talking about OTBG. We need OTBG to be a cyclic quad, right? But then what does it mean when OTBG is a cyclic quad, right? That quadrilateral should fit on a circle, right? And then all the vertices must lie on the circumference of the circle. So we must be able to draw a circle, right? Obviously, I'm not going to do any justice drawing the circle, but we must be able to have something of this manner if OTBG is a cyclic quad, right? B is also lying on the cyclic quad. Yeah, that's what we mean when you say OT BG is a cyclic quad. So when I tried solving this problem, the mistake I made, I tried proving that it's a cyclic quad by saying that this angle here plus this angle here, they should be equals to 180. That is correct, right? And then another way I try to prove it is that this angle here should be equals to that angle there. And then I couldn't prove it using those two ways, right? I'm not saying those ways are not correct. They're correct, but when I tried proving that OTBG is a cyclic quad using those ways, I couldn't, right? And then what helped is realizing that if OTBG is a cyclic quad, then this angle here, GBT, this angle GBT should be equal to the angle GTO, right? Why should they be equal to each other? Because they're being subtended by the same chord GO, right? So if we prove that those angles are equal to each other, then we have proved that OTBG is the cyclic quad. So let's go ahead and try that. So let me just erase this. So we are required to prove that angle GBO is equals to angle GTO. If we can prove that, then indeed OTBG is a cyclic quad, right? So let's go ahead and try and prove that. So very quick, you can see here that this line from the center is cutting the line EF in half, right? If it cuts the line EF in half, then this angle here should be 90 and this angle here should also be 90. So what are we saying? We're saying that GTO, yeah, that's correct, is equals to 90 degrees, right? The line from the center is bisecting the chord, right? So that angle there should be 90 degrees. So now we know fully well that GBO should also be 90 degrees. And indeed it is. We're going to say that GBO is equals to 90 degrees. Why are we saying GBO is equals to 90 degrees? Because this radius here will be perpendicular to the tangent, right? We know that fully well. So the radius is perpendicular to the tangent, right? So now we've proved that GTO is equals to GBO because they're all equals to 90 degrees, right? And then as a consequence, OTBG is a cyclic quad, right? It's a cyclic quad because clearly GBO and GTO are lying on the same segment. Now we can do 9.2.2 because we have proved beyond reasonable doubt that OTBG is a cyclic quad. So 9.2.2 is saying that let's prove that GOB. So let's just get rid of that. We have GOB here. So here's GOB. We're supposed to prove that apparently GOB is equals to angle S, right? But then immediately when you look at this, you would think that angle S is equals to angle STF, right? Because they are alternating. So let's just write that down. So we're saying that angle S is equals to angle STF because they are alternating angles, right? If you just look at that. But then if you look at STF, you will see that STF is equals to GTB, right? GTB. So we say that angle S is equals to, not angle S, but angle STF. So angle STF is equals to GTB because those are vertical opposite angles, right? Yeah, whatsoever the reason is. Yeah, we know that STF should be equals to GTB, right? But I kid you not, GTB should be equals to B, right? GTB is being subtended by GB, right? And then GOT is also being subtended by GB. We've proved that OTBG is a cyclic quad, so we can get away with saying that, right? So here we're gonna say that they've been subtended by the same code, right? By the same code. Yeah. So now you can see that we're saying that GOB is equals to GTB, and here we say that S is equals to STF, but STF is equals to GTB. So now we can say that angle S is equals to angle GOB. Why are we saying that? They are all equals to angle GTB. Let's see what's happening here. So in the diagram, PQRS is the cyclic quad. So let's indicate that, right? We have PQRS being a cyclic quad. I'm just going to write that down too, because a cyclic quad is very important to us, right? There's a few properties around that. And then KP is a tangent. So let's have tangent there. And then what else do we have? We are told that CA is parallel to QS, so we have parallel lines. And then P1 is equals to R2, right? So what I've been proposing is that with only these 4 keywords, we should be able to, answer all these questions that we have, right? So let's go ahead and give it a try and see what happens. So the first question, 10.1, is saying that let's prove, given reasons, that S1 is equals to T2. And yeah, indeed, S1 is equals to T2. Let me show you how. So let's look at S1. S1 is here, right? Is an exterior angle of a cyclic quad, right? We're using our first keyword there. So if it's an exterior angle of a cyclic quad, it should be equals to Q1 plus Q2, right? So S1 is equals to Q1 plus Q2, right? An exterior angle of a cyclic quad is equals to interior opposite, right? Yeah. So we have exhausted the cyclic quad. Now let's look at T2, right? Because we're supposed to prove that S1 is equals to T2. S1 has no immediate connection with T2, right? So let's try other ways here. When I look at T2, I realize very quick that T2 should be equals to R2 plus Q2, right? An exterior angle of a triangle is equals to the sum of the two interior opposite, right? So what are we saying here? We're saying that T2 will be equals to R2 plus Q2, an exterior angle of a triangle is equals to those two interior angles, right? So from here, where do we go? We can see that S1 is equals to Q1 plus Q2 and T2 is equals to R2 plus Q2, right? Let's go to our next keyword. We have the keyword tangent, right? Let's see what it can give us. So from the keyword tangent, we will see immediately that P1 here is supposed to be equals to Q1, right? P1 is supposed to be equals to Q1, right? Because of the turn chord theorem, right? Because of the turn chord theorem. So let's write it down. Let's say that P1 is equals to Q1 because of the turn chord theorem, right? So from here, what can we say? Let's look at the keywords again. With parallel lines, they won't give us much, but if you see here, we are told that P1 is equals to R2, right? P1 is equals to Q1, but then on the statement itself, we are told that P1 is equals to R2. So what does that tell us? That tells us that R2 is equals to Q1 because they are all equals to P1, right? So now you should be able to see here. Let me show you something. Now you should be able to see here that instead of R2, we can write Q1 because we have proved that R2 is equals to Q1 because they're all equals to P1. So instead of R2 plus Q2, we can say Q1 plus Q2, right? So now it will be easy to see here that S1 is Q1 plus Q2 and T2 is Q1 plus Q2. So we have proved that T2 is equals to S1 since they are all equals to Q1 plus Q2. And yeah, you get your 4 marks. And then now let's move to 10.2. So we are at 10.2 now. So 10.2 is saying that let's prove, given reasons, that AD divided by AR is equals to AS divided by AC. So let's go and look at those lines and see what's happening, right? Are we going to use parallel lines, or do we have to prove that certain triangles are similar to each other? Let's go to our sketch. Yeah, so we have AD. Where's AD? Yes, AD here, right? So AD divided by AR, right? Divided by AR is said to be equals to AS divided by AC. So we have AS here divided by AC, right? So I can see immediately here that this is all going on in true triangles, right? In triangle, not A, but triangle. In triangle ASD and triangle ACR. So if we can prove that triangle ACD and triangle ACR are similar to each other, then we can play around with their sides, right, and be able to prove that. So let's go ahead and prove that triangle ACD and triangle ACR are similar to each other. Even when you look at them, right, they do look similar. But we have to prove we're not trusting our eyesight here. We actually have to prove that they're similar to each other. So real quick, you can see here that, let me just erase this line. So you can see here real quick, right, that A is a shared angle of the two triangles ASD and the triangle ACR, right? A is a common angle. So we can say that angle A is equals to angle A, obviously, right? It's a common angle, right? There isn't really much to say there. So from here, where do we go? Let's see. So here we are expecting angle S1 to be equals to angle C2, right? Because of just, how the triangles are. So let's, give it a look and see how we can potentially prove that. So we already know from 10.1 that S1 is equals to T2, right? But then, since these two lines here are parallel to each other, then T2 should be equals to C2, right? Because they are, is it called alternating, corresponding? I forgot the name, but it's called something. We know that C2 is equals to T2, right? And then you're gonna give that reason there. But you know what's going on. There's some reason there why T2 is equals to C2. It's because of the parallel lines for sure, but there's a specific reason why we say those are true. So now, since we've proved that T2 is equals to C2, we can conclude that D1 should be equals to R1. Why is D1 equals to R1? Because the third angle of triangles, right? If the other two angles are equals to each other, then consequently the third angle should be equals to each other. So we've proved that ASD is similar to ACR, right? So let's look here. ASD is similar to ASR. So now we can say that AD, right, divided by AR is equals to AS divided by AC, right? We can only have those lines if we've proved that those two triangles are similar to each other. So what are we saying now? Now we're saying that AD divided by AR can be equals to AS divided by AC if and only if triangle ASD is similar to triangle ACR, and that's how we do 10.2, right? So now let's look at 10.3. So 10.3 say that let's prove that AC multiplied by CD is equals to AR multiplied by TC. In this question, I cannot see an immediate way why AC multiplied by CD should be equals to AR multiplied by TC. But you just wrote this paper today. If you have an idea, let me know in the comments.
Determine the equation of the least squares regression line for the data. Let's take a look at what's happening here. So truck drivers travel a certain distance and have a rest before traveling further. Okay, makes sense. A driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes, and the amount he rested in minutes before he continued his journey. The information is given in the table below. We have the distance traveled in kilometers, which is our x, and the amount of rest time in minutes, which is our y. It's really helpful that they're telling us which one is the x and which one is the y. Okay, sort of makes our equation simple. 1.1, we're supposed to determine the equation of the least squares regression line for the data. Well, our equation for this is y is equals to a plus bx. Basically, we need to find a and b. If we do that, we have the equation for the least squares regression line for the data. I've showed you how to do this before, but let's go ahead and do it again. We're going to use our calculator. So what you want to do, you want to press mode setup, and then you press start, which is option 3 on this calculator that I'm using. After that, you press 2. As you can see that it says a plus bx, which is what we are interested in. Okay, when you do that, you're going to have this table. You enter your x variables and you enter your y. Okay, so let's go ahead and punch in the x. We have 180 followed by 200, 400, 600, 170, 350, 270, and 300. Okay, after doing that, we want to punch in the y values next to the corresponding x value. So 180 is going with 20, 200 is going with 25, 400 is going with 55, 400 with 55, 600 with 120, a big jump between 400 and 600, and then 170 is going with 15, 350 with 50, 270 with 40, and lastly 300 with 45. You have to verify that you've entered the correct data, because if you make a mistake when you enter your data, all your answers are going to be incorrect. So after entering your data, you press equals to a couple of times, you press AC. After doing that, we have shift 1, and then we go to 5, regression. It can be option 6 on a different calculator, it doesn't matter, but we want regression. Okay, and then let's go ahead and determine A. A will be equals to, so we have A being equals to. So let me press 1 and equals to. If I do that, I get minus 23.85 as the value of A. Okay, now I'm interested in the value of B. So I'm going to press AC, shift 1, 5 for regression, and then now I press 2 for B. B is equals to 0.23 if I round it off to 2 decimal places. So there we go. We have the equation for the least squares regression line using our calculator. So we're going to have y being equals to minus 23.85 plus b, which is 0.23 multiplied by x. So that is our equation for the least squares regression line. Let's move forward and do 1.2. So 1.2, if a truck driver traveled 550 kilometers, predict the amount of time in minutes that they predict the amount of time in minutes that he should rest before continuing his journey. So we are given an x, which is equals to 550, and we want the y, which is the amount of time. So we are substituting 550 into this equation. If we do that, we're going to have minus 23.85 plus 0.23 multiplied by 550. I need to put that in my calculator. So minus 23.85 plus 0.23 multiplied by 550. I'm getting 102.65. Let me see if it makes sense. 400 is 55, 600 is 120. So 550 should be in between. Yeah, I'm quite happy with that answer. It makes a bit of sense, right? If it was 10 or if it was 300, then it wouldn't make any sense. Anyway, stories. Let's carry on. Let's do 1.3. Write down the correlation coefficient for the data. Again, in order to do this, we have to use our calculator. So let's go ahead and do that. AC, shift 1, 5 for regression, and then we press 3 for R, the correlation, right? We get R is equals to, let's see, R is equals to 0.98. So, right, that is the correlation coefficient for the data. 1.4. Interpret your answer to question 1.3. Well, the phrasing of your answer will be different from probably other people. But basically, there's a strong correlation between the distance traveled and the amount of rest time. As you can clearly see, it is 0.98. If it was 0.2, 0.1, then there will be a very weak correlation between the x and the y. But in our case, we have a very strong correlation. So the phrasing of that answer will be different, right? But basically, there's a strong correlation between the distance traveled and the amount of rest time in minutes. That is 1.4. On the other hand, 1.5, at each stop, the truck driver spent money buying food and other refreshments. The amount spent in rands is given in the table below. Okay, we have the amounts. And the first question, 1.5.1, calculate the mean amount of money he spent at each stop. Again, we can use our calculator here. Let me show you how. So we press AC. Now we want to change our data. So we're going to press mode setup, and then we press 3 for test. And now we press 1 for one variable. We are only interested on one variable now. So we're going to have 100, 150, 130, 250, 180, 200, 190. Okay, and then we press AC. We want the mean. So for the mean, we're going to press shift 1. Now we don't press 5, but we press 4 instead. So let's go ahead and do that. Okay, so the mean is x bar. That is option 2 on my calculator. When I press that, I'm getting 150. So that is my mean, 150. Okay, you can do this with a calculator, or you can do this manually. I think answer only will be the full marks. If you write only the answer, you still get the full marks. I think that's how it works. Okay, you can say otherwise if that is not the case in the comments. And 1.5.2, calculate the standard deviation for the data. So shift 1, 4, obviously, and then we press 3. That is the sign for standard deviation. So the standard deviation is, our standard deviation is 50.497, so 50.5. That's our standard deviation. And the question that follows, 1.5.3, we want to know how many stops did the driver spend an amount that was less than 1 standard deviation below the mean. What does that mean? 1 standard deviation below the mean. So is the mean minus the standard deviation, which is 50.5. Okay, what do I get? I get 99.5. 1 standard deviation below the mean. Okay, so anything less than 99.5, I think it is only 50, which is 1 standard deviation below the mean. So at how many stops? At 1 stop, at only 1 stop. Okay, that's where the amount spent was 1 standard deviation below the mean. Before I let you go, which question should I do next? Please leave a comment. Let me know which question you want me to do next. The answer to 2.4, the value of k. K is equals to 12. And I will show you why that is the case. Let's do 2.1, 2.2, and 2.3 first. Okay? So 2.1. At a certain school, the staff committee wanted to determine how many glasses of water the staff members drank during a school day. Okay? All teachers present on a specific day were interviewed. The information is shown on the table below. Okay? And the first question, 2.1, complete the cumulative frequency column provided in the table in the answer book. Well, I don't have the answer book, so I'm just going to put the cumulative table right here. So let me go ahead and do that. So on the first column, I'm just going to have 5. And then following 5, I'm going to have 5 plus 15, which is 20. Okay? After that, I'm going to have 20 plus 13, which is 33. Okay? 33 plus 5 is 38. 38 plus 2 is 40. So your table for the cumulative frequency should look something like this. 5, 20, 33, 38, and lastly 40. Okay? So that is 2.1. We are done with that. 2.2, on the other hand, how many staff members were interviewed? The staff members that were interviewed, 40. Okay? That is the total number of staff members when we add all these up. 5 plus 15, 20 plus 13, 33, plus 5 plus 2, 40. So we are 40 staff members at this school. That is 2.2. Okay? 2.3. How many staff members drank fewer than 6 glasses of water during a school day? So let's take a look at how our data is represented. So in this line, we have fewer than 6, right? As this is less than 6 and not less or equals to. So the people who drank fewer than 6 is 13 plus 15 plus 5. Those are the people that drank fewer than 6 glasses of water in a day. So 15 plus 13, 13 minus 2 is 28, okay? 28 plus 5, so we have 33. 33 people drank less than 6 glasses of water, which makes sense. Why are you drinking 6 glasses of water anyway? But that's not what we're interested in. Let's go ahead and do 2.4. The question we are really interested in, okay? This took me some time to figure out, but let me show you why I'm saying that k is equals to 12. K is equals to 12. If you didn't get 12, your answer is wrong. There is no way. I answered this question using a lot of different methods, and the answer, k is equals to 12. There's no way around it. Okay? So the staff committee observed that k teachers were absent on the day of the interviews. Okay? It was found that half of these k teachers drank from 0 to fewer than 2. Okay, so let's make sense of that information from the get-go. Let's look at the column with the number of staff members. I want to show you something. Okay? So k teachers were absent, and then half of these k teachers drank between 0 and 2 glasses. So for 0 to 2 glasses of water, we have 5 plus k divided by 2, okay? Because we know that k divided by 2 teachers drink between 0 to 2 glasses of water. Let's carry on reading our information. While the remainder of them drank from 4 to fewer than 6. So 4 to fewer than 6, we have another k divided by 2. Okay, we have k teachers that were absent. Half of them drank between 0 and 2. Half of k is k divided by 2. And the remaining, which will be k divided by 2, drank between 4 to 6. So, yeah, the number of staff members for 4 to 6 is 13 plus k divided by 2. That is the important part. You need to be able to comprehend that in order to answer this question. Okay, let's carry on and hear the stories. When these K teachers are included in the data, the estimated mean is 4 glasses of water per staff member per day. How many teachers were absent on the day of the interviews? Basically, what is the value of K? Okay, so let's go ahead and compute that. The formula we have the mean being equals to the sum of the midpoint multiplied by the frequency divided by the cumulative frequency, the total number of staff members. Okay, so we need to find the mid and we need to multiply that mid with the frequency and then divide by the cumulative. Let me show you what I'm talking about. Okay, so let's find the midpoint. So the first step is to find the midpoint. What is the midpoint of 0 to 2? That is 1. The midpoint of 2 to 4 is 3. That of 4 to 6 is 5. Of 6 to 8 is 7. Of 8 to 10 is 9. So that is the midpoint. And then we have the frequency, okay? So the frequency for 0 to 2, we know that it is 5 plus k divided by 2, followed by 15, and then 13 plus k divided by 2. For 7, the frequency is 5. For a midpoint of 9 glasses, the frequency is 2. Okay? And then now we're supposed to have the midpoint multiplied by the frequency. So what is 1 multiplied by 5 plus k divided by 2? That will just give us 5 plus k divided by 2. Okay? 3 multiplied by 15, that's 45. And then what is 13 multiplied by 5? Let me just put that in my calculator real quick. So I have 65. I have 65 plus k divided by 2 multiplied by 5. So I have 5k divided by 2. 7 multiplied by 5 is 35. And then 9 multiplied by 2 obviously is 18. Okay. And then the total. Okay, I have to find my totals now. The total for the frequency, I know that the cumulative frequency was 40, right? So now I'm going to have 40 plus k, right? For the k teachers that were absent. Okay, that is quite easy to see. And then midpoint multiplied by frequency, I need the total for that. I'm going to add up the numbers first. So I have 5 plus 45 plus 65 plus 35 plus 18, which is 168. I have 168 plus 1 divided by 2k plus 5 divided by 2k. That is plus 3k. Okay, now we can go ahead and substitute on our formula. Let's not forget that we're supposed to come and substitute here. If we do that, we're going to have the mean, which is 4, being equals to the midpoint multiplied by the frequency, the sum. So that is 168 plus 3k divided by the cumulative frequency, that is 40 plus k. If we cross multiply, 4 multiplied by 4 is 16. So this will be 160 plus 4k, which is equals to 168 plus 3k. Okay. If I take 30k to the left hand side, I'm going to have 4k minus 30k, which will be k. 168 minus 160 should be 8. Well, it seems like k is actually equals to 8 and not 12. Okay. Which question do you want me to do next? Let me know in the comment section. Which question do you want me to do next? Okay, let's chop it up real quick. So the first question, 3.1, we want to calculate the length of SL and leave our answer in set form. Okay, let's go ahead and do that. So SL will be equals to the square root of y2 minus y1 squared plus x2 minus x1 squared. The basics, really, nothing complicated. I don't think we should be getting this kind of questions wrong. So we have SL. Let's take L as our first point and S as our second point. So y2 will be the y value of S, which happens to be 5, minus the y value of L, which is 1. So we have 5 minus 1 squared plus x value of S, that is 4, minus the x value of L, which is minus 4. So 4 minus 4 is plus. So we have plus 4 squared, okay? The answer here is 4 square root of 5, okay? We shouldn't be getting that wrong. Let's go ahead and do 3.2. 3.2, we're looking for the gradient of Sn, okay? So this is S and this is N. We have said that S is our second point. So let's take N as our first point and see what we get. So the gradient that is y2 minus y1 divided by x2 minus x1, right? The y value of S is 5 minus the y value of N, which is minus 3. So 5 minus minus 3, that is just plus 3, okay? Divided by the x value of S, which is 4, minus minus 2, so that is 4 plus 2. So we have 8 divided by 6, which should be 4 divided by 3, okay? I think that is the answer we are supposed to get. I don't know if I trust that answer or not. So let me do it the other way around and see if I get to the same conclusion. So minus 3 minus 5 divided by minus 2 minus 4 minus 8 divided by minus 6. Okay, I think we're good to go. That is 3.2. We are really sticking to the basics. We haven't solved any question that is complicated up to so far. So we should have those marks in the bag. 3.3. Calculate the size of theta, the angle of inclination of Sn. Okay, we know fully well that tan of theta should be equals to the gradient of that line. So theta will be equals to tan inverse of the gradient, which happens to be 4 divided by 3. Okay, let me just put that in my calculator again so that I don't make any silly mistake. That is 53.13 degrees. Okay, so how many marks? 2226. So we have 6 marks in the bag. We haven't done anything complicated. It's just standard procedure. Let's take a look at 3.4. 3.4, we're interested on the size of angle LNS. Let's go ahead and denote that we have this angle LNS, okay? How can we possibly find that angle? Well, in the question above, I was calculating theta. So let me see if I can use theta to get to angle alpha, of which is LNS in our case, okay? So because of vertical opposite angle, this angle right here should be equals to theta, okay? So this angle is 53.13. Okay, so how do I move after being able to realize that? I can find the inclination of Ln. Look at the inclination of Ln, this angle here, right? The inclination of Ln, let's call it this symbol. The inclination of Ln should be equals to theta plus alpha, okay? Why do I say that? This is an exterior angle of triangle KON. Well, not KON, but this point here. I don't know. This point doesn't have a name, but that is the point we're interested in. So that angle should be equals to theta plus alpha. So let's go ahead and find the inclination of Ln. So we have to find the gradient of Ln first if we want to find the inclination of Ln. In finding the gradient of Ln, we're going to have y2 minus y1 divided by x2 minus x1. Okay, let's take L as our second point and N as our first point. So y is 1 minus y of n, which is minus 3, okay, divided by x, which is minus 4, minus x of n, which is minus 2. So 1 minus minus 3, that is 4, minus 4 minus minus 2, that is minus 2. So the gradient of Ln is minus 2, okay? So now I have to go ahead and find angle, the inclination of ln, okay? So the inclination of ln will be equals to tan inverse the gradient of ln, which is minus 2. If the gradient is negative, you're going to find a negative angle. And when that is the case, we have to add 180 degrees, okay? So let me just put that in my calculator and see what I have. So tan inverse of minus 2 is minus 63.43. I add 180, I get 116.57, okay? So the size of this angle is 116.57. What does that tell us? Let's not forget what we are proposing. Let's not forget what we're proposing. That tells us that 116.57 is equals to theta, which is 53.13 plus alpha, okay? So our angle alpha, or LKN, LNS, not LKN, I'm sorry for that. Our angle alpha will be 116.57 minus 53.13. Okay, so let me just go ahead and put that in my calculator real quick and see what I get. I get 63.44 degrees. So yeah, that is the size of angle LNS. Why am I saying LKN? LNS. Okay. Let's see the gradient of ln, and then I find the angle of inclination 116. I'm looking for the angle of lns. Okay, yeah, we are good to go. That is the size of lns. Yeah, let me know in the comment if you found a different answer. You'll probably not find a different answer, but use a different method. I'm quite convinced that the approach I'm taking is the right one. That is 3.4. 3.5. Determine the equation of the line which passes through L and is parallel to SN. So the line is passing through L. Let me just erase all this for the sake of clarity. Okay. The line is passing through L and it is parallel SN. Do I have the gradient of SN? Yes, I calculated the gradient of Sn in 3.2. So let me just go ahead and take a look. It was 4 divided by 3. So that tells me that the line of which I'm interested in will have a gradient of 4 divided by 3 x plus c. Okay, parallel lines have the same gradient. Okay, so now I just have to find the value of c. But I'm given the point L. They say that the line goes through the point L. So I have coordinates minus 4 and 1, which I can substitute into this equation to find C. If I go ahead and do that, the y value is 1. The x value is minus 4 plus C. So C is equals to 1 plus 4 divided by 3 multiplied by 4. Okay, let me just check which answer I am getting. I have 19 divided by 3. Does it make sense? 4 multiplied by 4, 16 plus 3, 19 divided by 3. Okay, I think we're good to go. So y is equals to 4 divided by 3 x plus c. Why am I saying c? X plus 19 divided by 3. C is 19 divided by 3. If I substitute minus 4, will I get 1 if I substitute minus 4? That is the equation. Let me see if that will be the case. If that will be the case, minus 4 plus 19 divided by 3, 1. Okay, I'm getting 1 when I substitute minus 4. So I'm quite convinced that I have the correct equation. Okay, you can still get the corresponding y value and your equation be wrong. That is very possible. But anyway, let's carry on. Stories. I just did 3.5, so now we have to go to 3.6. 3.6. We want to find the area of LSN. The area of LSN. Okay, let me see how I can do that. The area of triangle LSN. So we have LSN. I calculated the length of SL in 3.1. So I have SL. SL is equals to 4 square root of 5. So this is 4 square root of 5. Okay. Here I have an angle of 90 degrees. So if I find the length of LN, I can easily find the area of triangle LSN because I'll just use half base multiplied by height. Okay. So let me go ahead and use that idea. So SL, I've already calculated it above. We have 4 square root of 5. Now I just need to calculate the length of line LN. So LN will be the square root of x2 minus x1. So if I take S as our LN, not LS, okay. If I take L as our second point and N as our first point, I'm going to have minus 4 minus 2, so minus 4 plus 2 squared, plus 1 minus 3, so 1 plus 3 squared. Okay, let me put that in my calculator again, just to make sure that I'm not making any silly mistake. Yeah, I always hate it when the concept is right and I just make a silly mistake. Okay, so I have ln. This is 2 square root of 5. And the sandwich, these two lines, the sandwich an angle of 90 degrees. So I can just say that the area of triangle, what are they calling it? LSN is equals to half SL multiplied by LN sine of 90 degrees. Sine of 90 degrees. Sine of 90 degrees is 1. That is why when the angle is 90, we just say half breadth multiplied by height. Anyway, stories. This will be equals to half. SL is 4 square root of 5 multiplied by 2 square root of 5 sine of 90, which is 1. So I just need to put that in my calculator. So half multiplied by 4 square root of 5 multiplied by 2 square root of 5 multiplied by sine of 90. I know sine of 90 is 1, so let me just leave that. Okay, I'm getting 20. Do we have a unit? I don't think we're given any units, so I'm just going to say 20 units squared. Some people will say 20 square units. I think, yeah, that should also be fine. So that is the area of LSN, okay? You could have used a different method, maybe use LN and LS. Yeah, I think you should still get to quite a good answer. Yeah, you should get to the correct answer either way. And then 3.7, calculate the coordinates of P, which is equidistant from L, S, and N. I must say, I spent more time on this question than any other, okay? Right, yeah, because it is not a concept that is usually examined, okay? So you want to find the coordinates of P, which is equidistant from L, S, and N. So what does that mean? That means that LP should be equals to NP. It should be equals to SP. This is what it means, okay? So in order to find the coordinates of that point P, which will make this requirement to be true, we need the point P to be the midpoint of NS, okay? That is when we have a right-angled triangle. The midpoint of the hypotenuse will be equidistant from the 3 other points. What the question is really testing here is this concept. Do you know this concept or not? It is not difficult to compute. It is not that demanding when it comes to the algebra side of it, okay? So the midpoint, the x value of the midpoint of our hypotenuse will be x of s plus x of n divided by 2. So we're going to have 4 plus minus 2 divided by 2. 4 plus minus 2, that is 2. 2 divided by 2 is 1. And then the midpoint will be y of s plus y of n divided by 2. Okay, so what is y of s? We have 5 minus 3 divided by 2. 2 divided by 2 is 1. So the coordinates of p that will make this requirement to be true, such that LP is equals to NP is equals to SP is 1 and 1. Okay, if you go ahead and calculate LP, NP, and SP, you will indeed find that they're equal when P has coordinates 1 and 1. That is 3.7. On the other hand, 3.8, calculate the size of LPS. I'm going to leave that one for you. Please let me know in the comment. What answer did you get for 3.7? Okay, and also one last thing, which question do you want me to do next? Let me know in the comments. I'm always reading the comment section, waiting for you guys to tell me which question I should do next. 4.6. The smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. Okay, so we have two possible values of k. Question 4.6 is not for the faint-hearted ones. I hope I don't turn out to be faint-hearted. So let's just go ahead and give this question a try. Okay, let's start with 4.1 and hear the stories. So given that D with coordinates p and minus 2 lies on the smaller circle, show that p is equals to 4. Okay, we're given the equation of the smaller circle. We have x squared plus y squared is equals to 20. So the value of x at point D is p. So if we substitute that, we're going to have p squared plus the value of y squared, which is minus 2. So minus 2 squared is equals to 20. P squared plus 4 is equals to 20. P squared is equals to 16. So P is equals to 4. Okay, P can be equals to 4 or minus 4. But as we can see, the x value of D should be positive. So that's why we're saying that P is equals to plus 4 and not minus 4. No trickery there whatsoever, just basic stuff. Let's take a look at 4.2. So 4.2, we are told that E with coordinates, let's take a look, coordinates 6 and 2. Okay, is the midpoint of DF. Determine the coordinates of F. So we have the coordinates of D, 4 and minus 2. The coordinates of E, and we are looking for the coordinates of F. E is the midpoint of DF. So x of E is equals to x of D plus x of F, everything divided by 2. X of E, that is 6. X of D is 4 plus x of F, everything divided by 2. If we cross multiply here, we get 4 plus x being equals to 12. So x is equals to 8. The x coordinate of F is 8, which makes sense. Even if we just use translation, it should be easy to see that the x coordinate of F should be F. Okay, and then the y coordinate of F should be equals to 6. Let me show you why. So the y coordinate of F is equals to, not of F, but of E. We are using E as a bait to find that of F, right? So the y coordinate of E is equals to the y coordinate of F plus the y coordinate of D, everything divided by 2. That of E is 2, that of F we're interested in, and that of D is minus 2, everything divided by 2. 2 multiplied by 2 is 4, so we have y of F minus 2 being equals to 4 y of f is indeed equals to 6. So the coordinates of f, we have 8 and 6. Okay, we're not experiencing any difficulty up to so far. We are moving at the speed of light. Okay, let's do 4.3. So 4.3, determine the equation of the common tangent df in the form y is equals to mx plus c. So y is equals to mx plus c. We want the equation of df. It's a straight line. We just need the gradient, substitute 1 point, and we are done. So let's find the gradient of fe. As all the coordinates are positive, they're easier to navigate. So y2 minus y1 divided by x2 minus x1, okay? So y2, the y coordinate of f, that is 6, minus the y coordinate of e, which is 2, divided by the x coordinate of f, 8, minus that of e, 6. 6 minus 2, that is 4. 8 minus 6 is 2. 4 divided by 2 is 2. So we have y being equals to 2x plus c. Let's substitute our point E. So if we sub E of coordinates 6 and 2, we're trying to find the value of c, okay? The coordinate of E, it gives us x value and its corresponding y value. So we're going to have 2 being equals to 2 multiplied by 6 plus c. It is easy to see that c is equals to 2 minus 12, which is equals to minus 10. So we have y is equals to 2x minus 10. Okay, it makes sense because when x is 0, y is equals to minus 10. And if you look at this line, that makes sense that the y-intercept x is equals to 0 can be minus 10. Okay, that is 4.3. Let's do 4.1. Let's hear the stories. Not 4.1, but 4.4. What am I saying? So in 4.4, we want to calculate the value of t and show all working. Okay, the value of t. Right, I see the idea we're supposed to use here. So df is a tangent to the smaller and the larger circle. That tells us that m of tangent multiplied by m of the radius. Gf is the radius, as you can see. M of gf should be equals to minus 1. Okay, the gradient of the tangent is 2, like we calculated above. So we have 2 multiplied by the gradient of gf, which is equals to minus 1. So the gradient of gf is equals to minus a half. Okay, how can we use that to find the coordinates of t? If we use gf to find that gradient of minus a half, the only unknown variable will be t. Let me show you what I'm talking about. So we can say that the gradient of gf is equals to y2 minus y1 divided by x2 minus x1. So we have minus 1 divided by 2 being equals to y2. Let's take f as our second point and g as our first point. If we do that, we're gonna have y2. So f as our second point, that's gonna be 6 minus y1, which is y of g, 0, divided by x2, 8 minus t. Okay, let's go ahead and cross multiply. I'm taking minus 1 divided by 2 as one number. So that is how I'm cross multiplying. When I do that, I'm going to have 6 being equals to minus 4 plus a half t. If I take minus 4 to the other side, a half t is equals to 10. So t is equals to 20. Okay, so there we go. We have the value of t. That is 4.4. 4.5. We are moving at the speed of light. We're really close to doing 4.6. Let's do 4.5 first. Determine the equation of the larger circle in the form ax squared plus by squared plus cx plus dy plus e is equals to 0. Okay, let's take a look at the information we have. We have G, which is the center, right? Coordinates T and 0. We know that T is 20, and then we have the Y coordinate, which is 0. What else do we have? We need the center and the radius at least to talk about the equation of a circle. So let's go ahead and see how we can conjure up the radius. So the radius, well, the radius squared, okay? Let's find the radius first, and then we're going to find the radius squared, okay? So this is going to be the square root of the distance formula. GF is the radius. So if we find the length of GF, then we have the radius, okay? So this is y2 minus y1 squared plus x2 minus x1 squared. So the radius is going to be equals to, I'm taking f as the second point. So y is 6 minus 0 squared plus 8 minus 20 squared, okay? So 6 squared, 36, and then minus 4 squared, 144, 144 plus 36, 180, 180. So I have square root of 180. Can I further simplify that? Let me put it in my calculator, okay? If I further simplify it, I get 6 square root of 5 as r. So that's my value of r. If we go ahead and find r squared is going to be 180 if r is equal to square root of 180, okay? So right, now we can have x minus the value of t, 20 squared, plus y minus the y coordinate of t, not the y coordinate of t, but the y coordinate of g, which is 0. So we have 0 squared being equals to radius squared, which is 180, okay? So now what we need to do here is just to solve all this and take 180 to the left-hand side. And then we're going to have the equation of our circle in the form we are required to have it in. That is going to be x squared, x multiplied by minus 20, that is minus 20. You multiply that by 2, you get minus 40x. Minus 20 multiplied by minus 20, that is plus 400. And then y squared, that is plus y squared. You take 180 to the other side, we have minus 180 being equals to 0. So x squared minus 40x. Let me look at the form so that I don't ruin it. Okay, after x squared, I shall follow with by squared. So x squared plus, what am I doing? Okay, let me look for that again. Where am I? Okay, yeah, so x squared plus y squared minus 40x, and then I need plus dy, okay? Which term has a coefficient of y? There's no term with a coefficient of y. So just to act cheeky, I'm going to say plus 0y, okay? And then 400 minus 180, is that plus 220? I think this is plus 220 is equals to 0. I'm supposed to write the equation of the circle in that form. Okay, that is 4.5. The interesting question, really, 4.6. Yeah, this is interesting. Not for the faint-hearted ones. I hope I don't fall under the domain of those with the faint of heart. The smaller circle must be translated k units along the x-axis to touch the larger circle internally. Calculate the possible values of a. So let's make sense of what we mean when we say they touch internally, okay? So let me do something. Let me trace this circle. Let me use the color red. You're gonna see why I'm doing that. Just stay with me. So I'm gonna trace this circle to the best of my ability, okay? What I want to do now is to duplicate it. You will see why I'm doing that. Duplicate, and then now let's leave it there. So not there, but yeah, okay? So when this circle is positioned like that, then the larger circle and the smaller circle are touching internally. That's what we mean. But that is not the only possible scenario. Let me show you the other possible scenario. So I have to duplicate it. When they touch like that, that is another possible scenario where our condition is satisfied. They are touching internally. So this is option 1 and this is option 2. If they're touching like that, we can say that they are touching internally. That's what we mean when we say they touch internally. Okay, so there's 2 ways of doing this. You can do it in an algebra intensive way, or you can just analyze the diagram like I'm about to do right now. Okay, so let me just enlarge this and show you something. Right, so I will erase all this so that I have somewhere to write, and I'll show you what I'm talking about. Okay, I don't want to erase the larger circle. What am I doing? The larger circle must be there. All I want to erase is all these words so that I can have space to write in. Right, so the center of the larger circle, we have 20 and 0. Okay, and then the center of the smaller circle, we have 0 and 0. But we have the radius of the smaller circle. The equation for the smaller circle is given by x squared plus y squared is equals to 20. So the radius is square root of 20. Okay, let's look at this point. Let's concentrate on this point. The x coordinate of that point is minus square root of 20. Okay, if the radius of the circle is square root of 20. We need to comprehend that, right? So that is step number 1. We need to be able to realize that. Another thing that we need to realize is, or that we need to figure out, is the coordinate, is the x coordinate of this point that we are interested in. How can we find the x coordinate of that point? Let me show you. We know that from this point to the center is 6 square root of 5, or let's just say square root of 180. We know that for sure. But from the center of the Cartesian plane to the center of the circle is 20 units. So if we want to find the x coordinate at this point that we're interested in, we can just say that, let me enlarge where I have to write now. We can just say that the x coordinate at that point, let's call it q, right? The value of q is equals to 20 minus square root of 180. We want to move this x coordinate at that point such that it is equals to 20 minus square root of 180, right? We can have an equation for that which we call q prime. So q prime is equals to minus square root of 20 plus k, right? So when q prime is equals to q, then we can determine the value of k such that the circles touch at this point. Okay, so that is 20 minus square root of 180 is equals to minus square root of 20 plus k. Okay, so k is equals to 20 minus square root of 180 plus square root of 20, right? So let me just go ahead and put that in my calculator. Let me see what I have. I'm getting k is equals to 20 minus 4 square root of 5, which in decimals is 11.05. So this is one possible value of k. Yeah, this is the same thing. Yeah, one possible value of k. Now let's look at the other case where they touch in at this point. Okay, so let's find the x value at this point. Let's call it z. So z will be equals to the x value at the center, the x value at t, which is 20 plus the radius of the larger circle. So 20 plus square root of 180. Okay, so we want these two circles to touch at the point 20 plus square root of 180. But z prime now will be equals to square root of 20 plus k and not minus square root of 20 plus k. Okay, so if we equate these two, we get square root of 20 plus k is equals to 20 plus square root of 180. So k is equals to 20 plus square root of 180 minus square root of 20. So k is equals to 20 plus square root of 180 minus square root of 20. This is equals to 20 plus 4 square root of 5, of which is 28.94. So these are two possible values of k according to me. Let me know what you think in the comments. I'm quite sure there must be somebody who used the same method I'm using. Just let me know in the comments. Which video do you want me to do next? We have done question 1, 2, 3, 4. Should we just do 5, 6 until 10, or should we? Let me know in the comments. The only questions I'm going to answer is 5.2.1, 5.3.2, and lastly 5.4, because I think they're the most difficult questions. So let's take a look at 5.2.1. We have cos of x to the power 4 plus sine of x to the power 2 multiplied by cos of x to the power 2. Everything divided by 1 plus sine of x. This is said to be equals to 1 minus sine of x. So we're supposed to show that the left-hand side is equals to the right-hand side. If we decide to take the left-hand side, we're going to have, so let me show you something. What I'm realizing first is that on the numerator, I have cos of x and cos of x, which I can take as a common factor, right? In fact, I can take cos of x to the power 2 as a common factor in the numerator. If I do that, I'm going to have cos of x to the power 2, and then I'm going to be left with cos of x to the power 2, because cos of x to the power 2 multiplied by cos of x to the power 2 will give us cos of x, everything to the power 4, right? And then plus sine x squared. Okay, we're dividing everything by 1 plus sine of x. So cos of square x and sine of x squared will give us 1. That is a identity. Okay, so we're going to be left with cos squared x divided by 1 plus sine of x. But we know that cos of squared x plus sine of squared x is equals to 1. So cos of x squared is just 1 minus sine of x squared, okay, divided by 1 plus sine of x. 1 minus sine of x squared is a difference of 2 squares. So we can expand this and get 1 minus sine of x multiplied by 1 plus sine of x. Everything divided by 1 plus sine of x. So 1 plus sine of x on the denominator will cancel out with 1 plus sine of x on the numerator. We are only left with 1 minus sine of x. So as you can clearly see, the left-hand side is equals to the right-hand side. They are both equals to 1 minus sine of x. That is 5.2.1. Let's take a look at 5.3.2. So in 5.3.2, we are supposed to find the general solution of sine 48 multiplied by cos of x minus cos of 48 multiplied by sine of x being equals to cos of 2x. Obviously, we can narrow this down. We know that we have an identity that can help us with that, right? That will just be equals to sine of 48 minus x. We know that for sure. If you expand the sine of 48 minus x, you get this. So they are equals to each other. Sine of 48 minus x will be equals to cos of 2x. So we're going to have sine of 48 minus x being equals to. We can write cos of 2x as sine 90 minus 2x. So if sine of 48 minus x is equals to sine of 90 minus 2x, then 48 minus x shall be equals to 90 minus 2x. So we're going to have 48 minus x being equals to 90 minus 2x. If we take minus 2x to the left hand side, we're going to have x. 90 minus 48 is 42. So x is equals to 42 plus k multiplied by 360, because it is a general solution. We are not given a certain interval we are supposed to respect. So that is 5.3.2. The last question that we're going to answer is 5.4. So in 5.4, we're supposed to write sine 3x plus sine x divided by cos 2x plus 1 as a single trigonometric ratio. So with only sine, cos, or tan. That's what we want. Okay? So take a look at this. We have sine of 3x. We don't have any identity that we can use on sine of 3x. So it's better if we break it apart into sine of 2x plus x. If we do that, we're going to have sine of 2x plus x plus sine of x divided by cos of 2x. Let's just leave cos of 2x as it is for this step. Let's focus on the numerator. So we're going to have cos of 2x plus 1. If we expand sine of 2x plus 1, this will give us sine of 2x cos x, okay, plus sine of x cos 2x plus sine of x. We just expanded sine of 2x plus x. Everything divided by cos of 2x. So for this step, let's write cos of 2x as it is again. So we're going to have cos of 2x plus 1. Now we're going to further simplify our numerator. Okay, we have sine of 2x, which we can write it in another form. The same is true with cos 2x, right? Cos 2x is equals to a couple of things. So we can also change cos of 2x. Right, we're going to change sine of 2x to 2 sine, so 2 sine x cos of x. So that is sine of 2x. We are still multiplying with cos x. So we have cos x right here. Plus sine of x. Now we're going to change cos 2x to 2 cos square x minus 1 plus sine of x. Everything divided by. So now we are going to change the denominator. I'm going to show you how. Cos of 2x is also equals to 2 cos of x everything squared minus 1. Okay, and then we have this plus 1 right here. Obviously, minus 1 plus 1, that will give us 0. On the numerator, we're going to have 2 sine of x cos square x plus 2 cos square x sine of x. And then we're going to have sine of x multiplied by minus 1. So that will be minus sine of x plus sine of x. Clearly, minus sine of x plus sine of x will give us 0. So we are dividing by 2 cos of x everything squared. Okay, let's take a look at the numerator. On the numerator, we have 2 sine x cos of x everything squared plus 2 sine x cos of x everything squared. So this is just 4 sine of x cos, let me start with cos instead. This is 4 cos of x everything squared multiplied by sine of x divided by 2 cos of x everything squared. Okay, 4 divided by 2, that is 2 cos of x squared will cancel out with that term on the numerator. So we are only left with 2 sine of x, and this is the expression we are given as a single trigonometric ratio. Write down the period of f. Okay, so let's take a look. We have f of x, which is equals to 2 sine of 2x. So what will be the period of f of x? Let's go ahead and find out. The period is given by 360 divided by b. B being this value that we have right here, the coefficient of x. In our case, b is equals to 2. So we're going to have 360 divided by 2, which is equals to 180 degrees. So this is the period of f. Okay, if you decide to calculate instead. But the question says we must just write it down. Even if you look at your graph, you can see that the graph of f of x, it completes itself between 0 and 180. So the period is 180 degrees. Let's move to 6.2. 6.2, determine the range of g in the interval x, an element of 0 to 180 degrees. G of x is equals to minus cos of x plus 45 degrees. It's very simple for you to make this mistake. You can say that the range of g, we have minus 1 to positive 1. But this is actually not true. This is not the case. Let me show you why. Positive 1 is correct, but minus 1 is not correct. Let's look at g of x. So this is g of x. Okay, if you look at the lowest value, g of x doesn't touch minus 1. So if you write your range in this way, it will be incorrect. You actually have to calculate that value. And as you can see from the sketch, it is clearly not equals to minus 1. So let's go ahead and find that value. So we're going to have g of 0 being equals to minus cos of 0 plus 45. So what is cos of 45? That is 1 divided by square root of 2. So the range of g of x is actually minus 1 divided by square root of 2 up to positive 1. Okay, so this is the actual range of g of x and not minus 1 to positive 1. Yeah, this is because of the restriction we have. We are given an interval we are interested in. Okay, generally it will be minus 1 to positive 1, but here it is a bit different because of the restriction. Just like in question 4 of mathematics paper 1. Let's do 6.3, 6.3.1. So determine the values of x in the interval x an element of 0 to 180, for which f of x, let's take a look at that. F of x multiplied by g of x is greater than 0. So we want f of x multiplied by g of x to be greater than 0. For this to be true, it's either f of x is positive while g of x is also positive, or the other way around, f of x is negative while g of x is also negative. Yeah, if that is the case, then f of x multiplied by g of x will be greater than 0. So let's go to our graph and find those points. From 0 to 45 degrees, from 0 to 45 degrees, g of x is negative and f of x is positive. So 0 to 45 cannot be part of our solution. But take a look at this. From 45 degrees to 90 degrees. So from 45 to 90 degrees, g of x is positive and f of x is positive. But after 90 degrees, you can see that f of x starts being negative. okay, up until 180 degrees. So we can clearly see that the value of x for which f of x multiplied by g of x is greater than 0 is when x is between 45 degrees and 90 degrees. If you look at your graph, that is easy to see. G of x is positive here. G of x is positive. And the same is true with f of x. F of x is also positive up until x is equals to 90, where f of x starts being negative. Let's do 6.3.2. So that is 6.3.1. 6.3.2, we're looking for the values of x for which f of x is less or equals to. We're looking for the values of x for which f of x plus 1 is less or equals to 0. So we have f of x plus 1 being less or equals to 0. So f of x, if we make it the subject of the formula, should be less or equals to minus 1. Okay, so let's go ahead to our graph and do the analysis. We are given a point A of coordinates 105 degrees for the x value and minus 1 for the y value. Okay, and then as the value of x increases, f of x is negative. And as the values of x increases, f of x is less than minus 1 up until this point. So we're interested on the x value at that point where f of x is no longer less than minus 1. Okay, so we know that our answer should start at x is equals to 105, because when x is equals to 105 degrees, f of x is equals to minus 1. And then we need another x value for which f of x will be equals to minus 1. This x value right here. Our solution will be between those two values. Okay, if you play around with your x values, if you say 105 plus 20 plus 30, you end up figuring out that x, when x is equals to 165 degrees, f of x will be equals to minus 1. So our solution, we need x to be between 105 degrees and 165 degrees. This is our solution. When x is between those two numbers, we can clearly see that f of x is less than minus 1, like we are required to do. Okay, that is 6.3.2. Let's do 6.4. 6.4, another graph P is defined as P of x is equals to minus f of x. D with coordinates k and minus 1 lies on P. Determine the values of k in the interval x is an element of 0 degrees to 180 degrees. So P of x is equals to minus f of x. So P of x is equals to minus, what is f of x? F of x is 2 sine of 2x. So P of x is equals to minus 2 sine of 2x. This is P of x. And then on P of x, we have a point D of coordinates k and minus 1. We're supposed to find the value of k. So we will simply substitute into P of x. If we do that, the y value is minus 1 minus 2 sine of 2k. So if we divide both sides by minus 2, we're going to get sine of 2k being equals to 1 divided by 2. So 2k is equals to sine inverse of 1 divided by 2. So what is sine inverse of 1 divided by 2? That is 30 degrees. Okay, so k should be equals to 15 degrees. 6.4. The last question, 6.5. The graph of h is obtained when g is translated 45 degrees to the left. Translation to the left is plus, right? So when it is translated 45 degrees to the left, that is x plus 45 degrees. Okay, if it was to the right, it would be x minus 45 degrees. Determine the equation of h. Write down your answer in its simplest form. So g of x is equals to minus cos of x plus 45 degrees. If we want to translate it 45 units to the left, then instead of having g of x, we're going to have g of x plus 45. That will shift it 45 units to the left. So minus cos of x plus 45 plus 45. So g of x plus 45 will be equals to minus cos of 90 plus x. They say we must write it down in its simplest form. Can we change cos of 90 plus x into something else? I think we can. Let me know in the comment section how we can further simplify minus cos of 90 plus x. Determine the length of SK in terms of P, Q, and alpha. Let's go to our sketch and identify SK. We have SK right here. We're supposed to find the length in SK of SK in terms of alpha, which is this angle right here, P, which is this side ST, and Q. What is this Q? Let's go ahead and read our question statement and figure it out. So we are told that in the diagram, ST and K lie in the same horizontal plane. RS is a vertical tower. The angle of depression from R to K is beta. Angle TSK is equals to alpha. TS is equals to P meters. And the area of triangle STK is Q meters squared. Okay, so we have the area of triangle STK, which is equals to Q. So somehow we have to use the area, because how else can you get Q if you're not using the area? Okay, so let's see if we can use the area of triangle STK to find SK in terms of P, Q, and A. If we go ahead and try that, we're going to have the area of triangle STK being equals to a half. We need two sides and one angle between the two sides. We have ST, right? So multiplied by ST multiplied by SK, sine of the angle in between the two sides, which is alpha. So sine of alpha. So what is the area of triangle STK? We know it to be Q. A half. What is ST? ST is P. SK is what you are interested in, sine of alpha. It should be easy to see that SK will be equals to Q divided by 1 divided by 2 P sine of alpha. This is obviously equals to 2Q divided by P sine of alpha. So this is SK in terms of Q, P, and alpha. 7.1. Let's see if we can do 7.2. So 7.2, we're supposed to show that RS is equals to 2Q tan of beta divided by P sine of alpha. So let's go ahead and take a look at our triangle. This side in dotted lines is parallel as K. Why are we saying that? Beta is the angle of depression. So this angle right here is beta. Okay, we want to find RS in terms of Q, P, alpha, and beta. If you look at triangle RSK, we have a right angled triangle. So we can use tan, cos, and sine. We can use our trig ratio. In our solution, we have tan of beta. Okay, so it makes sense for us to start by trying tan and see if we get to the correct answer. So we're going to have tan theta being equals to the opposite divided by the adjacent. This is in triangle RSK. Okay, so we're going to have tan of beta being equals to the opposite, which is RS. So tan of beta is equals to RS divided by the adjacent. The adjacent is SK. Okay, so we have SK. So If we cross multiply here, we're going to get RS being equals to SK multiplied by tan of beta. But what is SK? We determined the SK in 7.1. SK is equals to 2Q divided by P sine of alpha. So if we replace SK with that, we are going to have 2Q divided by P sine of alpha multiplied by tan of beta. So this is just equals to 2Q tan of beta divided by P sine of alpha. Exactly what we are required to show. That is 7.2. Let's take a look at 7.3. Calculate the size of angle alpha if angle alpha is less than 90 degrees. Okay, we are told that RS is equals to 70 meters, P is 80 meters, Q is 2,500 meters squared, and beta is 42. So let's use the equation in 7.2, because in that equation we have RS being equals to 2Q tan of beta divided by P sine of alpha. In the information we have, we are given the length of RS, we are given Q, the area, we are given the angle beta, and P, right? P is said to be equals to 80 meters, and we are looking for alpha. So if we use this equation, we are only going to have one unknown variable, which is what we're interested in. Okay, so if we go ahead and cross multiply and divide, making sin alpha the subject of the formula, we're going to have sine of alpha being equals to 2Q tan of beta divided by P multiplied by RS. Okay, so we're going to have alpha being equals to sin arc of, so let's go ahead and substitute. We have 2 multiplied by Q. Q is 2,500 multiplied by tan of beta. Beta is 42, okay? And then we're dividing everything by P multiplied by RS. P is said to be equals to 80 meters, and RS is equals to 70 meters. So it is just a matter of putting that in your calculator. And when I do that, I'm getting 53.51 degrees. So that is the size of angle alpha if alpha is less than 90 degrees. In the diagram, O is the center of the circle and ABCD is a cyclic quadrilateral. OB and OD are drawn. If O1 is equals to 4x plus 100 and C is equals to x plus 34, calculate, given reasons, the size of x. So I'm given C, it is equals to x plus 34. I have O1, okay? But C plus A should give me 180, as ABCD is a cyclic quadrilateral. So if I can find A in terms of x, then I can say A plus C is equals to 180. But I can do that. I can find A in terms of x. I know fully well that O1 should be equals to 2 multiplied by A. Angle at the center, twice at the circumference. Okay. So O1 is 4x plus 100, and it is equals to 2 multiplied by A. If we divide both sides by 2, we're going to get A being equals to 2x plus 50. So this is A. Okay. So what am I proposing? I'm proposing that A plus C should give me 180 degrees. Okay. The opposite angles of a cyclic quad are supplementary. So in place of A, I have 2x plus 50. In place of C, I have x plus 34 being equals to 180 degrees. So 2x plus x, that is 3x. 50 plus 34, that is 84. This is equals to 180. So 3x is equals to 180 minus 84. I think it should be 96. But I'm not going to take any chances. I'm going to put it in my calculator and see what I get. Yeah, it is 96. And then 96 divided by 3, that is 32. So I'm getting 32 is equals to, x is equals to 32 degrees. That is 8.2. Let's see if we can answer 8.3. So 8.3, right. In the diagram, O is the center of the larger circle. Okay, we have O as the center of the larger circle. OB is the diameter of the smaller circle. Chord AB of the larger circle intersects the smaller circle at M and B. Okay, so I'm told that AB is a diameter. As soon as I hear AB is a diameter, I know that M is 90, right? A diameter subtends 90 as the circumference. Let's hear the stories. We want to find 8.3.1, write down the size of angle OMB. Like I've said, angle OMB is equals to 90 degrees. That is because it is subtended by a diameter, okay, at the circumference of a circle. So it should be 90 degrees. The question that follows, 8.3.2, if AB is equals to square root of 300. So this entire AB is square root of 300. And OM is 5 units. So OM is 5 units. Calculate, given reasons, the length of OB. Okay, we want to find OB. It seems like we can use theorem of Pythagoras here because we have an angle of 90 degrees. But can we find the length of MB? Because what we are looking for now is the length of MB. If we have the length of MB, then we can find OB using theorem of Pythagoras. Let me show you how we can find the length of MB. MB is equals to AB divided by 2. That is because if OMB is indeed 90, then that means OM bisects AB. Theorem 1. Okay, so we know that MB is equals to square root of 300 divided by 2. If I go ahead and use theorem of Pythagoras, it seems quite fishy. I don't know why it is 4 marks because it is pretty much straight forward. Okay, so if I go ahead and use theorem of Pythagoras, I'm going to have OB squared being equals to MB squared plus OM squared. So OB squared will be equals to MB. So MB square root of 300 divided by 2 squared plus OM. OM is 5 units. So I have 5 squared. Okay. So OB squared will be equals to, let me put that in my calculator. So square root of 300 divided by 2 squared plus 5 squared, that is 100. So OB is equals to 10. Okay, if we take square roots on both sides, we will get OB is equals to 10. So yeah, there we go. That is 8.3.2. A, B, C, D is a parallelogram with AB being equals to 14 units. AD is produced to E such that AD is to DE is equals to 4 is to 3. So AD is to DE is 4 is to 3. It is not necessarily 4 and it is not necessarily 3. But when we divide them, we will get 4 divided by 3. Okay? And then EB intersects DC in F, and then EB is equals to 21 units. Right, stories. Let's look at the first question, 9.1. Calculate with the reasons the length of FB. So we want to find the length of FB. We know that EB is equals to 21, okay? So EB divided by FB should be equals to EA divided by DA. Why am I saying that? DF is parallel AB. So the two sides are divided proportionally. Okay, so what is EB? EB is 21, like we have in the information. FB is what we're interested in. This will be equals to EA. EA will be 7x divided by DA, which is 4x. We can see x and x cancels out. If we cross multiply, we get 7FB being equals to 21 multiplied by 4. So we have 7FB being equals to 84. If we divide both sides by 7, we get FB is equals to 12 units. So there we go. We have the length of FB. Let's get to 9.2 and see if we can prove, given reasons, that triangle EDF is similar to triangle EAB. Okay, the way these triangles are named, the angles, they follow a certain order. Let me show you what I'm talking about. We have triangle EDF and triangle EAB. Okay, angle E on the two triangles should be equals to each other. Okay, so let's take a look at triangle EDF and triangle EAB. We can see that angle E is a common angle. Okay, so we can say that E is equals to E. This is a common angle of the two triangles. Let's go to the angle that follows. Angle D in triangle EDF. So this angle D in triangle EDF should be equals to angle A in triangle EAB. Okay, so we have angle A being equals to angle D. Which reason can we use? We can see that the line DF is parallel the line AB. So angle A is corresponding angle D. Okay, so we're going to say that angle D is equals to angle A. This is corresponding angles. So we have corresponding angles because DF is parallel AB. If we've proved that two angles are equals to each other in two triangles, then the third angles are also going to be equals to each other because of the sum of angles of a triangle. Okay, so this angle F should be equals to angle B. Okay, so we have F being equals to B. We can use third angle of triangle, or we can also use corresponding angles. So now we can go ahead and conclude and say that triangle EDF is similar to triangle EAD. Angle, angle, angle. That is 9.2. 9.3. Calculate with reasons the length of FC. So let me just go ahead and erase this. I want to find the length of FC. Okay, FC has nothing to do with our triangle, with our two triangles, right? But DF has something to do with our triangles. DF. If we can find DF, then we're going to have FC, because AB should be equals to DC if ABCD is a parallelogram. So how can we find DF? Let me show you what we're going to do. We know that this is 14. We know that we have 3x and 4x. We want to find DF. Okay, so on the smaller triangle, ED divided by DF should be equals to EA divided by AB in the bigger triangle. Okay, what reason can we give? We can say that triangle EDF is similar to triangle EAB and not EAD. Okay, so there we go. ED is 3x. DF is what we are interested in. This is equals to EA, which is 7x. AB is 14. Okay, x and x can cancel out. If we cross multiply, we have 14 multiplied by 3, which is 42. So 7DF is equals to 42. 42 divided by 7 is 6. So DF is equals to 6. Okay. But we know that DC is equals to AB, which is equals to 14, because ABCD is a parallelogram. So FC will be equals to 14 minus 6, which is equals to 8. 14 minus 6 is 8. So FC is 8 units. And just like that, we have the length of FC. There's no values in this question. We're just writing angles in terms of one another. Let me show you what I'm talking about. So the first question, 10.1, we are supposed to prove, given reasons, that S3 is equals to S4. Okay? But before we can attempt answering this question, let's go through the question statement so that we can extract our keywords that are going to help us in answering the question. Okay, so in the diagram, PQRS is a cyclic quad. So now I know that I have a cyclic quad. So let me write that down, as it will help me in answering the questions. Okay, PQ is equals to PR. That is also important. PQ is equals to PR. Yeah, equal chords subtend equal angles at the circumference of the circle. Right. The tangents to the circle through P and R meet Q as produced at A. Okay, we have some tangents, AR and AP. So let's go ahead and write that. We have tangent. We know that we have the tan chord theorem. So it is important for us to know the tangent. Okay. What else do we have apart from the tangent? Okay, I think that's what we have up to so far. I cannot think about anything else. Yeah, I cannot extract anything else from the question statement. So let's go ahead and give it a try and see what happens. Okay, I had a lot of people saying that they couldn't even answer one question from question 10. I wonder why that is the case, but I hope I'm going to be able to get at least one correct. Let's see. So S3 is equals to S4. Let's look at our first keyword. Our first keyword is cyclic quad. So let's see if we can make sense of that. Okay. We have S3 right here. So if SRQP is a cyclic quad, then S3 should be equals to angle Q. Right, so let me just write that down as part of my solution. It is something I'm realizing, so I need to write it down. So 10.1, I have S3 being equals to Q. As S3, it is an exterior angle of a cyclic quad, okay? What else am I realizing? Let me move to the following keyword. The following keyword is that PQ is equals to PR. Let's see what the consequence of that is going to be. PQ is equals to PR. So PQ subtends angle R3 and PR subtends angle Q. So what does that tell us? Okay, that will tell us that Q is equals to R3. That is because PQ is equals to PR. Okay, but if S3 is equals to Q and Q is equals to S3, and Q is equals to R3, I mean, then S3 is equals to R3 because they are both equals to Q. Okay, I think we can say that. Okay, let's pay our attention to the chords before we can move on to any other idea. Okay, so we say that R3 is subtended by PQ. But if you pay close attention, you should be able to see that PQ is also subtending S4. Okay, so what are we saying? We're saying that S4 is equals to R3 because they are both subtended by our chord PQ. Okay, I think the right reason is that they are in the same arc. That is the right reason. So take a look at this. S4 is equals to R3. S3 is equals to R3. So S3 should be equals to S4 as they are both equals to R3. Okay? If x is equals to 2 and y is equals to 2, then x is equals to y because they are both equals to 2. Okay? So that is 10.1. Let's move forward and do 10.2. Let's hear the stories. So 10.2, let's prove that SMRC is a cyclic quad. Okay, let me go ahead and highlight SMRC. So I have SMRC. Let's make sense of this question, okay? If SMRC is a cyclic quad, then this angle C1 should be equals to the angle M1, okay? Exterior is equals to interior opposite, right? And then S1, so this angle S1 should be equals to angle R1 plus angle R2, okay? I'm realizing something. I'm realizing that S4 is equals to S1. And in the question above, we've talked about S4. So why not try prove that S1 is equals to R1 plus R2? Because we can just carry on from what we've been doing from 10.1. We don't have to necessarily start anything new, okay? So I'm going to start by saying S1 is equals to S4. Vertical opposite, okay? Let me check if they are indeed vertically opposite. So I have this line and I have this line, okay? S1 and S4 are indeed vertically opposite, okay? And then let's not forget, in the question above, we said that S3 is equals to S4. And now we are saying that S1 is equals to S4. So what does that mean? It means that S1 is equals to S3 as they are both equals to S4. Okay? Right, now we can see what is happening here. Let's not forget, let me remind you of something. We said that S3, this angle right here, is equals to Q1 plus Q2. That is because SRQP is a cyclic quad, okay? So S3 is equals to angle Q, exterior angle of a cyclic quad. But I want to show you something interesting. Look at R1 plus R2. R1 plus R2 should be equals to angle Q because of the turn chord theorem, okay? So R1 plus R2 are equals to angle Q because of the turn chord theorem. You will see where I'm going with this. You will see when I connect the dots at the end. R1 plus R2 is equals to Q. Can you see now? S3 is equals to R1 plus R2 as they are both equals to Q. Okay, but what we are required to prove is that S1 is equals to R1 plus R2. But we have proved that S1 is equals to S3. So now we're going to say that S1 is equals to R1 plus R2. This is because both of them are equals to S3. Like I said at the start of the question, we are writing angles in terms of each other. There's no value in this question, okay? So let me just erase for the sake of clarity. We have proved that S1 is equals to R1 plus R2. So SCRM is indeed a cyclic quad because, so what are we saying? We're saying that therefore SMRC is a cyclic quad because S1 is equals to R1 plus R2, okay? the exterior angle is equals to opposite interior. That is 10.2. Okay, and the interesting question 10.3, right? If you thought 10.2 is difficult, then what about 10.3? Let's take a look at 10.3. So in 10.3 we are told that RP is the tangent to the circle passing through P, S, and A at P. Okay, so RP is the tangent of the circle passing PSA. So we have some circle right here, and we are supposed to prove that RP is a tangent, right? So if RP is a tangent, let me show you something. This is a chord on the circle, right? Let me use a different color. This is a chord on the circle. If RP is a tangent, then P2 should be equal to the angle subtended by that chord, which is A2. So if we can prove that P2 is equal to A2, then we've proved that RP is a tangent to the circle passing through P, S, and A at P. Okay, so let's see how we can do that. Let me erase all this for the sake of clarity and zoom in. Right. Okay, so let me see. Let's take a look at M3. Okay, M3 is the exterior angle of triangle MAP, right? MAP. So we can say that M3 is equals to A2 plus P1 plus P2. This angle here, A2, and P1 plus T2 are equals to M3, right? An exterior angle of a triangle is equals to the sum of opposite interior. Let's not forget that. So we have M3 being equals to A2 plus P1 plus P2. Okay, we can also use M3 again. We can say that M3, okay, let me see. M3 is equals to, let's see, S4 plus P2. Let me erase again for the sake of clarity. So we can say that M3, this angle right here, is equals to S4 plus P2. So what are we saying? We're saying that M3 is equals to S4 plus P2, so P2 plus S4. Okay, for the same reason, exterior angle of a triangle. It's just that now we are concentrating on a different angle. Okay, right. Let's equate these two equations. I want you to realize something. If we equate these two, we're gonna have A2 plus P1 plus P2 being equals to P2 plus S4. Okay, so we want to prove that A2 is equals to P2. If we can find a way to show that P1 plus P2 are equals to S4, then A2 will be equals to P2. So that's what we essentially want to prove, right? So let's go ahead and try doing that. We already know that S4 is equals to S1, right? They are vertically opposite. But if you look at S1 from what we have proved in 10.2 should be equals to R1 plus R2, right? Exterior angle of a cyclic quad is equals to interior opposite. So S1 is equals to R1 plus R2. Exterior angle of a cyclic quad, so on and so on. Because of the turn chord theorem, R1, let's take a look at R1. R1 is equals to P2 because of the turn chord theorem, right? And then still, because of the turn chord theorem, P1 is equals to R2. So instead of saying S1 is equals to R1 plus R2, we can say that S1 is equals to P1 plus P2, because R1 plus R2 is just equals to P1 plus P2 using the turn chord theorem. So we have S1 being equals to P1 plus P2. but S1 is S4. So S4 is equals to P1 plus P2. This is because of the turn-chord theorem, okay? So let's come back to this equation that you're interested in. We can replace S4 with P1 plus P2 because we have showed that S1 is equals to R1 plus R2, which is equals to P1 plus P2, and S4 is equals to S1, which is equals to P1 plus P2, okay? So we're going to have A2 plus P1 plus P2 being equals to P2 plus, in place of S4, we have plus 1 plus P2. So take a look at this. P1 plus P2, P1 plus P2. So A2 is equals to P2 because A2 plus P1 plus P2 is equals to P2 plus P1 plus P2. So A2 should be equals to P2 because of that. And this is the most difficult Euclidean geometry equation I've ever solved.
An annual sports festival is held over a period of 11 days. A tuck shop sells hot drinks at this festival. On each of the first 10 days, the owner of the tuck shop recorded the temperature at 1 p.m. and the number of cups of hot drinks sold. This information is presented in the table and scatter plot below. We have the temperature for the 10 days from 14, 24, 26, so on until 19 on the last day. And then the number of hot drinks, 410, 258 to 280 on the last day. And then we have our scatter plot. And then 1.1 says describe the data. So let's look at our scatter plot. On the x-axis, we have the temperature. And then on the y-axis, we have the number of hot drinks sold, right? Now, let's look at our data. Let's ignore this point here because it's very far away from all the other points. Let's stick to these points that are on a linear, so to say. So, there we go. Yeah, we have something like that, right? So it's easy to see now that when the temperature increases, the number of hot drinks sold is going down, right? Apart from this point, which is a bit deviating, and this one, which is totally an outlier. But then the general trend, when the temperature is increasing, the number of hot drinks sold is decreasing, which makes perfect sense. You would expect people to buy less hot drinks when the temperature is increasing, right? So here, the trend of the data, when the temperature increases, the number of hot drinks sold or bought, right, decreases. And then 1.2 says, determine the equation of the least squares regression for the line. So we want to find the equation for the least squares regression line for the data we have, right? So it's very difficult to do it manually. So we're going to resort to using a calculator. So I have two calculators with me here. The one which you can see is on my phone, right? And then the other calculator which you cannot see is the normal one. So what you want to do when you want to find the least squares regression line, the first thing you press is mode, right? So I just pressed mode on the calculator, you can see right now, and then that menu pops up. But then on the normal Casio calculator, when you press mode, you're gonna have options with numbers on them, right? It's usually 1, 2, 3, and you want to click on the number that has stat, right? It's usually 2, but not always. So I'm clicking 2 on the calculator, on the normal calculator, and here on the phone I will click on the option that says stat, right? When you click that on the normal calculator, you're gonna have options from I think 1 to 8. You want to click on the option that has a plus bx, right? Because that's the general formula for the least squares regression line. On this scientific calculator that I have, it's option number 2, right? So I'm clicking number 2. But then on the calculator that you can see with your eyes here, you can see that
a plus bx is option number 5, right? So I'm gonna click 5. After I click 5, the screens are the same. You have x and y, so you're supposed to put the values for the x and then the values from the y. So on the calculator that you can see, let me put the values. So we have 14, you press equals to 24, you press equals to 26, 18, 20, 28, 22, 17, 12, and 19. And then on the y values, we have 410, and then we have 258, 192, we have 324, not 321, 324, we have 328, 156, 156, 280, 384, and 230, right? And then we have 280. So we have entered all our numbers, right? Let me do the same thing real quick on the calculator. You can see. So after you've pressed that, after you've entered your data, you can press AC, right? So I'm gonna press AC here, and then we go back to the normal screen. I'm also pressing AC on the other calculator. So now what you want to press, shift 1, right? So let me press shift 1. When I press shift 1, this menu pops up. So we have a few options here. I'm going to press option 3. It says regression calculate, right? And then on the normal calculator, we just have rig for regression, right? So on the normal calculator, you're gonna press 5. So let me press regression calculate here, and then this calculator that I have will give you the value of a and the value of b, right? And then on the normal calculator, you're gonna have numbers from 1 to 5, right? 1 being a, and then 2 being b. But then that's not always the case. You just have to press the number for the letter you're looking for. So here on the screen, you can see that a is 488,3026, and then b is minus 10.2051. And then if I press number 1 on the normal calculator, I get an a value of 488.30.25641, right? They seem to be the same. And then after you've done that, you can press AC again, press shift, press 1 again, press regression, and then press the number that has b, and then b is also minus 10.2051. Now we have a is equals to 488.3, right? And then we have b being equals to minus 10.21, right? So our equation will be y is equals to minus 10.21x plus 488.3, and that's our equation for the least squares regression line for the data. And then 1.3 says that the owner observed that he had used 1 liter of milk for every 8 cups. So now let's say 8 cups is equals to 1 liter of milk, right? And then it goes on to say that if the temperature at 1 p.m. on the 11th day was expected to be 17 degrees Celsius, predict the number of 1 liter boxes of milk the owner should buy for the 11th day. So we are given the temperature on the day, right? With the temperature on the day, we can find the number of cups sold, right? The number of hot drinks. And from the number of hot drinks sold, we can then find the liters of milk needed. So now we're going to say y is equals to minus 10.21. In place of x, we put in 17, right? Because our x is the temperature, plus 488.3. And that is giving me 314.73 cups sold, right? So now I can convert these cups to liters, because we know that 8 cups is 1 liter. So we're gonna say that the boxes of milk will be equals to the number of cups divided by 8. So we have 314.73 divided by 8, which is equals to 39.34, right? So yeah, it seems like we're going to need 40 boxes of milk, right? You cannot have a third of a box, so we're gonna need 40 boxes of milk. And then 1.4 says let's identify an outlier in the data. Let's go to our scatter plot. You can see clearly this point here that I've circled, that is very far away from the other points. And then apart from that, it sort of goes against common sense, right? Because the temperature is really low here, but the number of hot drinks that are sold are also very low, which doesn't make sense. Learners from various schools wrote an aptitude test in order to qualify for a bursary. Their marks as a percentage are represented in the ogive cumulative frequency graph below. And then we're given our ogive there with the cumulative frequency on the x, on the y, and the marks on the x as a percentage. 2.1.1 says how many learners wrote the test. So the number of learners that wrote the test is the total frequency, right? Or the cumulative frequency, so to say. So we can see from this ogive that the cumulative frequency is at between 180 and 70, right? You can see that this is where our graph ends here, and then if you extrapolate from there, you will end up at 175. So the number of learners who wrote the test is 175. So here 2.1.1 we have 175 is the cumulative frequency. 2.1.2 says write down the modal class of the data. Now the question is, what is the modal class of the data? We know the mode when we have ungrouped data, right? The mode is that number that appears the most, right? So the modal class when we have grouped data is the class that has the highest frequency, right? Because we assume that the class that has the highest frequency will have a lot of numbers that are the same, thus our mode will lie there. So we call it the modal class. So let's come to our ogive and look for a class with the highest frequency. So people between 0 and 10, I think it's only 4 people who got between 0 and 10, and then between 10 and 20, I think it's about 6 people. It's about 2 people actually, or something like that. But then you can see that we're basically looking at the distance between the two dots, right? So the interval, that is the largest distance between the two dots, then that will be our modal class. And then you can see fully well here that it seems like from 40 to 50, there's actually a big gap, right? Because if you want to find the students who got between 40% and 50, you're gonna say, you're gonna come from this point, and then the cumulative frequency is 100 there, come from this point, the cumulative frequency is 60, so you're gonna say 100 minus 60 is equals to 40, right? So people who got between 40 and 50 is 40 people, right? And then I think the next largest is 50 to 60, which is about 30 people. But then we're looking for the modal class, the class with the highest frequency, right? Clearly is 40 to 50. right? And then even if you write it like 40 and then you include 40 and exclude 50, it's still fine. So 40 to 50 is our model class. Why are we saying it's our model class? It has the highest frequency. How do we determine whether it has the highest frequency? We're subtracting the cumulative frequency from where it starts to the cumulative frequency where it ends. Let's go to 2.1.3. 2.1.3 says the minimum mark to qualify for a bursary is 75%. How many learners qualified for a bursary? So let's come to our x-axis here and look for 75%, right? So 75% will lie midway between 70 and 80, and then let's take the line up until we hit our ogive. So we are somewhere here, right? So everyone going there got the bursary, right? And then everyone going down didn't get the bursary. So let's find the number of learners who are up there who are going to get the bursary. We already know that the cumulative frequency is 175, right? And then let's subtract the number of people who didn't get the bursary so that we can know the number of people who actually got the bursary. At this point here, going down, no one got the bursary, right? So at approximately 160. So we have 175 minus 160. This will give you 15. So only 15 learners got 75% and above. So they are going to get the bursary, but everybody else didn't. So here we're gonna have how many learners qualified for the bursary? 15 learners qualified for the bursary. But you don't just write 15, you have to show that you are saying 175 minus 160 is equals to 15, and then you'll be fine. Let's move to 2.2. 2.2 says the table below shows the marks that 15 learners from one particular school obtained in an aptitude test. The marks are given as a percentage. 2.2.1 says calculate the mean obtained by these learners. We know fully well that the mean or the average is equals to the total sum of the data divided by the number of the data points. So what are we saying? We're saying 62 plus 58 plus all the numbers until the last number, right? 92 divided by the number of numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have that summation divided by 15. And then if you put that in your calculator, you're gonna get 74.8667, right? We're gonna round it off to two numbers, so 74.87. And then 2.2 says let's calculate the standard deviation of these learners' marks. So standard deviation, you can do it manually, right? But then it's only one mark, so there's no need to do that. You can just do it on your calculator. If you don't know how to do that with the calculator, you can let me know, and then I can do a dedicated video on how to do that. But then when I did it on my calculator, I'm getting a standard deviation of 16.12, right? And then 2.2.3 says let's calculate the number of these learners whose marks lie more than one standard deviation above the mean. One standard deviation above the mean. So let me just write it here. So we have the mean plus the standard deviation, right? So we want the marks that lie one standard deviation above the mean. So we have 74.87 plus 16.12, and this will give us a 90.99. So how many people got more than 90.99? One standard deviation above the mean, right? The question can also ask you to find people who got marks that are lower than one standard deviation below the mean. But anyway, let's answer the questions we are asked. So let's go to our data and look for those people. So we're looking for everything that is above 90.99. So basically 91 going up. Somebody got 100%. And then here somebody got 92, 90, they don't quite fall in there. And then another 92 here. So we have 1, 2, 3 people who got more than one standard deviation above the mean. So here your answer would be 3 learners. So 3 learners got marks that are one standard deviation above the mean. 2.3 says the final grade 11 marks as a percentage obtained by a group of learners was analyzed the one standard deviation interval about the mean. So below and above, right, was calculated as, and we're given the points then. Calculate the standard deviation for the final grade 11 marks. So we want the standard deviation, right? We are given the mean minus the standard deviation, right? Which is equals to 82.7, one standard deviation below the mean, which is this number here. And then here we are given one standard deviation above the mean. So we are given x bar plus one standard deviation is equals to 94.1. But what we can do here is to find the mean first using these two equations, right? Here we have a plus, here we have a minus. So if we add these two equations, the standard deviation is going to disappear and we're going to be able to find x bar, right? After we find x bar or the mean, then we can just substitute it in one of these formulas and find our answer. We basically solving simultaneously here anyway. So let's say this is equation 1 and then this is equation 2. So we add in the two equations, right? We add in what's on the left together and what's on the right together. So we're going to have x bar minus a standard deviation, right? Plus x bar plus standard deviation, right? This will be equals to 82.7 plus 94.1. So we add in whatever is on the right with whatever is on the left. The equations were balanced initially, so if we do that, the equations must still remain balanced. So x bar plus x bar, or the mean, that will be 2 x bar, and then minus standard deviation plus standard deviation, that will be 0, right? That will be equals to 82.7 plus 94.1, which is 176.8, right? So now we can just say the x bar is equals to, we divide in both sides by 2, we get in 88.4. Now you can substitute your mean in any of the two equations and get your standard deviation. So let's substitute it in equation 1. So we're going to get the mean plus the standard deviation is equals to 94.1. So the standard deviation will be equals to 94.1 minus the mean, right? But lucky for us, we know what the mean is. So we have 94.1 minus 88.4, which is equals to 5.7. 3.1 says calculate the gradient of AB. So here's AB here, we have point A here and point B here, and then the line goes on until point C. But then we don't have coordinates for point A, so we cannot use m of AB is equals to y2 minus y1 divided by x2 minus x1. We also don't have coordinates of C. But then we have the angle of inclination of line ABC, right? So since we have the angle of inclination, we can use tan theta is equals to the gradient of AB, right? We are allowed to do this. From here, we can then say that tan of 45 degrees is equals to the gradient of AB. So the gradient of AB will be tan of 45 degrees is 1. So the gradient of AB is equals to 1. And that's how you do that question. And then 3.2 says show that the value of K is minus 6.
K is the y coordinate of point A, right? And then since we have the gradient of AB, we can use the gradient formula to find the coordinate of K. So what we can say here for 3.2, we can say that the gradient of AB is equals to y2 minus y1 divided by x2 minus x1. Now it's on us to decide which point we take as point 2 and which point we take as point 1. So let's take B as point 2 and then A as point 1. You can do it the other way around, it still works. So the y coordinate of B is minus 2, so we're gonna have minus 2 minus the y coordinate of A, which is K, all divided by x2. x2, the x coordinate of A of B, which is 8, minus the x coordinate of A, which is 4. And then we know that m of AB is 1. That is the gradient, right? So we have 1 is equals to minus 2 divided minus K divided by 8 minus 4. 8 minus 4, that is 4. We cross multiply, we get 4 is equals to minus 2 minus K. Take minus 2 to the other side, you get 6 is equals to minus K. Divide both sides by minus 1, so minus 6 is equals to K. And that is exactly what we are asked to show. So now the coordinates of A, we have 4 and minus 6, right? K is minus 6. And then let's move to 3.2. 3.2 says determine the equation of EA in the form y is equals to mx plus c. So let's look for EA. So here's EA here. EA is said to be parallel to FB, as we can see from the lines. And so fine, let's say 3.3, and then we know that y is equals to mx plus c, so we need m and c, right? But we can find the gradient of EA, right? The gradient of EA will be equals to the gradient of FB, since line EA is parallel to line FB. And then we have the equation for line FB, which is in the form y is equals to minus a half x plus 2. So now at this point, we can say that the gradient of EA is equals to minus a half. Why are we saying so? That is because EA is parallel to line FB. So now we're only left with C, and then we have point A. Don't forget that. So because we have point A, we can substitute it in our equation, and then we can find C, right? So if we sub A, which is made out of 4 and minus 6, we're gonna get minus 6 is equals to the gradient, which is a half, multiplied by x, which is 4 plus c, right? So we have minus 6 is equals to minus half of 4, that is minus 2 plus c. So we take in minus 2 to the other side, we get minus 4 is equals to c. So our equation becomes y is equals to minus a half x minus 4, right? Because we just figured out that c is minus 4, and we have our equation for EA. And then let's move to 3.4. 3.4 and then 3.4.1 says let's find the size of theta, right? So we're looking for the size of theta. So let's go back to our sketch again. Here's theta here. Angle PBA, it's our theta, right? So we'll need to find the size of that angle. What is theta equals to? Let's look at that. Theta is equals to, will be equals to this angle here plus this angle here, right? Because an exterior angle of a triangle is equals to the sum of two opposite interior. So now we can see that theta is equals to angle CPB plus angle PCB. So we have PCB, right? And then why are we saying that exterior angle of a triangle is equals to the sum of two opposite interior, right? So now we can go ahead and try find the size of CPB and the size of PCB, and then we would have theta. So let's look at CPB. So CPB is here. Let me change the color. So CPB is here, right? So how can we find CPB? We know that CPB plus this angle here, right, will be equals to 180 because they're on a straight line. So if we find this angle that I'm circling, then we're gonna be able to find CPB. But then how do we find that angle? Again, we can use the inclination of line FB, right? So again, we're saying that tan of theta is equals to the gradient of a line. We are interested in FB now, so we're gonna have tan of that angle being equals to minus a half, because that is the gradient of that line. So now that angle will be equals to tan arc minus a half, and that is equals to minus 29.5167. And you know, if you get a negative angle, you're supposed to add 180, and that will be equals to 150.4833. So this angle CPB, so CPB will be equals to 180 minus 150.4833, which will be equals to 29.5167, right? Now we can move to angle PCB. So let's look at PCB. So PCB, let me highlight it in green also. So PCB is here. This is PCB. PCB will be equals to this 45 degrees here, right? Vertically opposite angle. So we're saying that PCB is equals to 45 degrees. So now we can find theta. Theta is equals to the sum of the two, which is gonna be 45 degrees plus 29.5167, and that is all equals to 71.5167 degrees. Now let's move forward and find the length of BF. That's 3.4.2. So we want to find the length of BF, right? We know that the length will be given by x2 minus x1 squared plus y2 minus y1 squared, right? Again, in this case, we have to decide which point we take in as the second and which point we take in as the first. So we want the length of BF. Let me just erase some stuff here. So you'll realize that we don't have the coordinates of F. So let's find the coordinates of F first so that we can find the length of BF. So the coordinates of F, we know the x coordinate of F because it's a y-intercept. We can substitute we can substitute 0 into the equation and find the y coordinate, right? So we're gonna have y of F is equals to half of 0 plus 2. So half of 0 is 0 plus 2, that is just 2. So now we have deduced that the coordinates of F is 0 for the x and 2 for the y. So let's take point F as our second point and B as our first point, right? So here we're gonna have 0 minus x of B, which is 8 squared, plus y2, that will be 2, minus 2, that will be plus 4, right? Squared. And then if you put that in your calculator, you're gonna get 4 square root of 5. And then now we can move to 3.4.3. let's look at 3.4.3. It's saying we must find the area of ABF. So let me just highlight ABF. So we have ABF. So we have our triangle ABF here, right? What is the formula for the area of a triangle? The area of a triangle is given by a half side 1 multiplied by side 2 and then sine of the angle. Which angle the angle which the two sides sandwich, right? On a right angled triangle, the two sides that you will usually use will be sandwiching 90 degrees. So that's why it's usually written as just half base times height. But that is not always the case. You can choose to use the other sides as long as you will take sine of the angle the sides sandwich, right? So here for this question, I'm going to take side AB and side FB, right? So if I take those two sides, the angle they'll be sandwiching is theta, right? I already have theta, I already have FB. I just need to find AB, and then I will have the area of my triangle. So now FB, we know fully well that FB is equals to 4 square root of 5. Now let's find AB, right? So AB will be equals to y2 minus y1 squared plus x2 minus x1. So let's take B as our second point, right? So y of B, that is minus 2 minus y of A, that will be minus 6. So we're just gonna have plus 6 here, squared plus x of B, that is 8 minus x of A, that is 4 squared, and then the length of AB is 4 square root of 2. So now we can say that the area of our triangle ABF will be equals to half side 1 4 square root of 5, right? 4 square root of 5 multiplied by the other side 4 square root of 2 sine of the angle the sandwich, right? The sandwich theta, and we just deduce that the angle for theta is 71.5167. So we have sine of 71.5167. So when I do that, I get 22.8 units squared, right? Because it's an area. And then let's move forward and do 3.5. 3.5 says let G be a point in the fourth quadrant such that APBG is a parallelogram. Calculate the size of angle PAG. So we are interested in angle PAG if we have coordinate G on the fourth quadrant such that APBG is a parallelogram. So let's go see how we can possibly do that. So we have A, P, B, and we need G such that APBG is a parallelogram, right? So if G is somewhere here, then we get our parallelogram. So we are looking for PAG. So PAG is somewhere here, right? And then PAG is made up of BAG, which is this angle here, and PAC or PAB, which is the angle here, right? So if we break that angle into two, we can find it using BAG and PAC. So let's pay our attention to BAG first. So angle BAG. So we are looking at BAG, this angle here. This angle here, that's what we're interested for now. We're looking at BAG. So if you pay close attention, you will realize that BAG is supposed to be equals to angle theta, right? Why are we saying they're supposed to be equals to angle theta? PAGB is now a parallelogram. So those angles will be alternate angles. So now we can say PAG is equals to theta. Not only is it equals to theta, it will be equals to 71.5167 degrees, right? So we have found angle BAG. We can then look at angle PAC. So let's have PAC here, right? So let me just erase the information for angle BAG so that we can pay our attention to PAC. So PAC is this one that is left in green right now. So PAC will be equals to 45 degrees. Why am I saying so? Let's look at the triangle PAC, right? So let me just highlight triangle PAC. So here's triangle PAC here. In triangle PAC, angle CPA, this angle here, is 90 degrees. right? And then we already know that this angle here is 45 because it's vertically opposite to this angle here, that is 45. So we have 90 degrees, we have 45 degrees. We know that the angle should add up to 180. Then angle PAC should be equals to 45 degrees, and angle PAC is indeed 45 degrees. So now we can say that angle PAG is 45 degrees plus 71.5167. That will be equals to 116.5167. 4.1 says the equation of the circle centered at S. Yes, S on the diagram is x plus 8 squared plus y squared is equals to 4. 4.1.1, write down the coordinates of S, right? So 4.1.1. We know that the general formula for the equation of a circle is given as x minus a squared plus y minus b squared is equals to r squared. And then the point at the center of the circle will be given by a and b. So for our circle centered at S, the coordinates of S will be given by minus 8 and 0. It just says y squared, right? So that will just give us 0. And then this 8 will give us minus 8 based on this general formula we have, right? And then let's do 4.1.2. 4.1.2 says, show that the diameter of the circle centered at S is 4 units. So what is the diameter by definition? The diameter is equals to 2 multiplied by the radius, right? But what is the radius of our circle? We know that from the general formula, x minus a squared plus y minus b squared shall be equals to r squared, and we're given r squared. So with r squared we can find r and ultimately find the diameter, right? So r squared is equals to 4. Here it is, right here, right? So we say in r will be equals to 2. We take square roots on both sides, right? So d, the diameter, will be equals to 2 multiplied by r, which is 2, and this is all equals to 4. So the diameter is equals to 4 units, and that's exactly what we are asked to show. Now let's move to 4.2. 4.2 says that if it is further given that SR is equals to 8 units, right? So SR is equals to 8 units. Problem solving 101. You have to write down the given information, right? And then R has coordinates minus 8 divided by 5 and 24 divided by 5. Yes, R here. And then 4.2.1 says, let's find the length of EM. So let's denote EM on our sketch. So here's EM. The radius of our big circle, right? So what information do we have? We know that SR is equals to 8 units. We also know that the radius of the small circle is 2 units, right? So we can say SE is equals to 2 units, right? SE is this distance here. We're saying it's 2 units. And then SR, this entire distance, is 8 units. So we can basically find the length of ER, right? And ER will be the diameter, which is 2 multiplied by the radius, and EM is our radius, right? What am I saying? I'm saying that SR, right, and the entire distance from S to R will be equals to SE, the radius of the small circle, plus ER, right? But then you can see that ER is the diameter, right? So it should be equals to 2 multiplied by the radius of the small circle, which is 2 multiplied by EM, what we are asked to find. So in place of SR, we can put 8 units. In place of SC, that's 2 units. And then in place of ER, that's 2 multiplied by EM. So you can see now that EM will be equals to 8 minus 2 divided by 2, right? So 8 minus 2, that is
6, and then 6 divided by 2, that is 3. So EM is 3 units, right? And now we can do 4.2.2. 4.2.2 says, let's find the gradient of tangent FE, right? FE is the tangent of both our small circle and our big circle, right? So we know fully well that the radius and the tangent are perpendicular to each other, right? The product of their gradients will give you -1. So if we find the gradient of ER or the gradient of SE, then we're going to be able to find the gradient of tangent FE, right? So let's find the gradient of SE since we have coordinates S, right? But wait a minute, we don't have the coordinates of E. So how are we still going to find the gradient of SE? The gradient of SE will also be equals to the gradient of SR because it is one straight line from S to E to M to R, right? So the gradient on that line is the same. So we can just use SR to find the gradient of SE. So that will be equals to y2 minus y1 divided by x2 minus x1 by definition. So let's take R as our second coordinate, right? We have the coordinates of R here. So y2 will be 24 divided by 5. And then y1 will be 0, right? Because S rests on the x-axis. So 0 divided by x2 minus 8 divided by 5 minus x1 of S, right? We know that that is supposed to be minus 8. So it will be basically plus 8. Right? And then when you compute that, you get 3 divided by 4, right? But we know that m of SE multiplied by the gradient of the tangent should give you -1 by definition. So the gradient of the tangent will be equals to -1 divided by 3 divided by 4. So that will be equals to -1 multiplied by 4 divided by 3, that is -4 divided by 3. So the gradient of the tangent is -4 divided by 3. And now we can do 4.2.3. 4.2.3 says, let's find the coordinates of M. The coordinates of M. So M is the center of the big circle, right? What do we know up to this point? What do we know about up to this point? We know the radius of the big circle is 3 units, right? And then we know the radius of the small circle, it is 2 units. And then we know the coordinates of S, and then we know the coordinates of R. That's all we know, right? And we sort of know the x value, the y value of our coordinate P, right? So we have to find the coordinates of M using this information that we have. So how can we possibly do that? M and P, they share the same x value, right? That is because if the x-axis touches the circle, then where it touches the circle will be the x value of the center of the circle. And then if it touches it along the y with the y-axis, then the y value will be the y of the circle, right? So M and P, they share the same x value. So if we can find the x value of P, we have the x value of M, right? Now we can say that SM squared is equals to SP squared plus MP squared. So what is SM? SM is SE plus EM, right? So that is 2 plus 3. So we have 5 squared being equals to SP. We don't have SP, but that's what we're looking for, right? So that we can find the x value of P, right? And then plus MP squared. MP squared is EM squared because they are all radiuses, right? From M to E, that's the radius. From M to P, that's the radius. So we have the radius is 3, so we have 3 squared, right? So SP squared is basically 5 squared minus 3 squared, right? So SP will be equals to 5 squared, that's 25, 3 squared is 9, so 25 minus 9 is 16, square root of 16 is 4, right? So SP is equals to 4. But we know that the coordinates of S is minus 8 and 0, right? And then we have P, which is the X value, and 0 here, right? But we know that from S to P is 4 units, right? So what can be the possible value, X value of P here? It should be clear that the only possible value of P such that SP is equals to 4 should be minus 4, right? The descent from S to P will be 4 if the X value of P is 4. So now we have found the X value of our coordinate M. It's minus 4 and some Y, which we do not know. Let's go back to our sketch again. If you pay more attention, you will realize that from P to M is 3 units, right? Because that is the radius, is 3 units. We already know fully well that the Y value of P is 0, right? So if from P to M is 3 units, then the Y coordinate of M should be 3. So the coordinates of M will be minus 4 and 3. Right? And now we can move to 4.3.4. So we have 4.3.4, which says we should find the coordinates of E. So let's just erase some of this stuff. So here's E here, and we are interested in the coordinates of E. Now we have the coordinates of M, and we have the coordinates of R. It should be obvious now that we're going to use the midpoint theorem, right? We're gonna use M as a bait basically to find the coordinates of E, because we know that X of M, since it is the midpoint of ER, right? Why are we saying it's the midpoint of ER? Because from E to M is the same distance as M to R, and they're on the same straight line. So M is the midpoint of ER. So we can say X of M is X of E plus X of R divided by 2. But we know X of M fully well. That is minus 4, right? So we have minus 4 being X of E plus X of R. X of R is minus 8 divided by 5, right? And then everything divided by 2. You cross multiply, you get minus 8 is equals to X of E minus 8 divided by 5. So minus 8 plus 8 divided by 5 is equals to X of E. And then if you put that on your machine, you will get an X of E, which is equals to minus 32 divided by 5. So we have X of E being equals to minus 32 divided by 5. Now we can move our attention to Y of E. We are applying the same idea. We say that Y of M will be equals to Y of E plus Y of R divided by 2. Y of M, that is 3, right? We have already established that. Then Y of E plus Y of R, which is 24 divided by 5. Everything divided by 2. And then now we can cross multiply. You get 6 is equals to Y of E plus 24 divided by 5, right? So we have 6 minus 24 divided by 5 is equals to Y of E, right? So what is Y of E? Y of E will be, if you compute that, you get 6 divided by 5, which makes total sense, right? It's just slightly above 1, because 6 minus 24 divided by 5 should be 1 point something. So now we have E having coordinates minus 32 divided by 5 and 6 divided by 5. And there we go. Let's do 4.3. 4.3 says the circle centered at M, right? Circle centered at M. So we have m being minus 4 and 3. And then now on 4.3, they given you the coordinates of m. Yeah, so it's shifted 1 unit to the left. So let's shift m 1 unit to the left, right? So it was at minus 4, which shifted 1 unit to the left, it will be at minus 5, right? And reflected on the x-axis to form a new circle centered at K. So it is reflected in the x-axis. So when we reflect in the x-axis, let's say we had a point A, right, of coordinates x and y. When you reflect on the x-axis, you get a, x, and then minus y. So when you reflect on the x-axis, you just have to put minus on the y value. So we have minus 3 here, right? Let's erase this. So there we go. We have our new center of the circle, right? The question is asking us, determine whether the point minus 8 and 0 lies inside or outside the circle centered at K. Show all calculations. So we've shifted the circle, right? We haven't changed the radius and everything. So the radius of our circle is still equals to 3, right? So when we calculate, let's name this point L. When we calculate the distance of ML, right? M is our new center, right? If it is greater than 3, then it makes sense to conclude that the point L of minus 8 and 0 lies outside of the circle, because the radius of our circle is 3. And then if it is less than 3, then that point will lie inside the circle. And then if it is exactly 3, then it lies on the circumference of the circle. So let's go ahead and compute ML. So we're saying that ML will be equals to, we know the distance formula, y2 minus y1 squared plus x2 minus x1 squared. So let's just go ahead and sub it in. So we're gonna get y2, let's take L as our second point, so that will be 0 minus 3, so that will be plus 3 squared, plus minus 8 minus 5, so that will be plus 5 squared, right? So we basically have 3 squared, which is 9, and then minus 8 plus 5, that is minus 3. So we have 9 plus 9. So we have the square root of 18 is the same as 3 multiplied by the square root of 2. So 3 multiplied by the square root of 2 is definitely greater than 3, right? So that point lies outside of the circle. So the point is outside the circle. 5.1.1 says, let's determine, without using a calculator, the value of the following. And then we're starting with tan of alpha. We know fully well that tan of an angle theta is equals to opposite divided by adjacent, right? The opposite is the y and the adjacent is the x. So tan of alpha will become the y of our coordinate of interest t here, right? Which is minus 2 divided by x, which is minus 1. So tan of alpha is basically just equals to 2. And then 5.1.2 says, let's find cos of theta. Maybe now you'd want to pause the video and try it out by yourself. Assuming that you did that, we know that cos of theta by definition is equals to the adjacent divided by the hypotenuse. So we have x divided by r, right? We've already established that we're using our point of interest t, right? So x will be equals to minus 1, and now let's find r. We know fully well from Pythagoras that x squared plus y squared is equals to r squared. So x is minus 1, we square it, and then y is
minus 2, we square it, and that is all equals to r squared. So we basically take in the square root of 5 and say n is equals to r. So now cos of alpha will be equals to x, which is 1 minus 1 divided by r, which is square root of 5. And we can move to 5.1.3. So 5.1.3 says cos of alpha plus 45 in its simplest form. So we have cos of alpha plus 45 degrees in its simplest form. Let's not forget, we're supposed to do this without using a calculator, right? Now it will be a good time for you to pull out your trig identities, right? Because we know fully well from definition that cos of A plus B will be equals to cos A multiplied by cos of B minus sine of A multiplied by sine of B, right? From definition. And that's exactly how we're gonna do this question, because there's no way we can compute this as it is without using a calculator or changing it to this trig identity that we're introducing. So now we're gonna say cos of alpha plus 45 will be equals to cos of alpha multiplied by cos of 45 minus sine of alpha multiplied by sine of 45. So what is cos of alpha? We know fully well that that is minus 1 divided by the square root of 5. And then what is cos of 45? That is a special angle, right? That is 1 divided by square root of 2 minus sine of alpha, right? So what is sine of alpha? Again, let's go back to our definitions. We know that sine of theta is equals to opposite over hypotenuse. So that is y divided by r, right? So let's just plug that in. So we're going to have minus y, which is minus 2, and then r, which is square root of 5. And then sine of 45. Sine of 45 is a special angle, square root of 2 divided by 2. And then let's erase this and carry on with our question. When I get to this point, I don't want to solve anything by head, right? I don't want to make any unnecessary mistake. I just put it in my calculator and get my answer, right? So I just did that, and I'm getting 1 divided by the square root of 10. And then 5.2 says that let's determine, without using a calculator, the value of the following expression. We have 2 sine of minus 20 degrees multiplied by sine of 160 degrees minus cos of 40 degrees. So this question, as soon as it says without using a calculator, I'm going to use the calculator first, and then I'm going to get the answer. After I get that answer, I will basically be proving that that answer is true, right? So when I put this on my calculator, I'm getting minus 1. So whatever I do, however I solve this question, I must get minus 1. If I don't get minus 1, there's something wrong I'm doing, right? So let's solve our question. So this is equals to, so we have 2 sine of minus 20 degrees, right? What can you do to 2 multiplied by sine of minus 20 degrees? You can't do really much. So we're just going to have 2 sine of minus 20 degrees. And then we have sine of 160 minus cos of 40 degrees, right? So we've already seen that we cannot do anything to sine of minus 20 degrees. And we need minus 1 some way, somehow. So if we could get minus 1 and minus 2 sine of minus 20, we're going to have our answer as minus 1, right? So we need to take everything else and push it towards 1 and sine of minus 20, right? That way we are getting close
for our answer of minus 1. So what can you do to sine of 160? We know fully well that sine of 160 is basically sine of 180 minus 20 degrees. And then minus cos of 40 degrees. Let's leave cos of 40 degrees like that, just for the moment. So 2 sine of minus 20, that's the same as minus 2 sine of 20 degrees. And then sine of 180 minus 20. So we are in the second quadrant, right? 180 minus 20 degrees. We know fully well that sine is positive on the second quadrant. So we can write that as sine of 20 degrees. And then now let's look at cos of 40 degrees. We know that cos of 2 theta is equals to 1 minus 2 sine of theta squared, right? Here we have 40 degrees, right? So cos of 2 multiplied by 20 degrees is equals to 1 minus 2 sine of 20 degrees squared. So in place of cos of 40 degrees, we can put 1 minus sine of 20 degrees squared, right? So let's go ahead and apply that idea. So here we're going to have minus 1 minus 2 sine of 20 degrees squared, right? And then that will all be equals to. So we have minus 2 sine 20 degrees multiplied by sine of 20 degrees. That will be minus 2 sine of 20 degrees squared, right? Minus, so let's solve that bracket. So we have minus multiplied by 1, that will be minus 1. And then minus multiplied by minus, that will be plus 2 sine of 20 degrees squared. So we have a minus 1 here. Here we have minus 2 sine of 20 degrees squared. Here we have plus 2 sine of 20 degrees squared. So it should be obvious now that our answer will be minus 1. The other 2 will cancel out. Now we can move to 5.3. 5.3 says consider, and we're given an expression, and then we are told to simplify that expression to a single trigonometric ratio. So let's write that expression down. We have 3 cos x multiplied by sine x, and then plus tan x multiplied by cos of 180 minus x squared, right? And then we're supposed to simplify it. So let's see what we can do. That will be equals to 3 cos x. What else can we do? There isn't much. So 3 cos of x, and then multiply by sine of x. Still not much you can do. Plus tan x. You can play around with tan x, right? We know fully well that tan x is equals to sine of x divided by cos of x. So let's put that in. So we have sine of x divided by cos of x. So we just want to see if that will take us anywhere. It's not all the time that when you have tan of x, you must do this. Sometimes you have sine of x divided by cos of x, and you change it to tan of x, right? We just trying our luck. And then multiply by cos of 180 minus x squared. 180 minus x, we on the second quadrant. And on the second quadrant, it's sine that is positive, not cos, right? So here we're going to have multiplied by minus cos of x squared, right? It's only fair. So now we're going to have 3 cos of x multiplied by sine of x plus, right? And then now we can cancel cos of x with 1 cos of x here, right? So we're gonna be left with sine of x multiplied by cos of x, and then we're not dividing by anything because on the denominator we had cos of x and they cancel out, right? Now you might be asking yourself, where did the minus go to, right? It just disappeared. The minus didn't disappear, right? We have a square here, right? We're taking this to the power 2. So if you square anything, the minus has to go, right? Maybe the mistake I did here is that I put it outside. It should have remained here, right? But then that minus is gone because of the square. So now we have 3 cos x sin x plus sin x cos x. So that will basically just be equals to 4 cos x sin x. Look at it and tell me if it doesn't make sense. So now we have 4 cos x multiplied by sin of x. So we can apply another trig identity. In trigonometry, you have to know all the trig identities by heart. There's no other way. So we know fully well that sine of 2 theta is equals to 2 cos theta multiplied by sine of theta. If you multiply both sides by 2, so multiply this by 2, multiply this by 2, you get 2 sine of 2 theta is equals to 4 cos of theta multiplied by sine of theta. And that's exactly what we have here. 4 cos theta sine of theta, but we have x instead, so that will be equals to 2 sine of 2 theta, right? And we have simplified our expression into a single trigonometric ratio. We can move to 5.3.2. 5.3.2. 5.3.2 says write down the range of f of x is equals to the expression we basically had, right? So in place of f of x, we can just put 2 sine of 2 theta, right? And then now we have to go to the basics. We want the range of that function, right? We know that the range of sine theta is -1 and we go up to 1, right? And then if you multiply by 2 here, then the range will also go up by 2, right? Its highest point will then be 2 and then its lowest point will be -2. So here we're gonna have a range. Y will be an element of some -2 to some 2 there. And then we can move to 5.4. Cos 3x divided by cos x is equals to 4 cos of 2x minus 3, right? So the rule of thumb when you solving trig identities is to pick the most complicated side, and then from the most complicated side you reduce it so that you get the simpler side, right? If you pick the side that is more simple, then it's very difficult to complicate it. So which side is complicated between the two sides? The left hand side is more complicated, right? We have a deviation there. It will be very difficult to produce a deviation from this expression, right? So let's take the left hand side and try make it look exactly the same as the right hand side. So what is our left hand side? We have our left hand side being equals to cos of 3x divided by cos x. But there's nothing special about cos of 3x. So there isn't so much manipulation we can do to cos of 3x. So instead, let's say cos of 2x plus x. And then we can divide all of that by cos of x. So now it should be clear that we can play around with cos of 2x plus x because we know that there's something special about that. We've already established what cos of a plus b is equals to. So we'll just go ahead and substitute it. But let me just write it down for the faint-hearted ones. So we're basically saying cos of a plus b, right, is equals to cos of a cos of b minus sine of a sine of b, right? It's on the back of
the question paper when you're writing your exam, right? And then now we have that being equals to cos of 2x cos of x minus sine of 2x sine of x, and then we divide everything by cos of x. But we know for the world that there's something special about cos of 2x, right? And then there's also something special about sine of 2x. But then let's not forget what we're trying to achieve. We have 4 cos square x. We have 4 cos of x squared minus 3, right? So let's break these terms, right? So we're going to have cos of 2x cos x divided by cos of x, and then minus sine of 2x sine of x divided by cos of x. Check it out and tell me if it doesn't make sense. So let's move forward. This will be equals to, so let's change cos of 2x to sine, because on the other hand we have sine, right? And then on our solution there is no sine, so that sine has to disappear somewhere somehow. So we know that cos of 2x will be equals to 1 minus sine of x squared, right? So we're gonna have 1 minus 2 sine of x squared multiplied by cos of x, everything divided by cos x. Cos x. I'm sure you can see now that the division is falling away, right? We've gotten rid of it on this side. And then minus sine of 2x multiplied by sine x divided by cos x. Let's change sine of 2x to something that has cos, so that the denominators can also cancel out, right? And then we know fully well that sine of 2x is equals to 2 sine of x cos of x, and then we're still multiplying by sine of x, right? I'm just running out of space. Everything divided by cos of x. So cos of x cancel out with cos of x. So we are left with 1 minus 2 sine of x squared minus 2 sine of x multiplied by another sine of x, right? So that will be just sine of x squared, right? But our answer has cos of x, right? So let's change sine square x to cos of x. Now, how can we do that? We know that sine square x plus cos square x is equals to 1. So if we do that, we're gonna get 1 minus 2. So we have 1 minus cos of square x, right? Minus 2 multiplied by 1 minus cos of square x. And then if we simplify this, we should get what we are required to prove. So we're gonna have 1, and then we have minus 2 multiplied by 1, so that will be minus 2. Then minus 2 multiplied by cos of x squared, that will be plus 2 cos of x squared. And then the other bracket, we're gonna get minus 2 multiplied by 1, that will be minus 2. Then minus 2 multiplied by cos of x squared, that will be plus 2 cos of x squared. So if we add all that, so we have 1 minus 2 minus 2, so that will be minus 3, right? And then we have 2 cos of x squared plus 2 cos of x squared, that will be 4 cos of x squared. And we've proved exactly what we are required to prove. Let's move to 5.5. 5.5 says that let's determine the general solution of x in the following equation. Which equation do we have? We have 3 to the 2 tan x minus 3 to the tan x plus 1 being equals to 54. So when I see a question like this, I always look for the easy way out, right? Usually the easy way out is writing this 54 in terms of 3, right? If you can write that 54 in terms of 3, then you can just, find a way to drop the bases and then you just work with the exponents. But then it's so bad that we cannot do that, right? So we have to find another way of solving this. So let's say let 3 to the tan x be equals to k, right? Because 3 to the tan x is just a lot to process, but then k is just simple and straightforward. If we do that, we're gonna get, in place of 3 to the power 2 tan of x, right, we're just gonna get k squared, right? You can work that out and see if it makes sense. I think it does. And in place of minus 3 to the power tan of x plus 1, so let me break that down for you first, right? So 3 to the tan x plus 1 is the same as 3 to the tan x multiplied by 3, right? So here we're gonna have minus 3 multiplied by k, and then that is all equals to 54, right? So now we can take 54 to the left hand side. We're gonna get k squared minus 3k minus 54 is equals to 0, right? So now we can factorize this. So we have k is equals to 0. So the question I ask myself when I'm factorizing, which two numbers do I multiply and get this value here, minus 54, and then when I add them I get minus 3, right? Factors of 54 that I can do that with. Those factors are 9 and 6, right? Minus 9 and 6. So we have minus 9 and 6. So k will be equals to 9, or k is equals to minus 6. But what is k? We know fully well that k is 3 to the tan of x, and then we also have 3 to the tan of x on this side being equals to minus 6. This part falls away. It's wrong. It cannot be true. So we are only left dealing with that. So 3 to the tan of x will be equals to 3 squared. Now we drop the bases, right? So tan of x is equals to 2, right? So we can say x is equals to tan arc of 2, right? Tan arc of 2 is 63.43 degrees. But tan of x is not only equals to 2 on that range, is equals to 2 every cycle it completes at some point of time, right? So the right way of writing it, you say that x is equals to 63.43 plus some constant k multiplied by 180 degrees, right? And then 180 degrees is the range of tan, right? And then k should be a whole. In the diagram, the graphs of f of x and g of x are drawn for the interval x an element of minus 180 to 90 degrees. And then 6.1 says, for which values of x being an element of the given interval, will f of x multiplied by g of x be greater or equals to 0? So if we were dealing with exponential or cubic functions, I would suggest we solve this equation algebraically, right? And then see what our answer is. But then when we are dealing with trig functions, it's a bit complicated. We always have to resort to looking at the graph. So here, if f of x multiplied by g of x is greater than 0, then f of x needs to be positive and then g of x needs to be positive, right? Because if one between the two is negative, then the product will not be greater or equals to 0. Yeah, it's either they're both positive or one is positive and the other one is 0. So let's look for an interval where that is true. Clearly g of x is negative here, so this interval can be part of our answer, right? And then at minus 30 it's 0.
So here, this is where it starts getting interesting. And then f of x is positive on the interval we are given, right? So from minus 30 degrees to where the graph ends, the product of f of x and g of x is greater or equal to 0, right? So our answer here will be x is an element of minus 30 to 90 degrees. And then 6.1.2 says, let's look for values of x where g of x is equals to minus 1, right? Let me just erase this and let's look at g of x. So g of x, we're looking for values where it is equals to minus 1. This is minus 1 and this is minus 2. Here at minus 180 degrees, g of x seems to be at minus 1. And where else? Let's just draw a line and see. And at minus 60 degrees, it seems like it's at minus 1. What I'm doing here just gives us an idea of where the point we're looking at is, right? So now what you do, you substitute minus 180 into the equation of g of x and see if you get minus 1. And then you substitute minus 60 degrees on the equation of g of x and see if you get minus 1. And that is exactly what I'm getting. So here, the values of x for which g of x is equals to minus 1 will be x is equals to minus 180 degrees, and when x is equals to minus 60 degrees, right? It's easy to see on the sketch, but you always have to put it in your calculator and see if it is true. So now let's look at 6.2. 6.2 says the y-axis is moved 90 degrees to the right. Determine the new equation of the graph originally called f in its simplest form. So our y-axis is moving from this point here to somewhere here. Moving the y-axis to the right just simply means that we're moving the graph to the left, right? So in a standard format, if you have a graph, h of x is equals to cos of x plus k plus q. If q is positive, you're gonna move your graph up, and then if q is negative, you're gonna move your graph down. And then for the value of k, if k is positive, you move your graph to the left, and then if k is negative, you move your graph to the right. So we're saying that we're moving the y-axis to the right, so we're moving x to the left along the x-axis, right? So based on this general formula, we have a k which is positive, right? So let's look at f of x. F of x is minus cos x plus 1. So let me just write that. So we have f of x, which is equals to minus cos x plus 1. And we want to move this graph 90 units to the left along the x-axis, right? So that will be f of x is equals to minus cos of x plus 90 degrees, right? We're moving it to the left, plus 90 degrees plus 1. Let me just erase this. And then now this is our new equation for the graph originally called f. We have moved it 90 degrees to the left because y is moving 90 degrees to the right. But then the question says in its simplest form, right? So this is not its simplest form, but then if you manage to get here, then you can get 1 mark of the 2. Yeah, now what's left is realizing that cos of x plus 90 degrees is equals to minus sine of x. So if you substitute that back in your equation, you get f of x is equals to minus multiplied by minus sine of x plus 1. So this will be equals to sine x plus 1. We have a 3D diagram here, and the first question, 7.1, is saying show that x is here is equals to 5 divided by 2 cos theta, right? Let's look at triangle ADC, right, where x lies. On triangle ADC, the only thing we know is that this angle here is 90 and then this angle here is 2 theta, and then we have x there. We don't have any other information. But then if you look at triangle ADB, right, we have theta here, and then we have 5, right, a value here, and then here we have 90. So what you want to do in this kind of questions, you want to start with the triangle that has the most information and move towards to the triangle you're interested in. Clearly, triangle ADB has the most information compared to triangle ADC. So let's start from triangle ABD and move towards triangle ADC. How do we possibly do that? Triangle ABD and triangle ADC, they share line AD. So let's find line AD using triangle ABD, and then from line AD we then find a way to find the x. So here on triangle ABD, what we can say that sine of theta is equals to opposite divided by hypotenuse, right? So we're going to have sine of theta being equals to opposite is AD, and then the hypotenuse is 5, right? So if we cross multiply, we get AD is equals to 5 sine of theta. So now let's find a way to use AD to find x. If we had the length of DC, then we would just use Pythagoras, right? Because we have an angle of 90 here. But then unfortunately we don't have, so we're gonna use trig ratios. So we can say sine of 2 theta in triangle ADC, right, will be equals to opposite divided by hypotenuse. What is the opposite here? The opposite is AD divided by the hypotenuse, which is x. So again, if we cross multiply, we get AD is equals to x multiplied by sine 2 theta. So now we have two equations for AD. If we equate these two equations, we're going to be able to find x. So we can say now 5 sine of theta is equals to x sine of 2 theta. So we divide both sides by sine of 2 theta, right? We're going to get x is equals to 5 sine of theta divided by sine 2 theta. This is not exactly what we're looking for, but then if we use the trig identity, sine of 2 theta is equals to sine theta multiplied by cos theta, then we can possibly get there. So now we're going to get x is equals to 5 of sine theta divided by 2 sine theta and cos of theta. So sine theta and sine theta cancel out, and we are only left with x is equals to 5 divided by 2 cos of theta. And that's how you do 7.1. And then 7.2 says calculate the length of BC if it is given that angle BAC is 112 degrees and theta is equals to 30 degrees. So let's look at BAC, right? So we have an angle here BAC, which is said to be 112 degrees. So on triangle ABC, we have angle BAC, we have the length of AC, right, which is x, and we just calculated it, and then we have AB, which is 5. We know from definition that the cosine law says that a squared is equals to b squared plus c squared minus 2bc cos of a, right? So a is the side you're interested in, b and c are the other two sides of the triangle, and a is the angle which is opposite to the side you're looking for. So if we're looking for BC, A here will be 112 degrees, right? So let's apply the same idea. So we can say that BC squared, right, will be equals to AB squared, will be equals to AB squared plus AC squared minus 2 multiplied by AB multiplied by AC cos of BAC. So this will be equals to, what is AB? AB is 5, right? So we have 5 squared
plus AC squared. AC is x, right? And we know what x is equals to. So here we're going to have 5 divided by 2 cos of theta. But we are given theta, it is said to be 30 degrees. So we can substitute 30 degrees here. And then minus 2AB, we're saying that AB is 5. And then AC is 5 divided by 2 cos of 30 degrees. And then cos of BAC, which is 112 degrees, right? This is BC squared. And then you will find that BC squared is equals to 44.147. And then if you take square roots on both sides, you get BC is equals to 6.64 units. When it comes to cycle geometry, getting the keywords right from the statement is the most important thing, because with the keywords, you are then able to answer all the questions. If you're wondering why I'm starting with 8.2, 8.1 was saying let's prove the turn chord theorem, and we've already done that. I will leave the link in the description. In the diagram below, PWRS is a cyclic quadrilateral. So cyclic quadrilateral, I'm writing that down. So we have cyclic quad, and then the circle is centered at O. PSW is an equilateral triangle. So I have triangle PSW, which is equilateral. So when a triangle is equilateral, all the angles are equal. The only way all the angles can be equal is if all the angles are equals to 60 degrees. TW is a tangent to the circle, so we have tangent. And then we have radii OR, right? Radius OR, so let's say radii. And then OW are drawn, and then we are told that W1 is equals to 25 degrees. So all the questions that we are going to answer, we are going to stick to these keywords, except from basic things like angles on a straight line and so on. So 8.2.1 A says determine given reasons the size of S1. So we are interested on S1. Yes, S1 here. So how can we use cyclic quad to determine S1? S1 is not a complete angle, right? So I don't see how we can immediately jump to S1. The next keyword talks about triangle PSW being equilateral. S1 is not in that triangle, so I don't see how we can use that. And then the third point talks about the tangent. We have tangent TW, right? And this is how we are going to determine S1. Look at W5. W5 is between TW and RW. And then at the same time, RW subtends S1. So S1 will be equals to W5. It will be equals to 25 degrees. And why are we saying so? Turn chord theorem. And then let's move to B. B says let's find O1. Again, we're not thinking about anything else other than the 4 keywords we have. Cyclic quad, there's no immediate connection between O1 and the cyclic quad. Angle PSW, O1 is not an angle on PSW, right? So it cannot help us with anything. And then tangent, O1 is at the center of a circle. There is no immediate way that is connected to a tangent, right? Because usually when we're talking about tangent, we're talking about the turn chord theorem. And now the only option we're left with is radii, right? Let's look at how radii can help us. Obviously, OR and OW are equal to each other. So angle R2 will be equals to angle W3 plus W4, right? We're saying that this angle here is equals to this angle here. So now we can say that O1 is equals to 180 minus 2R2, right? Because we're gonna minus R2 and we're gonna minus W3 plus W4. But we know that W3 and W4 is equals to R2.
So minus 2R2. So if we can find a way to find R2 or W3 and W4, then we can find angle O1, right? OW is a radius, right? And it touches the tangent. Where it touches the tangent forms an angle of 90, right? We know that for sure. So now we can see that W3 plus W4 plus W5 is equals to 90 degrees. I'm talking about this angle here, right? But we know what W4 is. We know what W5 is. W5 is 25 degrees, right? So we're going to have W3 plus W4 being equals to 90 degrees minus 25 degrees. And that will be equals to 65 degrees. So now in place of R2, we can put 65 degrees. So we're going to have O1 being equals to 180 minus 2 multiplied by 65, which will be 130. So O1 is equals to 50 degrees. We just stick into the keywords and nothing else. So A has 2 marks, B has 2 marks, and then C has 5 marks. And then now let's do 8.2.2. 8.2.2 says, let's prove that SP is parallel to TW. So we're proving that SP is parallel to TW. Obviously, we don't have coordinates here. So there's no way we're going to be calculating the gradient. We have to do that using angles some way, somehow. So if these two lines are parallel, then this angle here, W1, should be equals to this angle P here. But then at the same time, W1 should be equals to S2. Why are we saying that? To our keyword again, tangent. We're using the tan chord theorem, right? We're sticking to the keyword. So now we can say that W1 is equals to S2. We already said that S2 will be equals to 60 degrees, right? Why are we saying S2 is equals to 60 degrees? Because triangle PSW is an equilateral. So W1 is equals to S2, but S2 is equals to SPW. They are angles on an equilateral triangle, and all those angles will be equals to 60 degrees. And we're done with 8.2.2. We can give a reason and say that they are alternate angles. And then let's move to 8.3. 8.3 says, in the diagram below, a circle centered at O is drawn. H, J, G, and L are points on the circle. Triangle HGL is drawn. HOG bisects GL at M. So we have 90, and then we're given the values of the lengths. And then 8.3.1, if MG is equals to 6 units, so let's denote MG, right? So we are told here that MG is 6 units and OM is X units. So we have X here for OM. Write HM in terms of X. So let's look at HM. So H starts here and then it goes down to M, right? So we want the length of HM in terms of X. HM is basically equals to 2 radius minus mg, right? Because if we're looking for hg instead, then it will just be 2 radius, right? But then the only difference between hm and hg is that hm stops here at m, and then we have that 6 going forward. So hm is basically 2 radius minus mg. But what is the radius? We have OH as the radius, right? But then OG is also a radius. So let's write the radius in terms of OG. So if we write the radius in terms of OG, it will be X plus 6, right? From here at O to M and from M to G. It will be X plus 6. So if we substitute that in place of the radius, we're gonna get 2x plus 6 and then minus mg, which is 6, right? So that will be equals to 2x plus 2 multiplied by 6, 12 minus 6. So HM will be equals to 2x plus 6 units, right? And then now we can move to 8.3.2. Calculate, given reasons, the length of the radius of the circle. So we already know that the radius of the circle is equals to x plus 6, right? So on this question, we can use triangle OJM, right? Let me just clear something so that we can make it more clear. We are looking at triangle OJM, right? We have the radius of triangle OJM, which is equals to the radius of the circle. So that will be x plus 6, and then we have 12 as the adjacent, and then x as the opposite, right? So we know fully well that on a right angle triangle, don't forget the angle here is 90, the radius squared will be equals to x squared plus y squared, right? The other two sides. So what is the radius here? The radius is x plus 6. So we square it, and it will be equals to the adjacent, which is 12. So we're going to have 12 squared plus the opposite, which is x. So we're going to have x squared. So what is x plus 6 squared? X multiplied by x is x squared. X multiplied by 6 is 6x. You multiply that by 2, you get plus 12x. And then 6 multiplied by 6, that is 36. And that will be equals to 12 squared, 144. Plus x squared, right? So look at this. We have x squared here, we have x squared here. So they're going to fall off, right? We're going to be left with 12x plus 36 is equals to 144. So 12x is equals to 144 minus 36. So we have 12x being equals to 108. You divide both sides by 12, you get x is equals to 9, right? But then we're not looking for x, we're looking for r, right? And we know fully well that r is equals to x plus 6. So that will be 9 plus 6, 15. When we do Euclidean geometry, we are guided by the keywords and nothing else. So for question 9, it's saying that in the diagram below, P, Q, R, and S are points on a circle. Clearly, and then PS, PQ, PR are produced to V, T, and W respectively. VT is parallel to SQ, right? And then we know that there's a lot we can deduce from lines being parallel. So that can count as a keyword. So VT is parallel to SQ. And then it goes on to say that SR is parallel to VW. So our second keyword, SR, is parallel to VW. So we must be able to answer all our questions using these two keywords, except from the basics. Things like angles on a straight line, angles on a triangle 80 to 180, angles subtended by the same chord. But these are only the keywords we're going to need to answer this question. So 9.1 says, prove given reasons that TQ divided by QP is equals to WR divided by RP. So where's TQ? So we have TQ here divided by QP being equals to WR divided by RP. Okay, so let's look at the first keyword. The first keyword says VT is parallel to SQ, right? So let's look at the VT. VT is this line here, and it's said to be parallel to SQ. SQ is this line here. If those two lines are parallel, then the sides PT and PV will be divided proportionally, right? In triangle PTV, if QS
is parallel to VT, then the two sides will be divided proportionally. What are we saying? We're saying that TQ divided by QP will be equals to VS divided by SP. We can only say that if we have two lines that are parallel on the triangle, right? They will divide the two sides proportionally. So that's all we have deduced for now. Let's move on and go to our second keyword. Our second keyword says that SR is parallel to VW, right? So let's erase these parallel lines for QS and VT, and let's pay our attention to SR and VW. So where's SR? SR is this line here, and then we have VW, which is this line here, right? So if those two lines are parallel, then in triangle PVW, right? PVW, the two sides will be divided proportionally. WR divided by RP will be equals to VS divided by SP. But then how does that help us answer our question? I want you to realize something here. We're saying that TQ divided by QP is equals to VS divided by SP, and WR divided by RP is equals to VS divided by SP. We know fully well that if A is equals to C and B is also equals to C, then A and B are equals to each other because they are all equals to C. So if we apply the same idea here, we're now saying that TQ divided by QP is equals to WR divided by RP. Why are we saying that? They are all equals to VS divided by SP, and we have proved what we are required to prove. Let's move to 9.2. 9.2 says, let's prove given reasons why TPVW is a cyclic quadrilateral, right? So let's look at TPVW. So we have T here, we have P here, and then we have V, and W is here. And then it is said that we must prove that it's a cyclic quadrilateral, right? So it's a cyclic quadrilateral if those four corners can lie on the circumference of a circle, right? So we must be able to draw a circle around TPVW, and then the 4 points lying on the circle. So let's just construct a circle. It's not really clean, but yeah, this is what we essentially saying when we're saying that TPVW is a cyclic quadrilateral. We should be able to construct a circle around TPVW, and all the points lie on the circumference. So I want you to realize something here. If these points lie on the circumference, then angle T should be equals to, don't forget we have W here. Angle T should be equals to angle W, because they are getting subtended by the same chord PV, right? That's if indeed it's a cyclic quadrilateral. So if we can prove that, angle T is equals to angle W, then we have proved that TPVW is a cyclic quadrilateral. Because if indeed it's a cyclic quadrilateral, then T and V should be equals to each other, because they will be subtended by the same chord PV. So let's find a way to connect T and V using the circle we already have and our parallel lines. Let's go back to the keywords again, because we agreed that for this question, we're only gonna stick with the keywords, right? All questions on Euclidean geometry, you stick to the keywords and nothing else. So the first keyword says VT is parallel SQ. So VT is parallel SQ. If VT is parallel SQ, then Q1, this angle Q1 here, should be equals to angle T. Q1 and T are corresponding angles. So let's write that down for the sake of clarity. So we say in Q1 is equals to T because they are corresponding angles, right? And then let's go back to our keywords. So we've used the first one. We are only left with the second one, right? SR and VW. If SR, let me make SR clear. So if SR is parallel VW, then angle R1 should be equals to angle W, right? They are also corresponding angles. So let's write that down. So we say in R1 is equals to W, but we need the T to be equals to W. So we have to find a way to relate Q1 and R1, right? If we can prove that Q1 and R1 are equals to each other, then T is equals to W. So how can Q1 be equal to R1? Let's look at our diagram. So we have Q1 here, and we say that it must be equals to R1, right? And then indeed it is, because PS subtends Q1 and it subtends R1, right? So now we can say that Q1 is equals to R1 because they are in the same segment, right? So T is equals to Q1, but Q1 is equals to R1 and R1 is equals to W. So T and W are equals to each other because they are all equals to Q1 and R1. So by saying that, we have essentially proved that TPVW, it's a cyclic quadrilateral. When we did question 8 and 9, we realized that you can answer all the questions using only the keywords in the statement. So we're gonna try and apply the same idea to this question. So it says that in the diagram below, BCD are points on a circle such that BC is equals to CD, EC and ED are tangents, right? So tangent is a keyword because we have a theorem that talks about tangent, the tan-chord theorem, right? So I'm going to write that down. I have tangent, and then it goes on to say that BC produce meet tangent DE produce at F, angle B is equals to X. So it seems like the only keyword we have is tangent, right? And this question is out of 17 marks. So we should get all of these 17 marks based on the keyword tangent and nothing else, right? So we're just combining the keyword tangent and just a few basics, the sum of angles on a triangle, angles on a straight line, and so on. But then in the grand scheme of things, we're answering all the questions using the word tangent. So the first one, 10.1, says, so we have 10.1 says prove given reasons that E1 is equals to 180 minus 2x. So 10.1.1, we are asked to prove that E1 is equals to 180 minus 2x. So let's look at E1 on our graph. So here's E1 here, right? And then E1 is on triangle ECD, right? On triangle ECD, we have angle C2 and angle D1. There's nothing else we can do. We have to look at the tangent and consequently the tan-chord theorem, right? Because that's the only keyword we have. If you look at C2, you will realize that it is equals to angle B, right? Because of the tan-chord theorem. Angle C2 is between tangent CE and chord CD. And then chord CD subtends angle X, right? So C2 is equals to X. Why are we saying so? The tan-chord theorem, right? We don't have much of a choice. We only have tangent. So all the questions we have to answer them based on the tan-chord theorem. And then at the same time, D1 is also equals to B, right? Because D1 is between tangent DE and chord CD. And as we've said, chord CD subtends angle B, right? Which is X. So now we can say that D1 is also equals to X. So now you realize that E1 plus C2
plus D1 should be equals to 180 degrees, the sum of angles on a triangle. So now we can find E1 by saying that it will be equals to 180 minus C2 minus D1, which are all equals to X. So it's 180 minus 2X, and then that's how you find E1. Now we can move to 10.1.2. 10.1.2, we still have one keyword, right? Proving that angle E1 is equals to 180 minus 2x doesn't give us any other keyword. So we're supposed to answer 10.1.2 using the tangent again, because that's the only keyword we have. So we're supposed to prove that triangle ECD is similar to triangle CBD. So let's look at these triangles on our sketch. So we want ECD. So here's ECD here, and then we're supposed to prove that it is similar to triangle CBD. So we have C going to B and back at D. So when you're proving similarity, you need two angles to be equal to each other. As soon as two angles are equal to each other, the other two remaining angles will be equal to each other, and you will have proved that the two triangles are similar, right? So the way the examiners name their triangles, right? They name them with respect to the angles that are equal. So angle E in triangle ECD should be equals to angle C in triangle CBD, and then angle C on triangle ECD should be equals to angle B, because it's the second letter of how they name the triangle, right? And then angle D on ECD should be equals to angle D on CBD, right? So let's start with angle E on triangle ECD. So angle E on triangle ECD is here, right? It's E1. We know that it's 180 minus X. So we're saying that that angle E should be equals to angle C on triangle CBD. So it should be equals to this angle, and indeed they're equal, because I want you to realize something. In triangle CBD, right, C3 will be equals to 180 minus 2x. Why am I saying 180 minus 2x? Because B, we've already established that it is x, right? But this angle D2 here will also be x, because line CB is equals to line CD, right? So C3 will be 180 minus x minus x. So we have proved that C3 is equals to E1. Now we can move to the following angles. So we're saying that angle C in triangle ECD should be equals to angle B in triangle CBD, right? So angle C in triangle ECD, it's C2, right? And then we have already proved that it's equals to angle B because of the Tangent theorem. So now we can see that C2 is equals to angle B is equals to X. Why are we saying so? Tangent theorem, right? Now we've proved that two angles are equal in these two triangles. So the third angle, without proving it, already we know that it is equal, because those angles should all add up to 180, right? So now we are basically done. We can conclude that indeed ECD is similar to triangle CBD. Pay attention to the letters next time you solve this kind of problems. It always works. And then let's move to 10.2. 10.2 is saying to us, we have 10.1, which says prove given reasons. So we have 10.2.1 is saying that CD squared is equals to CE multiplied by BD, right? Let me just clear these sketches up so that we can have a bit of more clarity. So we want CD squared. So we want CD squared to be equals to CE multiplied by what? Multiplied by BD. Multiplied by BD. So if you pay attention here, these sides that we're interested in are sides on our similar triangles, right? So we can use the fact that those triangles are similar to find 10.2.1. So we moved from the word tangent, and now we have figured out that we have two triangles that are similar, right? So we can use similarities as one of our keyword, right? But then we're not just taking it out of thin air. We're using it because we have proved that indeed they are similar. So for 10.2.1, we're going to use similarity, which we proved through the tangent theorem, our main keyword. From what we are required to prove, you can see that we some way, somehow need CD, right? And then apart from CD, we need CE and BD, right? So our proportionality should involve those sides, right? From what we are required to prove. So let's start with CD. So we can say that CD divided by something. So CD is the smallest side of triangle CBD, right? So let's say CD divided by BD, right? The biggest side of triangle CBD. And then let's do the same thing on triangle CED. So the smallest side on triangle CED is CE, right? So we're gonna say CE divided by the biggest side on that triangle, which is again CD, right? And then that should be true if the triangles are similar. So now from here, we can cross multiply. So we can say that CD multiplied by CD will be equals to CE multiplied by BD, right? And you will see that CD squared will be equals to CE multiplied by BD. If you take a ratio of the smallest side to the biggest side on one triangle, it should be equals to the ratio of the smallest and biggest on the other triangle, right? It doesn't have to be smallest and biggest in that order. You can do it in any other way. But then as long as you do the same thing on the two triangles, the ratio of the two sides must be equal to each other. And that's how you would do 10.2.1. So the way you justify what I just wrote here is by stating that triangle ECD is similar to triangle CBD, right? And then let's move to 10.2.2. 10.2.2, we are required to prove that CF squared divided by EF squared is equals to BD divided by DE, right? Which is a bit complicated, but it's fine. So CF is not in any of those triangles, so we cannot use those triangles to prove 10.2.2. we have to resort to something else, right? But take a look at this. If line CE is parallel to line BD, then it will be quite easy to say that CF divided by EF will be equals to something, right? But then, are they parallel? Let's look at that. We know fully well that if they're parallel, then we can construct something like this. Not really construct because it's already there, but then this angle C2 should be equals to this angle D2. That's if the two sides are parallel. And then guess what? That's true because C2 is equals to X, and then D2 is also equals to X. So C2 is consequently equals to D2. So by saying that, we've basically proved that CE is parallel to BD, right? Because we have those alternate angles being equals to each other, right? And then now, since we have proved that, we can see that BC divided by CF is equals to DE divided by EF, right? We can play around with things like this once we have proved that CE is parallel to BD, right? We can play around with those ideas, but that's not where we're going. That's not what the question is asking us. We have to look at CF and EF, right? We are guided by the question. So let's say CF divided by EF. and see where that can take us. So if we say CF, right, CF is this line, divided by EF, then we can say CB divided by DE. The two lines CE and BD are parallel, so we can get away with that. So let's see that. So saying that CF divided by EF will be equals to BC divided by ED. And why are we saying that? CE is parallel to BD. We can get away with that. So now we have CF squared and EF squared. We know fully well from grade 3 that if A is equals to B, then A squared should be equals to B squared, right? No questions asked. The other way around is not necessarily true, but then if A is equals to B, then A squared should be equals to B squared. So we can say CF squared divided by EF squared is equals to BC squared divided by ED squared, right? And then that's it. We're still not quite there. What else are we missing? Okay, 10.2.1. Now we know from our sketch that BC is equals to CD, right? So if BC is equals to CD, then BC squared should be equals to CD squared. And we know exactly what CD squared is equals to from 10.2.1, right? So in place of CD squared, we're going to put CE multiplied by BD. Here it is. So now we can say that CF squared is equals to EF squared. And then in place of BC squared, we put in CE multiplied by ED. So here we can have CE multiplied by BD, right? Divided by DE. But we're not, divided by B or DE squared, right? But we're not quite there yet. We need DE on the numerator, right? So that we can lose that square on the denominator. So which one between CE and BD is equals to DE? Let's look at our sketch. So let me remove a few things for clarity. So we know that this angle here is X, this angle here is X, and then here we have X and here we have X. So if we have X here and we have X here, then CE should be equals to DE, right? So in place of CE, we're going to put DE. So we have CF squared being equals to EF squared, which is equals to, in place of CE, we put in DE multiplied by BD divided by DE squared. So DE and DE, we're left with CF squared divided by EF squared being equals to BD divided by DE.